Ready? Okay. So I'm Prashant Sridhar. I'm the product manager for our TV server, and today we're having TV Server Education Day. The main point of this is that we take all the program managers and the dev guys giving presentations on their features so that we can distribute this tape to the field as necessary so that people can get educated on all the internal stuff in TV server, and we can get rid of a lot of the confusion that's around TV server. So this is the agenda for the day. We'll go ahead and Peter Chain's going to give us the overview of TV server. We'll jump through the marketing plan for TV server. We'll go through the plan of record as far as ship schedules and so on. And then we'll get into the features, including the provisioning system, proxy server, and everything else you see here. And we'll hopefully be done within 6 to 6 hours. Okay, so I'm going to turn it over to Peter Chain now to give the TV server marketing plan, or overview.
So I had the great job being able to put together a slide presentation that was made of slides from other presentations. So I can't take a lot of credit for any slide, but I put them together in a really compelling way. So here's Tim Sullivan showed this slide at the office, and I thought it was a good one to start with, since this is sort of the one-sentence way of describing TV server. I won't ask you to say this in unison, but you should sort of know this, love it, love it kind of thing. Just to pick this apart a bit, commercial grade means that in server speak means that we're looking at mega scale. We're looking at the services that are going to run AT&T's interactive service network across the country, and it's a ton of subscribers, it's a ton of traffic. It's people that are watching TV and using these services a lot. That's what we mean by commercial grade. Manageable is a key word because when you sell really large-scale server systems, the guys in the data center need to manage it every day. And if you don't sort of make the claim that it's manageable from the outset, a lot of customers back away from it and say, oh, this is going to require a ton of more people and a ton of consulting, and it's going to be down a lot, so I don't want to deal with it. It is a platform. And by platform, we mean that third parties or cable companies or whoever can build applications on top of it. And throughout today, we'll show you some applications that we've built, and then we'll show you what we're doing to enable others to build applications. TV commerce. So these cable companies are sinking a lot of money into upgrading their networks, buying new set-top boxes, building data centers in some cases, and you need to make some ROI on all this. And TV server will help them do that by enabling them to get more subscriber revenue through transactions or subscriptions or a bunch of things. And then finally, exciting new services. TV server comes with some new services. You'll get them today, including email, some content services, things like internet search. And it's also a platform for a bunch of other services. Some of the services we've thought about, like interactive TV and program guide, based on our web TV experience. And some services, we don't even know what they are because no one's really tried doing this over cable yet. So that's a long version of the elevator pitch. In terms of the goals of TV Server 1.0, so now we think of TV Server as a multi-year, very complex product, but we said, okay, what do we got to do short term to sort of focus and get something out the door? So our 1.0 goals are really to make AT&T, Charter, and UPC happen. Those are the showcases. If we get them to happen, there's going to be a ripple effect where other cable companies will say, wow, these guys invested the money up front, they were the early adopters, and other people will follow their lead. And these people are industry leaders, they have deep pockets, and they have the technical savvy, quite honestly, to make this stuff happen in the year 2000. We know we need to be reliable in the sense that the product can't be down, the services can't be down. We've learned this from the WebTV experience and the fact that most of the TV server development team had their roots in WebTV, will bring this to fruition. So the server just needs to be up a lot. Scalability. So we realize that the number of cable customers is enormous in the U.S. and in Europe, and it's only going to get larger. And we need to scale. Cable companies are not going to invest in the core technology like this if the technology will not scale to their entire subscriber base. So we want to do that. And another thing in TV Server 1.0 is enable other deployments. So we realize that we have 3 sort of showcase customers. We're going to bend over backwards to make them happen and make trade-offs against other customers to make the 3 showcases. And But at the same time, we realized that, come end of 2000, 2001, we want to have other deployments sort of start hitting as well. We don't want to wait another 12 months after the showcases. So we want TV Server to also, enable those other deployments as well. We're going to do that through a variety of features we'll talk about. So some key values, and this is sort of drilling down on that elevator pitch a little more. TV Server presents an end-to-end solution when it's mixed with Microsoft TV Client. So TV Server manages the set-top boxes and the client software on them, and you can get a full reporting and analysis of data. So some features live on the client, some features live on the server, and you need to report on subscriber activity end-to-end. And we do that with TV Client and TV Server together. Integration. So this is sort of an interesting point. Cable companies and network operators, for that matter, already have a bunch of stuff. They have huge data centers. They've invested in technologies over the years. Most of it is not Microsoft technology, or very rarely is it Microsoft technology. And we've built TV Server to integrate with pieces that are already there in some key places, one of which is a billing system. We don't come with a billing system. We produce a pipe that you can plug into someone else's billing system that's already there. And we have a bunch of those interfaces in the product we'll talk about. Scalable and reliable, I've sort of already talked about this. We're doing a lot of stuff on our own in TV Server with failover and some of the things we do on a protocol level to make ourselves scalable and reliable. We're also building on standard Microsoft stuff that's been proven at large scale, or with Windows 2000 and Commerce Server will be proven shortly at very large scale, whether through us or through someone else. And finally, the complete suite of applications. And this is really important because TV Server comes from the heritage of the Web TV service. And the Web TV service taught what users want on television in an interactive service. And we're going to offer that experience and then work with the cable companies over time to enhance it and build things beyond what Web TV built. So here's a very basic architecture slide. Let me just go over this quickly. So sort of start from the bottom up. The standard Microsoft products we're building on: Windows 2000 Server, or I think it's called Advanced Server, SQL Server 7, this is currently shipping, and then we're using Commerce Server 4, which is the next version of Commerce Server that's coming out in 2000. On top of that, we sort of segment the things that TV Server does into 3 levels. Platform services, this is kind of all the core stuff that makes everything else run. Device management, this stuff manages set-top boxes and client software. And user experience, this is also sort of the applications, so the things that you see on the TV. And then finally, we integrate with a bunch of stuff. We can integrate with, as I said, a bunch of existing systems that are already there. We could integrate with content that's already there, email systems. And we can also offer Microsoft content or Microsoft services if a cable customer wants them. But by no means are we tied to Microsoft stuff. Some customers like the fact we offer the whole thing, and some customers want us to stop here, and some customers, even want to plug and play some of these kind of items. So here's even a lower level. Dave already drew this slide a while ago, and we've had a ton of use out of it, I'm proud to say, of how TV can integrate with existing systems. You're definitely in cable accounts going to find people that already have stuff running, including interactive service stuff. So we integrate with them in a number of ways. Here's some core ways that we can integrate. Billing systems. TV Server doesn't come with a billing system. We have an API into one. Customer service systems are going to exist over here. And again, we have some APIs that can integrate the two. Provisioning. So provisioning is a loaded term. It usually means setting things up. When you join Microsoft, Microsoft provisions you for like a @Microsoft.com account, and you get accounts at other systems. Cable companies have that because they provision you for TV, for HBO, for channels like that. We have a provisioning system, and we have a way where they could come together and talk together. Finally, things like monitoring. There's a guy who sits in a data center in a cable company who makes sure that it's running all the time, and that's through the monitoring system. We have a similar service, and you usually don't want the guy, looking at 2 monitors too much or 2 different systems. And it really sucks if people in the data center don't have to learn another system if we can integrate with what they already know. So we're doing that as well. This is another slide that Tim put together for the offsite, and I thought it was a good one because it sort of breaks out the customers of TV Server. And TV Server has, hits a lot of different people in an organization. We've seen that with the showcase customers where, first we start talking to technical people, then the content people, then the business analysts, then the operations people, and then the billing expert comes in, and it takes a number of months to get there. But there's sort of parts of TV Server that touch all of these people. So from a systems integration perspective, we have a great set of APIs, and we have a great set of documentation that someone can take and integrate TV Server with existing systems. The operations people are going to really love the fact that we're reliable, manageable, and scalable. The business management folks or the product managers at a cable company are going to love the fact that, one, we enable revenue opportunities through interactive services, and two, we have incredible reporting capabilities so we can track what subscribers are and are not doing. And then finally, end users. So the cable company's customers are going to love the fact that this thing works all the time, it provides a great feature set, and we're building on the web TV legacy of ease of use and a pretty interesting feature set. So for systems integration, as I said, there's some things we're doing that where TV Server is opening up and letting other systems play with it. So on the provisioning level, customer care, which is customer tools. Email backends is a key one where TV Server doesn't come with an email server. It merely interfaces with an existing one. And if the cable company doesn't have an email system, Microsoft will be happy to provide one for them. And content integration. We're not tying carriage of content with TV Server sales. We certainly integrate with what a cable company already has, or if a cable company doesn't have content assets and they want to use MSN, we're happy to provide that as well. Probably a good example of our integration is Charter. Charter as GoToNet as a content property. They want to integrate that with their interactive service. Another cable company that we're just starting to talk to is more interested. They don't have content assets, probably don't have the Depop Charter, so they're bringing in MSN. I'm going to skip over operations features because I think Jim is coming in to talk about some of this stuff. So end user features. A point of note: TV Server, enables a lot of functionality for the end user. It can also enable a user interface that go along that, built some of the legacy of web TV. Or if a cable company says, no, I want my own look and feel, my own brand, we can do that too. So by no means are we tied to an experience. We have a default one, and you could change it. Business managers like TV Server because we have a data warehouse, which is pretty incredible. It tracks what subscribers are doing on a daily basis and gives you pretty interesting reports. And to provide some ammunition behind the data warehouse, we have many people from the web TV service who basically say that we would not be able to run our business without the data warehouse. We have a pretty amazing advertising system that could target ads and content to a specific user profile. And then finally, we can do something called a walled garden, where some cable companies have the idea where they want to keep customers looking at content and services that they produce. And they don't want people to go out to the open internet. And TV Server can do that by helping people, one, not get out to the internet at a physical level, and two, by producing a content experience that is good enough so people don't feel the need to constantly go out to the internet and look at internet sites. So I think it's it for the overview. I'm happy to answer any questions on what I just said, and many of my answers may be more details coming later today. But I want to make sure that you get a good start on what TV Server is, because it's a very complex product. It's certainly one of the most complex products that I've ever worked with, and there's so many different features and so many different ways it can be configured. Sometimes it's hard to get a handle on. Yes? That's a great question. So the question is, I mentioned a lot about cable. Do we also support satellite, telco, DSL? The answer is yes, we do support satellite, telco, and DSL. The reason I talk a lot about cable is I guess I'm too stuck on the showcase customers because they're all cable companies. But yeah, there's nothing in TV server that will prevent working with another transport protocol. Yes, exact same set of software. Yep.
Just one small point on the content integration. We have a targeted content pipeline which enables you to integrate not only in our own advertising system, our own advertising backend, but also third-party content provision systems. So we should add that last point there. They should put in, sort of like ad pipeline and things like that.
So we're that follow. If someone even has an advertising system, we can integrate with that. Fair point.
So you mentioned that the email UI came from the server. In general, how can you tell which element of UI comes from the client to the server? The kind of web TV homepage look, I think, comes from the client. And then, the help pages, I guess, come from the client. They do it with the server. How do you tell?
By looking at I think one of the beautiful things about web TV is you can't tell. And it's so seamless between client and server. Like on a PC, it's very clear, because usually the thing that's coming from the server is the thing that's slow. On a set-top box, that's not the case, especially of these cable networks. So there's no hard rule. You can pull up some UI and tell. And it also depends on the type of set-top box. Like if it's like a DCT 1000, a pretty high set-top box, you can do more things on the client and some things on the server. If it's a very thin set-top box, like even thinner than WebTV Classic was, you have to do more things on the server because the client can't really do a lot.
I guess my question comes from, if you're talking to an NetApp customer, thinking of just the client without necessarily the server, and you want to say, okay, with the client you get this, but with the server, you get this other stuff, and UI is always a big concern. There should be a base architecture, I would assume.
Yeah, I don't know if we're going to get into that today on the sort of what is in the client, what is in the server.
My suggestion is that one way of answering that is to explain that the client UI is all the UI that needs to be there if the client is not connected to something. It's like when it first switches on, you want to be able to bring up to the TV list that they change channel, watch TV, that's all on the client. At the time you want to connect with some external service, you're most likely to be seeing UI that's pushed up by a server.
That's a good rule. Unplug the client and see what still works. Is kind of the rule. There's also ways of. Yeah, there's also things like satellite boxes, which they work with a server, but the server really just downloads a lot of stuff to the client, and then it works locally. So sometimes that rule may not apply all the time.
It's also important to point out the web application comes from the server. So everything that you see in TV home, email, settings,
Web home, you mean?
Web home, those are all server applications. Anything that you see in TV home, those are mainly clients.
It sounds like
those applications are running on a server, right? All you're really seeing
UI
is
comes
the
from
page.
the server. On the web home, they come from the server.
Right. I think Michael has a good question. I think a ton of people on the Salesforce are going to hit, which is, what if someone just says, I just a client? Because, when people think about the stuff from a PC perspective, they sort of just say, well, I just need some client software. Why do I have to buy your back end when, I could just go out to web pages and. Yeah. Maybe Prashant and I could work on that and come up with, a good response to that, because I think it's a pretty complex response. Yeah. And we've had a lot of customers, like AT&T, for example, that started out saying, we just want your client software. And then when we told them about the server, and it took us a series of months to do that, they said, oh, my God, I want the server. So, we've done that. I don't think we've written it, though. So that's a good thing we should do. That's a good point.
I think the most complete answer is that for the next 6 hours we're going to be hearing about TV server.
So here's your damn answer. It's all day.
You know, the answer is, well, then there's a 6 hours worth of stuff here on your own. You're going to do that by yourself. It doesn't take TV server.
So you don't get, yeah, today's agenda does not come if you just take the client. You just stick them with video and say, you know, you don't get all that stuff. But I think we need to do some slides or a white paper. That's a good point.
I think it boils down to interactive TV, though. Because anything you have today without a service is cable as it is today. The thing that makes it interactive, services you provide. The important thing is this just ain't any old website. It comes with service. Service that has to support millions of users that are basically a captive audience, not millions of users that can periodically, you know, visit your site, like say Microsoft.com. And so to be able to do that in an effective way that provides the same kind of uptime as just a regular cable TV service, you need a pretty sophisticated, basically back office support system that's capable of doing that.
So anything else, just sort of from a general perspective of TV server? So just to kind of put it in some more concrete perspective, it comes on a CD. It has an installation program. You put it in, you double-click on setup.exe, and it will install it. It could run on one server. It could run, be configured to run on many servers, which you want to do if you distribute things and balance load, and make sure that if one server goes down, another one will pick up where it left off. So I mean, it has documentation. It'll probably come on the CD. If you print it out, it'll be very thick. So in that sense, it's a real product. I don't think it's ever going to come in a box, but I'm sure if a customer wants one, we could cook up a box for them. So it's very much like a packaged product. And when you see it running on a computer, it's a series of directories. There's executables and the whole thing. It's probably easier to install than Office 2000.
Okay, thanks, Peter. So, am I on now? Okay, so I'm Prashant Sridharan. I'm the product manager for TV Server, and this is the TV Server marketing plan. So our number one or three top marketing objectives are to establish Micro TV Server as the premier enhanced television platform. And the way we're going to do this is to do everything and to win the showcase deals. And we define winning the showcase deals as deploying to a showcase customer successfully. Not just deploying a service, but deploying a service that they're happy with, deploying a service customers are happy with, and winning that deal. And then we're going to ship on time. And Dave Barry is going to talk later about Plan a Record. And we're going to do everything we can to ship this product on time to the customer with a great deal of quality. Number two, we're going to recruit and engage an active third-party ISV and SI community to support this platform. One of the great things that the Windows platform did is not only did they ship a product, but they shipped an entire community around the product. An entire community of developers who built applications for the product, an entire community of system integrators and solution providers that built an entire service around that product and deploying that product into corporations and so on. We intend to do that with TV Server as well. And the way we can do that is we have to prove to ISVs and SIs that our platform provides the largest revenue opportunity of any interactive television service. So when we compare ourselves to Liberate, when we compare ourselves to OpenTV and so on, we have to prove to these SIs and ISVs that what we're offering is a better product and a better way for them to make money. And through that's primarily through working with both ISVs and SIs. So working with ISVs to build products for this platform. Maybe it's video on demand. Maybe it's a number of applications that we haven't even thought of yet. So working with ISVs to build up value in the platform, and then working with system integrators to prove to them that network operators and customers, end users, will want this kind of service. And then SIs will actually drum up business that way. And finally, we want to establish Microsoft as the leader in enhanced television. And the way we do that is answer all competitive threats with flexibility and quick response. So when Liberate goes into into a NetOp, we have to go in there as well and prove to the NetOp that we're better than Liberate. When Liberate comes out with a new feature, we have to provide that feature or prove that that feature is either irrelevant or we have something better. And we do that very proactively. So everything that Liberate does, we have a competitive response. And then at the same time, we continue to prove that we're a leader, that we're stretching the envelope, that we're pushing this product and this kind of service to a new limit. So our positioning defines our core competence and provides a foundation for all messaging. And Peter talked about this earlier. Microsoft TV Server is a commercial-grade platform that enables e-commerce through a variety of interactive services. And the key elements here are commercial grade. This is a product that the network operators are not going to be scared to deploy. This is a product that they can be assured will run to a degree of satisfaction that they expect. And it enables TV commerce. So it enables network operators and ISPs and end users and everyone else to make money or to spend money using this interactive service. And through a variety of interactive services, such as email, such as video on demand, such as shopping, such as everything else you're accustomed to in the internet, as well as a bunch of things that we maybe even haven't thought of yet. So our primary support for this positioning are the four key elements that Peter talked about earlier. The platform services, which provides a commercial-grade foundation for maintaining and delivering an interactive content. We do this through integration with third-party software that supports the platform message. So again, we're working with ISPs, we're working with system integrators, we're working with solution providers, and we're working with NetOps themselves to provide content for the platform. Through device services, which enable remote administration and maintenance of Microsoft TV client equipment. So when we work in conjunction with Microsoft TV, we're supporting this end-to-end platform message. You know, the network operator is going to deploy 1 million set-top boxes. And so we have in the product the capability to manage and administer all of those set-top boxes. Through a set of application services that provide end users with powerful, compelling applications. And this highlights the TV commerce and interactive services message. So not only are we shipping a platform and shipping a product, we're also shipping a set of services and applications on top of that platform and on top of that product that is compelling enough for the network operator to deploy to end users, for the network operator to make more money, and for the end user to find that TV is more entertaining, more fun, more useful. And then we have a set of configuration and administration services that eases setup and maintenance of Microsoft TV Server and supports the platform message. So, you know, when the network operator deploys the interactive TV service to throughout their system, they'll be able to administer and monitor that very easily. So our naming and branding for Microsoft TV Server creates a consistent image, and it's akin to the Windows logo or Intel inside. Microsoft, we've changed the name from Microsoft TV Pack to Microsoft TV Platform and so on. So what we're saying is always use Microsoft TV Server in demos, code, documentation, presentations, etc. And we've changed the name from TV Pack to TV Platform. So the client portion of the product is called Microsoft TV. The server portion is called Microsoft TV Server, and the overall product is called the Microsoft TV Platform. And we divide up our customers that go after in 4 different categories. The first category is system integrators and solution providers. These are the technical decision makers at network operators, and all they care about is just making this product work. So the dev team is building a product geared towards SIs and SPs. When they build this product, it will get shipped out as a CD to system integrators and solution providers. Those SIs and SPs will be responsible for customizing the product that we give them for the network operator. The network operator is who we're trying to sell to. So in a marketing sense, we go after the network operator and we tell them this is a great platform for you, but you're going to need the aid of a system integrator or a solution provider in order to deploy this platform. So our focus here is twofold. In marketing sense, we're focusing on network operators, convincing them that we have a great value-add product. And then from a development sense, we're focusing on system integrators and solution providers, showing them that we have a product with a great set of documentation, awesome APIs, things that they can add on to. And then we'll provide a lot of messaging towards end users that shows network operators that this makes TV more useful, more fun, more entertaining. And at the same time, in parallel throughout this entire platform effort, we're also going after ISVs and showing ISVs that this is a great product for them to build stuff on top of. So are there any questions? That's the TV Server marketing plan, and that's our overall objectives, our overview for going after Microsoft TV Server customers. There's a lot more detail, so you can always send an email to get those questions. So go ahead.
Not big spot.
Mm-hmm.
You mentioned the competitive materials stuff you're working on. So is that, I know you've hired a firm or something.
So the question is, do we have a set of competitive documentation and competitive materials? Yes. So there will be kind of 3 efforts as far as doing competitive analysis. The first one is a basic competitive analysis. So Edgar filings, going out and finding out, what a basic product positioning is of Liberate, OpenTV, and whoever else happens to come along, whoever else BizDev needs a response from. Right. So things like how do they position their product? What are the features of their product? How do those features stand at Microsoft TV Server? That's the first level. The second level is where we actually hire an outside firm to contact to contact network operators, to contact our competitors, and get a lot more in-depth information about how the product is to install, the technical aspects of the product. How easy is it to build a SCO that interacts with the billing system, and how does that procedure compare with how we would a Microsoft TV Server? That kind of competitive analysis is great for business in lower level meetings. It's also really important for our development team to provide a competitive response to everything we have. And then the final kind of competitive analysis is more of a research effort, where we go out to network operators in a blind manner and ask, what do you need in the product? What kind of TV offerings do you expect to have in the next few years, the next decade, whatever? And all of those things together will allow us to build a better product. But the key things for BizDev, I think, are the first top-level competitive analysis, and then also the in-depth competitive analysis for later meetings. Oh, absolutely. The Liberate competitive analysis, top-level Liberate competitive analysis is finished. Later on, at the end of this presentation, we'll have a URL that we'll publish, and all of these competitive analyses will be on that URL. The OpenTV top-level competitive analysis is in progress, and it should be done by the time this video gets out to the field. Okay? All right, so I'm going to go ahead and turn it over to Dave Berry now.
Okay, introducing myself. I'm Dave Berry. I'm Program Manager for TV Server 1.0. Been at Microsoft since 92, I guess, with a 2-year sabbatical at Cisco. So a bit about networking as well as Microsoft stuff. Nora, I'll introduce now. She'll be doing part of the presentation. Nora Calvillo is also Program Manager for TV Server 1.0. And for the purpose of introducing the faces behind the email, we should be your main point of contact for TV Server 1.0 information. We're your point of contact in engineering land. So now you know the names and the faces. I'm sorry for you. Here we go. The agenda we want to cover very briefly in the last half hour, the next half hour, is give you an overview of the plan of record for TV Server 1.0, explain what features are in the product and its schedule, how to change that plan of record where necessary, and tell you exactly how to contact us. So let's jump right in. First thing I want to set is some expectations about the product. When we're defining our features, I wanted you to remember that TV Server is just a component of a turnkey solution. TV Server itself does not give a network operator a full, television experience. You need your own head-end. Need your own billing system, management systems, EPG listing providers, and all those things. So our product includes interfaces to all those other things. But the system integrator is the person who has to integrate our component with the other thing to get the network operator a complete system. So we're developing our product for the system integrator. We're describing our interfaces. We're describing how to integrate it with the world. We're not describing how to push 1 or 2 buttons and be in the interactive TV business. The SI has to do that to his customers. Okay? So the point is that the customers, the NetOps who use this product, will need to work with system integrators. They may have their system integration group in-house. They can hire MCS. Marketing has a program to recruit and train system integrators. So there will be an army of people available to customers by the time we ship, and it's those people who actually deploy our product as part of the turnkey solution. For showcase customers, the story is slightly different. We have an in-house team called Deployment Engineering, and they are the system integrator for the customers. So we're trying to use as a rule of thumb an interface between engineering and deployment. And that interface looks as much as we can imagine like the interface will be between Microsoft and third-party system integrators later on when we ship. Okay, so as a rule of thumb, if you're in deployment engineering or working with deployment engineering, give us feedback and input about the kinds of API documentation you like, or Are we describing the product in a way that helps you the most? Because as an SI, deployment engineering is our number one customer, and it's their job to work with the end NetOps customer. Okay? So let's dive into what plan of record consists of, and I'll expose the details in the next few slides. The plan of record has a whole bunch of features that are included and not included. We're specifying what we're building, and we're also specifying features considered and have explicitly decided not to include in the product. We have prioritized those features based on input from the UPC charter deployment teams, and come up with a so-called bottoms-up schedule. The release process means that all the features we've defined in our plan of record will be delivered over a period of time. That period of time is called the release schedule. It's driven by when we believe we can actually build features. So the information about when stuff will be ready came from the people building the product. And that's why we call it the bottoms-up process. We created a small specification. In some cases, there are huge specifications, but we made sure that every single feature had this mini spec. It's a sort of two-page document that describes the feature in enough detail so that all developers could give input to how long their features would take to build. We then went through a bottoms-up scheduling process to make sure that every feature in the product had the developer believing in the fact that his schedule referred reality. They could integrate with other components, they could finish their stuff, and we could go code complete at a time that people believed in and can commit to. Then we went to QA and documentation and made sure they could meet those schedules. It's fine if we can deliver a bunch of code by our code complete date, but if it's not documented, it's not going to help anybody. Or if there isn't a resource to test that feature, it's not going to help anybody. So QA and documentation are an intimate part of the bottoms-up scheduling process. Having done that, we had a preliminary version of the plan of record, a bunch of features that we prioritized, a schedule that really believed in across the engineering team, and we then presented that to deployment. At the time we did it, Charter and UPC were the signed deal customers who gave us a lot of extremely valuable input. Actions. Stephen Levy and Quinn are in the room. I'd like to give special credit for the input we got from you guys on Charter. Thank you. And then likewise for UPC. So the point here is that we believe in the process we went through, and all the developers, QA, and documentation folks are bought in what I'm about to present. Okay. So what's in the product? We have a whole bunch of features. There are actually about 72 some odd features on a big list, and that's what we say is the product. They're broken down, the product is broken down into categories of features. So when you see the feature sheet, I actually have a handout here, and we'll be pointing you to the website where that handout lives. It's like a 9-page document. There's a page called Applications. And on that page, there's a list of all the features that are considered applications. So this describes the priority of those features and tells you the owner. So both the dev owner, the QA owner, and the program manager for every single feature is contained in the information in our feature list. And that list is broken down into applications, core infrastructure stuff, which is things like the proxy server, actually, is a good example of something there. You don't really see it in an application, but it has to be within the infrastructure for the product to work. Operational infrastructure is a set of all the features that make the system manageable. The instrumentation, the monitoring tools, the interfaces to things like third-party email provisioning. So you'll see a long list which is considered operational infrastructure. There's another list called content and commerce infrastructure. The content infrastructure is the part of the product that allows NetOps to order content, whether it's advertising or news or sports scores or whatever kind of content they want to get down to clients, and to target that content to specific users. Store user profiles, and we allow the NetOps to say, what type of user gets what type of content. Commerce is really a special case of content targeting because it pertains to advertising. So how to create advertisements, place them within pages in the user experience, and then target which user sees those features. So there's a whole set of stuff called content and commerce infrastructure. Data services is a really important part of the infrastructure. It's the place that stores all the user information, the devices those users have, the kinds of services they're allowed to get, the state of their provisioning, what software is on all their boxes, and so on. So we maintain a lot of information about all the devices, and actually everything above this line depends on that data to work. The data warehouse is a huge feature. It's sort of like a feature on its own. It's something that network operators can use to analyze all the logs generated by clients and by servers. Clients generate logs about time spent on each channel, what was the previous channel, also a click stream for web visiting, and troubleshooting information, crash logs, the ability to analyze any good or bad situations that arise on clients. Same on server applications. The servers are capable of generating a log stream that gives network operators information about, their state of health. Is the highest level thing to say about that. So all of these logs get piped into one huge database called a data warehouse. And at that point, operators can slice and dice the information any way they find useful. Show me the 5 most visited websites by people who spend more than 2 hours a week watching ESPN. And that's a way of finding where to do your sports advertising on the internet. So the data warehouse is really an extremely valuable feature of the product. Globalization and localization applies to the entire product. Nora will be giving you a presentation later on here about exactly the plan to make our product truly international from the ground up. When you look at the feature list, you're going to see then these breakdowns of all of the features. And you'll find that features are prioritized with a number from 1 through 5. 1 means that that feature is absolutely in the product, and we won't slip, we will slip the product to include that feature. Okay, so an example is the cyber and user database. Nothing works if that's not in the product, so it's a P1. If we have to delay the product to finish that feature, we will. A priority 2 is basically the same, except there's a little bit of risk about, does a customer really want that feature, or is a QA resource available? It might be a TBH somewhere on a staffing list. But we believe we can finish it, and it is in the plan of record, and you can assume it will be delivered unless we tell you the plan of record has changed. So that's what a 2 means. 3 means it is at risk, and we have to negotiate with QA and documentation to add the feature to the plan of record, saying it's there, we think it's important, it's under development, but it's not going to be delivered, and unless you stream, then we'll negotiate to add it back to the POR. This information I'm describing is on the sheet that you'll get, and it's also on the website. So I just want to explain that there's a lot of detailed information in there which you need to be familiar with when you're positioning the product to customers. Okay, so I go down to 3. 4 is a priority that says it's not going to be in the product, it's not going to be complete by Code Complete, there are no QA or documentation resources on that product, on that feature, but we think it's quite an important feature and we'd like to add it if we possibly can. So if for whatever reason some slack opens up or a particular developer is capable of working on a feature quicker than we thought, then a 4 is a candidate to be upgraded and made into a real feature. A 5 means it is absolutely not going to be included in the product. So 5 means retail thought about it, retail is definitely not going to be developed for this release. Okay, so the description of our priorities is on the first page of the plan of record document, and you'll find that every single feature on these lists has a priority, so you'll know whether it's in or out of the product. Now, the really key thing is that we believe we are going to finish this product by 131 within engineering. The code will all be written, it will be feature complete every feature on the feature list will be coded and ready to be tested by that date. So it's important to realize that there will be no functionality added after 131. If you look at the plan of record and there's some feature you think your customer wants, we're not going to add it to the product after 131. So make sure to raise the flag like now, like before the middle of January anyway, to negotiate a change to the plan of record. I'll explain the process for doing that. So, okay. The takeaway from this bullet here then is that when we reach code complete, our project will be functionally done. So no new features added until version 2, which is like the year 2001. Okay? And we're not closing the door, and it's going to be hard to work with on that point. There is a process for changing the plan of record that I'll describe. It's really important to understand that we've documented what we're doing by that date, and there's nothing more or less in the product.
So Dave, does that imply that we'll essentially have one TV server feature release a year and that everything else will be maintenance?
So the question was, does that imply that there'll be one TV server feature release per year and everything else will be a new release, maintenance? This is an important question to understand. So whether we release a new product once a year or less than once a year is TBD. That's the marketing. So 2.0 might be late next year, or it might be early in 2000. Nobody knows. And when is 3.0? We know even less. So the question about is it once a year or not is dependent on, what's the delta between 1.0 and what other customers want. How quickly can we do it?
So the 2001, we shouldn't get too worried about that. It's just until next version.
Yes.
Okay.
Thank you. Yes. So yes, thank you. The 2001 was an indication of when the next version could be expected. We're not saying that you should plan on every year being in a feature.
Well, a lot of features can get added through APIs and the extensible model of the system, right?
Yes, thank you. So the content was that a lot of features can be added through the APIs and the customizability of the product, and those features that get added in that way would be work done by customers, system integrators, deployment engineering outside of the product team. So a really important point, this is a platform that customers will add to in the field, and those additions are in no way limited by what we do in 31.
Actually, Dave, before we move on from this slide, I think it's important to understand that the current plan of record and the current schedule, all the POR, the features that are included, are all assuming that we will have the client dependencies resolved by 131. And so currently that's going through their planning process, and this is work in progress sort of thing.
Thanks, Nora. I wish you hadn't mentioned that. Just kidding. Just kidding, yes, it was on a roll. Okay. So here's the server schedule.
All right.
The point Nora made was that this information I'm presenting about the server plan of record is that this is the server plan of record. It does not take into account the client plan of record, because there was no client for us to be planning with till very recently, when the decision was made about which client some of our large customers would be going with. We now have that information and are working very closely with the client team. It's work in progress to evaluate their plan of record and to work features that the server depends on into that client plan of record. When will they be there means when will we have an end-to-end integrated client and server. I will give you a heads up about where that process is going after we've gotten through the server dates. So the exciting news is that as recently as 2 months ago, we shipped a version of TV Server called the Deployment Pre-Release. It is available, it's in the market, and it was intended specifically to enable deployment engineering to start adaptation work in the field with customers. And even more specifically, it has stable billing interfaces. Because the interface between our server and billing systems, we believe, was the most amount of work to do when integrating our stuff with the real world. So the billing interfaces will carry through to future versions of the product. Adaptations between our server and real-world billing systems should be based on this DPR release. That was the purpose of shipping that product. In March, we will have an alpha release of our product. This will be based on the 131 code base, and it will be tested, feature complete. It will be suitable for 1,000 users. It will have a rudimentary level of stress testing, so we know we will support a lot of users. The stability will not be guaranteed. It may be necessary to reboot servers or clients from time to time because it is an alpha level product at this point in time. It's 5 weeks after we first compile everything. So that gives you an idea of how stable it'll be. We're doing our best, and that'll be alpha quality. May is the date for our beta. It'll be more stable. There'll be a lot of bug fixes. It'll be stated to a 100,000 user load. And it'll be a strong beta quality. It'll be something that we believe is the first time a customer can look at that build and start making decisions about when to go commercial production on TV server. The beta will have bugs. But at some point between beta and RTM, we're going to give our 3 showcase customers the opportunity to look at the bug list and decide, which of the bugs perhaps we don't care about. There might be some features that it's okay to implement a little bit later when they're more stable. So if you're Charter or UPC or AT&T, you'll look at the bug list sometime soon after beta. When it reaches a point that there's a build that you think okay for you to go to production on, we will support that as a release for that one customer. So that's what we mean by some interim build here where the date can be driven by the showcase customer. They pick the build, they pick the date, they decide if the bug list is okay for them, and we will support that release.
The new approach to software development is that the customer picks the build, but they think it's RTM for them.
Yes.
We call that ship.
They call it ship. So the point is, this is a new way of releasing software. You get the customer to tell you to ship it. And it's actually a reflection of the high-touch nature of this product. We understand that TV server requires a lot of integration, a lot of contact with the customer. We want to be as accommodating as we can for these 3 showcase customers. The really important thing is we're saying, please don't sell this product until it's a 1.0 product. At that point, it will be a release quality product suitable for any or all customers. This is the version of TV server that we should be selling to anybody other than the 3 showcase people. It'll be tested to 1 million users. Stability will be guaranteed. You can bill on this product. It'll be supported by Microsoft Product Support Service Group. Ms. Michael.
Dave, I thought PSS had supported beta. Is that?
The question was, will PSS support the beta? And the answer is absolutely yes. PSS will support the 3 showcase customers in a beta time frame, but not anyone else. And those 3 customers must upgrade to 1.0 to continue getting PSS support. Okay?
But there will be the ability to do trial quotes. I mean, you can only use different terminology, but in May, the whole process is long for customers.
Yes.
Right? The
Yes.
plan and everything. So
Yes.
you don't wait to engage with a customer in August. You start now. And the whole project plan is lots of steps.
Exactly. So the point was that that life does not begin in August for customers. They have to do a lot of integration work and trials and ramping up their environment, training their customer service reps, and building billing interfaces. That's why we have alpha, beta, and RTM.
When it'd be great to have PSS.
Yeah. Okay. So we're saying that PSS is signed up to support these 3 showcases. Okay. So that was the plan of record. And actually, before we discuss how to change the plan of record, let's address the point Nora raised about how may or may not these dates move based on what client features are available. The MSTV client has a plan of record which has them shipping a product called Beta 2 on 12/17, which is next week. So next week, 12/17, there will be a version of the Microsoft TV client. it is missing some features that are required for it to work completely with TV Server, but it has most of the features. I'm going to say more than 50% of the features in that beta 2 are suitable for it to work with TV Server. So when we go code complete on 131, it's not going to be a completely integrated client. It'll be a delta in time between 131 and such time as the client is fully integratable with the server. We think that's going to result in us being able to solidify the server code base according to the schedule, subject to some features that are going to be outstanding on these dates. And we're going to move these dates so that when we really release to the public our actual alpha, beta, and RTM dates, that those will be dates for an end-to-end usable integrated product, client, and server together, one schedule. Okay? So we are driving as hard as we can towards coming up with those dates. It's, I think, worst case, weeks away, maybe even next week. Okay. So the takeaway is everything I presented is what the server team is going to drive towards as hard as we can. There's a slight delta between the features here and features that will actually work with your clients. That delta will be absorbed into our schedule once there is a nailed down client schedule. And it will result in some movement on these dates. But when we give you the new dates, it will be a real integrated end-to-end client and server with one schedule. So how to change this plan? If you feel there's a really compelling customer we need business with, and there are features that customer absolutely needs that are not on our plan of record, the first thing is to try and convince the customer to postpone that change until post 1.0. And that's because there really is no slack in our schedule for changes. And introducing them is likely to impact the schedule for all showcases and for the broader platform. So if we make any change, introduce any feature to our code base, the whole product is going to be late for all showcases, and the platform will be late. Yes, which means that a lot of people will be really mad, not just the one customer who wants that one new feature. So the first thing is to change the plan of record is to try not change the plan of record. The next thing is, if we can't negotiate away the requirement and we're prepared to accept possible schedule consequences, then product team will try to build the change into the platform in a way that it can be present in all builds. So that's really important. The product team is saying, if there's a change, it affects the entire product. It goes into the platform. We're not going to support a code base that's specific to one customer. That's what deployment engineering is there for, and they understand their role is to maintain the customizations, adaptations, and some additional features that are outside of our core platform deliverable. Okay? So if you want to make a change, understand that it goes into the product for everybody. There are going to be a lot of customers that don't require all those features. That's why we say optionally enabled. Like if there's a killer satellite operator, we absolutely have to be in business with this person. There may be a lot of other customers, like all the cable people don't need satellite support. So satellite support will be optionally enabled for the cable customers. That's what that means. But it will be in the product. So this allows us to keep building and testing a single product and ship something that's release quality. Needing to build and QA more than one release would impact the schedule. So understanding that those are the steps we'd like you to go through and think of before you come to us and say, let's change the feature list. Go through that, and then I'll be able to contact for negotiating the changes with dev, QA, documentation, and others affected by the feature. And Nora is 100% up to speed as well, so both of us are suitable contact people for anything to do with the plan of record. We will drive the change request and make them part of the POR.
Dave, is it accurate to say that for Server 1.0, the showcases that we're going to be looking at for changing the POR will be just the three main showcases that we're working with?
So the question was, will we change the plan of record for anybody other than UPC, Charter, and AT&T? And the answer is not necessarily. If there is a really important strategic customer that Microsoft has to do business with, they could be added to the list of three. That is my understanding. Given that, adding any customer is going to impact the schedule of all customers. Okay?
The other thing to point out too, though, is with those showcase customers, there's a need to accept a willing set of features from even the 1.0 record just to make the base. So
Yes.
I mean, we're not talking about adding features. We're talking about taking out features.
Oh, interesting. Okay. So the point was that
I don't know how you'd add features to.
I think the way of summarizing that is that the plan of record is a superset of all the features required by the 3 showcase customers and other features that we thought were strategic and important to have in the platform for any and all customers when we ship. So yeah, so the point is well taken that for a given trial or a given customer, it's fine to take the product and not use all the features. You can depend on a subset as required for your deployment. Okay? So I'd like to turn over to Nora now, and we'll go through the last few slides. I'm done. Thanks, Nora.
Good, thank you.
On the feature slide that you had up earlier, you mentioned content commerce, and you were talking about commerce providing targeted content ads.
Mm-hmm.
You should note that the default form includes Commerce Server 4.0, and that's what we're based on, which, in addition to just targeting, also opens up a whole slew of possibilities for cable operators to provide their own commerce sites, catalog sites,
Yes.
within their own walled garden. It's, it's a product in its own right. So we should.
I see. Thank you. So the point John wanted added to our discussion about what's in the product is that our product will integrate with Microsoft Commerce Server 4.0. That is in its own right a foundation for building rich e-commerce sites, and that should be, an advertised feature of TV Server. Any NetApp who wants to deploy TV commerce has the full functionality of Commerce Server available to them through our product. I'd also like to build on that point by saying that when you look at the application list, email, search, favorites, content centers, and the stuff we're doing, if it appears to a customer that that list is kind of short and they'd like to see a whole lot of phenomenal, new, cool applications like video on demand or different kinds of commerce, site and walled gardens, the thing to sell them on is that our product, again, is a platform. We're shipping you some reference implementations of apps that get you off the ground and is functional on day one. It's sort of like taking Windows 3.0 when it first came out. It had Write and Notepad and a couple of rudimentary apps that you could actually do something with Windows when you took the shrink wrap off the box. But nobody was pretending that Write was the world's best word processing program. Lots of other companies added powerful word processing programs on top of Windows. The analogy is exactly the same here. TV Server 1.0 is a platform for third parties to build new and compelling applications for NetOps. So our list is short because we want to partner with the world to build thousands of killer TV commerce apps in the future. Okay? Hand over to Nora. Thanks, Nora.
Thanks. All right. Okay, so I'm the localization and the release program manager for TV Server, and I'll just briefly go over the plans for the international versions of TV Server 1.0. So we're going to basically release 7 versions of Server 1.0. They're going to be English, Dutch, Italian, Iberian Portuguese, French, German, and Spanish. The plan is to have Dutch and English available by alpha. Iberian Portuguese will be released 30 days after US RTM, and the rest of the European languages will be released 60 days after US RTM. What we're doing with Japanese is basically we're working with Yoshi Nakayama in WebTV Japan so that he can help us, he and his team can help us do some testing of the US server on Japanese components like Japanese Windows 2000, SQL Server, Commerce Server, etc. They're also going to be helping us to do double byte enabling verification just to find out what areas are not enabled properly for our server. And we're going to be releasing the Japanese version sometime after Server 1.0 RTMs. The time frame is not determined yet. It really depends on Nakayama-san's findings and to figure out really how much additional work is necessary. I'd like to point out one thing, that the plan of record is for us to localize, to translate the web applications, basically all the search, mail, registration, and the rest of the other web applications, and the CSR tool only. We will not be localizing the installer, the documentation, any of the admin tools. All of it will be left in English for Wino. And again, this will be revised post Wino. So that's basically it for the international version. So if you have any questions, let me know now, later. It's fine. And then the last is contact information. How do you guys get more information about everything that's being presented today? And it's actually, everything is posted on TVPAC server. The site is being revised. We're trying to re-architect it to make it a bit more, I don't know, easier to navigate and just easier to access information. So, but everything is being posted there. And there's any questions about where to find information or if something is not there that you need, I'm the contact for that. The program managers, as Dave mentioned, are basically Dave being the lead for, the program manager lead for the Wino version, and I'm the release manager for that. So there's also an alias, TV server leads, that's made up of the server dev managers and the program managers. If you have any questions about anything specific to features, schedule, anything like that, you could send it through that. If you can't go with Dave and myself. There's also another one that's called TV Server Wino Managers, and that's the dev leads again, program managers, QA managers, documentation, deployment leads, and all that. So that's a very good alias also to send information if you're not sure who the contact person is for your specific question. Okay, any questions? Go, thanks. Ben?
Thank you.
Okay, my name is Mike Smith. I'm Program Manager for Data Services, and I sit around thinking about things like data access, provisioning, and integration with external systems and other exciting things. What I'm going to do is talk to you about the TV server provisioning system. This presentation will familiarize you with the provisioning portion, which is an area that generates a lot of questions on the product, and will also give you some new technologies, some of the changes, and I'll mention some of the changes as we go along. For example, TV server provisioning system is a new name to cover what we used to call WADL, the Web TV Data Access Layer or system or whatever you want to call it. And so that's the first change. So it's now the TV server provisioning system, and what I'll do is a lot of meetings I've had in the past with third-party vendors and with some customers, the wording would come up that, we'd talk about provisioning, and then we'd say, it depends on what you mean by provisioning. So what I want to do is start off by talking about provisioning itself, come up with a set of, let's say, a general definition of the term provisioning system, and then we'll talk about the TV server provisioning system. I'll mention what it is in words. There could be a couple bullet slides, and a little bit on benefits of the provisioning system. And then we'll get into architecture, where I'll give you thousands of words in the form of pictures. Pictures worth 1,000 words. And so we'll start high level in architecture and work down into lower level architecture until your head starts hurting. Then we'll talk about service groups and scaling out to large populations of customers, and then a little bit about building events. Okay? And feel free to ask questions as they come into mind, because this is an area that a lot of questions do come up. Okay, provisioning. What I did is when I started out, I decided to look in the Microsoft Computer Dictionary for provisioning. It's not in there. I looked in a telecommunications dictionary, didn't find anything on provisioning. And I searched the web for provisioning. And there are a lot of vendors out there that write software for provisioning, but they assume that you already know what provisioning means. So I looked in the Webster's Dictionary and found these two little bullets amongst many under the term provisioning. One of them is providing, preparing, or supplying for future needs. Okay. The other is preparation or preparatory arrangement taken in advance. A sort of a setup, preparation for something. We use the term provisioning in two general contexts when we talk about TV server. One of them you'll hear mostly BART, and that's in setting up the connection when you're establishing, logging in and connecting to the service. You're provisioning the connection as you're setting up. And there's the other one is a service, and what I'm interested in is service provisioning, where you're actually setting data in specific data stores of service providing systems, such as the TV server database, and you're setting information in there in preparation for future consumption of the service. Okay. Now I want to coin and define a phrase, the service provisioning system, and I call a service provisioning system the infrastructure for which service information is prepared and maintained for an entity such as an account or user or device. The important distinction is provisioning is the preparation part of it. You know, this is the part of setting up, but I'm also including maintain. So when we talk about data services, I'm including that in the provisioning system. So we don't have to say we're calling it provisioning system when I'm talking about provisioning, and also calling it the data server when I'm talking about data systems, data access. Okay?
Quick question. One thing that's still not really clear to me, I've talked to a lot of people about provisioning, but when a client box fires up and it gets recognized and connected to a server, is provisioning happening then, or is provisioning something that has happened before that?
That's the connection provisioning I was talking about. That's where you get an IP address, you have access.
So provisioning happens both before, provisioning is both preparatory and in real time.
Yes, and in fact, when Bart talks about provisioning, that's the providing and preparing for the future need being the connection, the bandwidth, and setting it up to access the service. Mine is more of an arrangement made in advance to set up the placeholders for the user or for account in the database.
And would actually, at least we've had this discussion many times, their view of provisioning is when you phone and say, geez, I wouldn't mind to get it from Google.
Right. And that's the provisioning that I'm interested in and I'll be talking about.
Right. And they have to stick to the whole cycle, so we're actually just one part of that cycle. And we need to keep relating what part of that cycle we are to the whole cycle. If we just talk about it in the context of our little cycle, they don't get it, and we lose the battle there.
Okay, thanks. Okay, so let's talk about the provisioning system, or the TV server provisioning system. I put TPS here, but we don't have any official abbreviations or acronyms. Okay, sometimes we have a version for acronyms, and sometimes acronyms are great, and we want to get many. So here, what the convention I'm taking on is, if you're writing about the provisioning system in some document or in some white paper or something, you can make an abbreviation for shorthand, and you put it in parentheses. But it's not really I don't want to stand and say this is the official abbreviation for the provisioning system. Anyways, TV server provisioning system is a modular and flexible. By flexible, I mean extensible and scalable general provisioning engine. Okay, so we could have, I guess, early on a provisioning system, a custom provisioning system could have been made for TV server that is only interested in the TV server service, but it was decided to build a general engine so that because the service arrays multiple services for the consumers, it's more integrated and more coordinated to have that provisioning done by a single engine. Other examples of provisioning engines would be, we have a customer, AT&T, that's contemplating the use of a general AT&T provisioning engine that we would just connect to. Another one would be Xeon Corporation, used to be called Firstel, has a product called Net Express, and it's only interested in provisioning. So it's a provisioning engine, and we would, gladly tie up with that, with our provisioning engine, and just delegate the provisioning work to them. Anyways, out of the box, the provisioning system provides all service data provisioning and the maintenance needs to operate TV server. Okay? That's not to say that to operate a TV server business, because it doesn't cover billing. It doesn't handle billing things, but you can operate everything right out of the box. And so one of the tasks you would do if you want to operate a TV server business is to integrate your billing system to our system. It provides a simple API to allow access for viewing and modification of service data. Okay, it's a simple object-based API. And this API provides the information, the service data, in logical entities. We call profiles, and a profile is an aggregation of information to a particular class of item. Like, for example, a user profile will have all that information, such as first name, last name, phone number, mailbox name for that particular user. This helps to hide database implementation details, so applications and services that need data does not need to know about the structure of the database, and they don't have to worry about integrity and things like that. And in fact, when you get the data and you're accessing properties of your profiles, you don't necessarily need to know that one of the pieces of the data may have come from a different than the rest of the data. And it allows integrators to add in other data resources, external resources, such as homegrown, in-house, or third-party billing systems, subscriber management systems, and other services like email, directory services, and so on. Okay, now we're going to get into picture. Not very many words. This is sort of a simplified picture of the interaction that's in the world of this provisioning system. What we have is multiple applications and services that are consumers of data, the service data. For example, customer service, the CSR application, home pages, the logon service. And then we have service profile objects, or SPOs. And these service profile objects are those entities I was talking about, the user subscriber profile. And the old name for this thing was TDAL, and before that was WADL. TDAL stood for the TV Pack Data Access Layer. So it's a data access layer, but since you're working with objects, I better name to call it a service profile objects. Okay? And here's examples of objects: devices, users. And then there's a SCO server, which used to be called MAPS. MAPS stood for the MSys Administration and Provisioning System. And so since MSys isn't in the product, we thought it was like a slightly misnomer. And either that or we were naming it. Well, it was really the Microsoft Administration and Provisioning System. But that was kind of a corny name. So this is more appropriately named. It's the SCO server because it serves up SCOs, and SCOs are service configuration objects. These are objects that are concerned with back-end data resources, whereas the service profile objects are concerned with providing data to consumers. Okay? An example of a SCO would be the SQL SCO that comes with out of the box that accesses the internal database, the service database that we have. And you can write custom SCOs to access your billing systems, or email provisioning, and so on. Then these SCOs interact with resource managers, such as a database, an RDBMS, like SQL Server or Oracle or Informix, other subscriber management systems or billing systems, Active Directory, and other services. Okay. And we'll get more into the context picture here. This is a high-level architectural picture of the provisioning system. On this side of the picture, you have consumers of service information or service data, and then here you have managers of or providers of this service information. Here we have examples of applications that TV consumers access, or server components like the registration services that access the initial call setup and connection. They would access data out of here to find, say, information regarding a key to get your session keys for authentication. And then a customer care application, like out of the box we have a CSR tool, which is a canned application, but any other customer care tool that is used to integrate to the system would instantiate provisioning service profile objects, through the use of a broker. So they would object called a broker, and send me a profile on this user with this particular account number or login ID, so on. It would access the SCO server, making its requests to the SCO server. The SCO server would look in and based on the type of object and the action that's required, such as add or update, we'll put together the sequence of steps that needs to be done to execute that job. And a SCO is essentially a step in that job. It may sequence, say, 2 of these SCOs and execute those. And the SCOs worry about how to access all the API information and all the details on how to access the back-end system is encapsulated in the SCO. So that goes run, and whatever operation is executed in that. Okay, a little closer look. This is inside the server now. This is the consumer part again, the applications, and this is the back end part here. These two, and this shows more of the interactions. By these arrows, the arrows mean this entity initiates communications or requests to the other tree. That's where the flow of the arrow is. So an application requests data from a profile object. Profile object would get information out of the profile dictionary that would give it template information on the profile, like what does this profile look like for a particular type. Say, what does the subscriber profile look like? It puts information or receives information from the applicant in an add operation, and then when the application says, I want to add this to the database, the service profile object sends a request to this SCO server. The SCO server takes the request and goes to the dictionary and finds out what are the steps needed to this particular task. Then it sequences the steps and executes them and bundles up the response from each one of those and sends a response back up the chain. Here's where the SCO server manages and sequences the service configuration objects. Here's the depiction of the SQL SCO that you come out of the box, and the custom SCO that you would write for your back-end billing system. For an integrator that's deploying TV server, their task would be to integrate their system into TV server, and here are the integration points, the 3 of them. If you're just going to do say a light level or a high level integration between your billing system and the server, one of the first things you would consider is how would you talk to the TV server. And so you would use the service profile objects in your billing system to send data to the server. You can integrate more tightly by having the server talk back to your billing system. So in order to do that, you have to have some agreement on what is your server going to say or do to activate things in my server. So you would have an API for your billing system, some programming interface, and we have a set of rules that if you follow the rules, if you write a particular type of software fragment or chunk and install it in a certain way, then whenever we need to access your system, this function will be called, and something you'll have control, and you can do what you need to do to execute, say, an add or update or retrieval of data. Does that make sense? Okay.
The only thing I noticed is that you'll have flow into the application.
Into the scope?
Into the application. All in the top.
Well, the flow is, it's a request-response sort of thing. So the application will make a request. Now, response would come back to the application with the data.
Yeah, that's kind of why you have a double.
Right. But this is not to show data flow. It's more to show the who's initiating the transaction or the request. And then the billing system, we also have service profile objects. The broker itself will allow you to throw what's known as billing events. The integrator would define billing events. It would go into the dictionary and these events so that an application can say, well, this event occurred. I'm going to throw this event information to the system. So it's thrown into a billing event store, which is a SQL Server database. It's a table with some management infrastructure in there. For example, we watermark it so that whenever you pull events out of it, you have a place marker so that you would know where we're at, and you can pull new events. We can archive the old events. And the billing system would just retrieve using SQL those events. Okay? Simple billing event model. It's not really real-time events, fast events, because it's a relational database in SQL Server, but it's not real-time in the sense that there isn't a two-phase type of mechanism where responsibility of the event is handed off and and assumed by the receiver. We may work on something like that in the future, but there hasn't really been a demand for that. Okay, so that's the architecture of TV server profile system, provisioning system. Any questions on it? Any curiosities? Okay, so when you're in the booths or whatever, and they're asking you, how do I integrate my systems? These are the 3 things to worry about. writing a SCO to talk to external systems, which is sort of like 20% of the integration work. I mean, I feel that 20 or 30% of the population is going to want to do that level of integration. Most of the integration is going to be that system sending information and commands to the TV server. Okay. All right, service groups. With the provisioning system server, I pictured it earlier, accessing a database. That database can be on the same machine as the provisioning server, or you can have multiple provisioning servers for a larger population, all accessing a single database. Okay? We have, I'm going to introduce another thing called a local routing database, or the LRD. The local routing database will allow you to, will come into context or is useful when you're talking about multiple service groups, because once in a great while you may have the need to access data for a user that's not in this database. You need to find out where to go to get the data. So this is a general service group. So multiple service groups would look like this. You would set up an array of provisioning system servers that accesses a database, a service database. And notice the service database is an external thing to the server, the provisioning server. And then you have multiple copies of the database, and you have the LRD, or local routing database, that would get replicated information from a global routing database. So time, say 95% of the time, most of the accesses on these servers will access the database here. During initial setup, it's about the only time I'd anticipate that you don't know the service group. These servers would have names, so you don't know the service group of a particular user. You do a quick query to the routing database. Most of the time, it will be in this service group, and so you keep that information in the ticket that goes around to different applications. So when an application requests data, it would send with it the service group that it's in, and you would know to access the data out of that database. Once in a while, we may get a request, and the LRD says, "Oh, you're in another service group," and so accessing it because of this replication, you know what service group, and you would access the database here from this particular provisioning system server. Okay, and so this picture can grow and grow and grow to handle millions and gazillions of users. Okay, so that's the provisioning side, service side. Now there's also the billing event store back here in this diagram. Okay, which one? This one? Okay, service groups.
So, maybe this is another picture, but where in the process here are you linking to the operator's provision? The way that things generally get provisioned in a cable operator, for instance, is the customer service rep will do it from their console, right? Mm-hmm. And then that'll feed, depending on how it's architected, it could feed a number of different systems. We're one of those systems that it gets fed to. Mm-hmm. It gets fed to. So we don't show that anywhere, though. We just show our own world, which is within TV service.
Right. This is, right? Yeah. For that question.
You show the billing world, but you don't. In billing, you show the external world, but you don't show the internal provisioning world.
Right. This is just this illustrates the I guess service groups. Service groups is a concept for the database itself. Yeah. So the server, it's relevant to have just the service database here. Right. The question on how do you how does the billing system come into this when you integrate?
Where are all the other provisioning systems?
Okay. Where are all the provisioning systems? Right.
If they're going to turn the HBO channel on, they're not doing it through ours. They're doing it through depending what let's just take an example. The GI, right? So the GI head end, you've got a GI controller, you've got a GI set-top box. They have a provisioning system that says, I want to watch, I phone up and I say, hey, the fight's on, I want to subscribe to HBO, and the customer service rep says, great, when Mr. Nico will turn you on. Boom, right?
Okay.
So they have to actually go in, turn my HBO channel on. That's got to get that's their business system that talks to the GI controller at the end. Then it talks to my set-top box running MSTV, has my set-top box, and turns HBO on.
Right.
So that's one example of an entire event that provisioning that comes through that doesn't use our software, but yet still writes in a sense of
Right.
set-top box.
So I guess the paraphrase that is that the service provider, the cable service provider, has many services, an array of services that they need to provide provision. And I view that in I guess in levels of integration. You know, what levels are the different provisioning systems integrated to the TV server provisioning system? It's either not integrated, it's separate systems, or integrated through a mediating provisioning system that we would talk to, or it is actually integrated into a provisioning server to do some of the tasks. And so for those different ones, the easy ones to talk about would be the ones that aren't integrated. You know, there would be the person that does it would go to another screen and do something else. The ones that are integrated with a general provisioning engine, say from Xeon or something like that, you would have, picture a cloud here, and these servers are accessing that one cloud, and then the cloud is accessing all the other services and provisioning. For an integrated one, you write a particular service configuration object for, say, a billing system, a subscriber management system, you would have an arrow coming out of each of these servers going to that billing system. Okay, and so out of all the servers, and they won't really be organized into service groups unless you build that into the integration code. Right. Well, in the future, currently, that's how the picture would look currently. But in the future, we're going to have this notion of a remotable service configuration object. Station the service configuration option at the billing system, and all the arrows disappear, and any operation that needs to configure it will go and actually execute on that billing system. But for now, it's sort of a distributed thing where all the servers will do the configuration, know about that billing system. That was a good question, by the way. Okay, billing events. Earlier diagram I showed a little cylinder here for the billing event store, way off in the corner. It's a little table. You just throw events in. But for scalability, we have set up is multiple billing event stores based on service groups in general, but they can be by server themselves, and they would do replication to a central billing event store. This is something that an integrator would do, and we would provide documentation and assistance and perhaps some scripts in doing some of the initial setup. And the idea is that billing events would occur throughout this, the service, and as they occur, you get placed in this billing event store, which tracks it by record ID, which is a monotonically increasing number, so you would know if you're missing any events, and you can keep track of it. So you're sort of guaranteed your events in that way. And as it gets replicated to this, there's another tracking number that keeps track of all those. So here, you would access your data, pull it out. There's a watermarking scheme here, and that watermarking gets updated on each of these services. So at all times, the stores have an indicator of what events you've already seen and what events you haven't seen yet. Okay. This is a general picture. You can have individual servers accessing a billing event store. You can have a provisioning system server accessing an event store, or an application server, because the broker itself, the service provisioning object, is file object, sorry, is what's accessing or throwing the events. So the event can actually come from an application server, and put it into context. This service profile object doesn't have to be on the SCO server. It could be on the application server. Okay, that's what I'm saying. So you can have an application server throwing events, and you can also have a client application, a custom-written, Visual Basic application that's throwing events. Okay.
Mike, just out of curiosity, when a client request comes in, where is the first process that
You mean an event that's thrown? The events are sort of just a blob that's grabbed, a string that's grabbed and thrown into a store. So as far as a client request, the request is just throw this event, and the event ends up here. So what's the question?
Well, actually, my question is more relevant to
For service?
you slide previous when you were the slide with service groups.
Okay.
Well, you've got multiple TPS servers, right?
Mhm.
Does that, and you have a SQL server. Does the SQL server determine which of those TPS servers is going to process a particular, or
No, the SQL Server will receive requests and respond to the requests. So this particular server, it's an application that's homed this provisioning system server, will make its request. It's a profile object request for data, and they would request it through ODB or whatever to the SQL Server store. It's the SCO that would know what server to go to.
in a service group, is each one of those TPS servers, are those duplicated, that there are the same services on each one of those TPS servers?
Yes.
Okay.
And they would.
So what determines which server group is going to provide the service?
The complex services infrastructure will do that. So when I access a Sunday as a consumer, I may not necessarily access it the next day. Consuming part of it, but this server, it would go to this database for its data. Okay, and then also in the service group kind of thing, it would look in a LRD in the case that it doesn't know the service group that it has to get the information from. Okay, so this LRD, the question may come up when you look at this is does every request for data result in two separate requests for information? And no, this is just for the exception, the 0.5% of the time where you don't know, like for example in the connection, you don't know what group it's in, and then that's a larger percent of time for that, but going across to another server would be a very small percentage of the time. Okay. Any other questions? Okay. That's
Okay.
Yeah. Len,
Let's go ahead and get lunch and come back, and then Bart's going to.
So there's three presentations here, and I'm going to try and do it maybe in about 45 minutes, which will get us back on schedule. But feel free to ask questions, and I can jump into things. I don't have that many slides, but there are a lot of fairly tricky details of it. So it's the type of thing where I welcome questions and can easily go into more detail on it. So we're going to start off with a section on the proxy and the reformatting. And the first thing that's interesting about this is that we actually are not providing a proxy. We call it the proxy, but if what you're thinking of is something that's designed to be the firewall interface between an internal subnet and the open subnet, that's not what we've designed, and it's not what we're trying to sell. Instead, what we call the proxy is something that will provide content reformatting, walled garden support, both whitelist and blacklist, and has a very highly optimized cache, and it actually is caching the reformatted data. So it is a caching service that has been optimized for TVPAC server and client. And I'll go into more details on all of these. On the content reformatting, there are several things that you want to do with content reformatting. One is that there may be new media types. Someone may come out with a new audio type that our clients currently don't support. We tend not to do client upgrades very frequently, so we may drop the audio support into the content reformatting engine, and it will this new audio format transfer it into some format that the client understands, and then send it off to the client. We'll also use it to change existing content for bandwidth purposes. There aren't many sites that still have large TIFF files on them, but when we run into those sites, we'll take it, repackage it as a JPEG, and send it on down. So you just lower the bandwidth. And even on a cable modem environment, bandwidth is still a shared resources among the other people. You may have limited bandwidth depending on how your cable modem is set up and how much you're paying your cable company. We'll also do this where we can reduce the image resolution to match the screen. We know what you can see on a television screen, and sending a 4,000 bit image that you're going to display in a 300 by 300 part of the screen makes absolutely no sense. So we can go ahead and take care of that along the way. The other thing that's really an interesting feature is to fix broken HTML. There is actually a surprisingly large number of sites out there that send out HTML that does not meet the HTML spec. But if it works on IE and it works on Netscape, then they don't really care about the fact that it doesn't happen to work on our particular client. That's the de facto standard. It works there. Although, even then, there's some interesting things. I know someone set up a website, viewed it on IE, looked great, they left, and then they started getting urgent pages. And it turned out that they had, instead of ending it with a slash at the very end, they'd left that out. And IE happily said, ooh, I think I knew what you're doing, and fixed it up for them. But when they viewed it on Netscape or older versions of IE and everything else, it's just complete garbage. And so people who write HTML pages really should have something that's on the cord. You're about right. Should really have something to view it with, something that's not trying to make up for all these broken web pages. But in any case, when you run into a website with these broken pages, and it's something that causes our client to incorrectly display stuff, we can have the proxy look at that HTML stream, rewrite it to make it obey the standard, and then send it on down to the client. Often then in the next client release, we will modify the client so it can handle that. So this is the type of thing that will show up for a while until a new version of the client comes out, and then you'll go ahead and remove it because now the client can handle these. But it's useful because at the time a customer calls and complains, you can look, understand the problem, and make the change on the proxy to fix it to them instead of having to wait 6 months or 9 months to go through a whole QA cycle for a new client. The other thing we can do is actually improve some of the HTML code as it goes by. So for instance, one of the things we can do is add some images and things like that. If you've played with a WebTV client, you may notice that unlike a lot of browsers where you'll see stuff start to lay out and it'll stretch or shrink as the images start to come in and adjust stuff, we can know the size of everything ahead of time and lay out the page. So that gives a much better user interface, and we can decide how we're going to handle stuff ahead of time. On the content reformatting, if you hear CRF and CRM, what these are referring to is that we actually have a general purpose content reformatting framework that's in the 1.0 release, but we're not documenting it for customer end use. But we are, sorry, not the subscriber, but actually the MSOs. But we are planning on in a 2.0 release documenting this so that MSOs could their own modules here. And what you plug into the framework, content reformatting modules. Some of the ones that we provide are the ones that do image and audio transformation and HTML fix-up. So it's designed to be a general purpose framework, but we're not QAing it and documenting it for the 1.0 release. Okay, before I jump out of content reformatting, that makes sense to people generally? We will look at every piece of content in terms of the data type to see if it's one we want to do something with. So for instance, if we're not going to change a JPEG, then we won't look at beyond recognizing it's a JPEG and passing it on. For the HTML, we actually will look at the HTML stream as it goes, although we can do it on a site-by-site basis. So we can say, well, we know this site is sending broken HTML, so we don't have to overload the proxies where they're parsing every page from every site. So we could, but that tends to overload the server. So we tend to do it specific things where we'll say fix up HTML from this site, and then it will watch everything that comes from that site and fix it, but others it will just pass straight through. That's done by the NetOps of the MSO. And so we will talk about on the one that does the HTML fix-up how you could edit that and add things to the bad list and tell it how to fix it up. On to walled garden. This term, I'm not sure if we can officially use it as a marketing term because some companies seem to think that it's important to them, but I like it because it describes what's going on, and I'll use it, and you guys can decide what you want to call it. In a walled garden mode, you'd route all internet traffic through the proxy. Our clients do have the ability to talk directly to different sites. So if they do that, they, of course, lose content reformatting, and they would also bypass any walled garden interface put it in. We tend to, if someone is supposed to have full access to the internet, tell them to go through the proxy first, but if that fails, let them go directly to the site just because we figure it's better to get something where it might not be perfect than nothing at all. We're actually in a walled garden mode. You can tell the client that they have to go through the proxy when they're talking to any outside site. When you do that, when the client talks with the proxy, it knows the capabilities of the subscriber on that client through the ticket. And I'll talk a little more detail about what's in it later on in the presentation. So based on that ticket, it knows the capabilities of that subscriber, and then it has lists of valid sites. So for instance, it might have a list of KidSafe sites. And if your ticket said that you were restricted to KidSafe sites, it would then look at the URL you were going to, see if it was on that white list. If it is, you get to it. If it's not, you're blocked and you can't get to that site. You could also use that for an email, which is I think what AT&T was calling it for a while. I think they've changed the name again, where you had something where a subscriber who is not paying as much or maybe for free had access to a limited number of sites, Bank of America, Barnes & Noble, Amazon.com, but then if they wanted to get full internet access, they'd have to pay some extra money and could go out to the world. So again, you'd set up this list of sites that they could go to, and then if they tried to go outside of that, the proxy would return a message, in effect saying, you're trying to leave the walled garden, click here. If you want more info, they click here and they go to a page that says, gee, for only an extra $10 a month, you can have full internet access. So this is the upsell that we want to include as part of the walled garden support. We also have the blacklist capability. So for instance, sometimes you want to have stuff in a Surfwatch mode, where you want to say, in general, I want my kid to have full access to the internet. As National Geographic adds a new site, if it's not on the whitelist, still be able to go to it. But in particular, I don't want them to go to all the X-rated sites. So Surfwatch is a company that actually maintains a list of sites that they think is not appropriate, and the proxy will block you from going to any site that's not on that list. If it's not mentioned, you can go to it. So this is not as safe as the KidSafe mode, because if a new porn site comes up, until it gets added to that blacklist, someone could visit. But it does a pretty good job of filtering out sites that people find inappropriate. So I'm just pointing out that we have both whitelist and blacklist capabilities in the proxy.
So in TV Server, we're reselling some form of Surfwatch data, or?
So in TV Server, we will provide a general mechanism that they can pull in that data. We will recommend that they do it from a third-party company, and we will say that we do it with Surfwatch. I believe we actually have a contract where we can give them a limited time period when they get Surfwatch for free. Beyond that, it's their responsibility to negotiate with Surfwatch to go ahead and get their own feed.
There are APIs for that, so that if they wanted to make up their own list, they just plug it in.
Right. And I mean, it basically turns out to, if you give a text file with a list of all the URLs, we'll suck it in and then put it in our own internal format. But yeah, it is important to point out that especially with the blacklist ability, you want monthly updates, and we, Microsoft, are not providing these monthly updates. But we can talk about third parties that do provide that. Another thing that's important, especially for AT&T, is that we can have capabilities associated with each site and send to the client a set of those capabilities. AT&T refers to this as rack. So you could say that some sites are allowed, for instance, to print stuff out on a printer connected to the set-top box, but other sites aren't. So you could have finer grain access control over what sites can access what client functionality. This is sort of a general purpose mechanism, and AT&T hasn't figured out exactly what they want to do with it yet, but they want us to support it. So the proxy will be able to go ahead and support that. Walled garden, that fine for everyone?
This is all included in 1.0.
This is all included in 1.0.
I thought, so fine grain is it's not a function of the browser. It's a function of the proxy.
Sorry, it's a function of the browser, and that the browser enforces it. But how does the browser know what capabilities to allow or not allow? Okay. So the proxy is a central site that knows where the client is, where the browser is attempting to go to, and then we'll say, okay, you're trying to go to Barnes & Noble. Here are the fine-grained access for Barnes & Noble, and give that back to the client. Envision that all of that got downloaded to the client when it first came up, but since that list might be rather large and the client may not have a lot of memory, the proxy is the logical place to do it, because you don't want Barnes & Noble sending that list, because they could say, oh, I want to have every capability, just check all the check boxes. So the proxy is the place that the MSO controls, where they can go ahead and adjust and have that go to the client. Other stuff on walled garden? Okay. So moving right along, on the cache. This is a highly optimized cache. In the U.S. service, it goes up to millions of users. It doesn't do a million users on one cache, but it does have distributed caching capabilities. I don't believe that's necessarily going to be in our 1.0 release, but it is something that we will support in the future. And we're trying to get in 1.0, and we'll see when it makes it or not. In that case, you could actually have groups of proxies, and the clients would share the space among all the different proxies. But it is something we're testing right now in the lab with millions of objects. It really is designed to be a large-scale caching object. And one of the main advantages of this, and one of the reasons why, if people ask you, why aren't you just using Microsoft Proxy or some other proxy, is that we actually get the data after it's been transformed. So that way you don't have to reapply the transformation each time someone's trying to look at a piece of data. There's nothing to say that you couldn't have another proxy serialized with this, so you pre-staged data on that proxy, or you had that available to larger users. There's also nothing that would prevent you from having parallel proxies. If you have both PCs and set-top boxes on the same cable network, you would probably or you would have to point all of the PCs at a general purpose proxy and the set-top boxes at our proxy. So even if someone already has proxies that they're using for PCs, those proxies aren't wasted. They still need them for the PCs. They still need to be part of their network. They would need to add additional capabilities anyway as they start adding set-top boxes. And what we're saying is use our proxy because it's designed to work with clients. We are talking with the proxy team up in Redmond about adding some of these capabilities to Microsoft Proxy. In the future, I could see that happening. But for right now, for the 1.0 release, this proxy works with our clients, provides all these capabilities.
We used to have statistics from the Web TV service that were really good too from our marketing, like the 50% hit rate on the cache, which is really important in international because a lot of the content comes from the U.S. Do we have any sense for, if the U.S. service has gotten bigger, whether the proxy, the caching is still as efficient?
We could check that. Okay. So one of the questions is, what sort of data do we have on how efficient our cache is? In the past, we've had very good data from U.S. service. I think we could get similar data. Maybe Prashant can follow up on that and let people know. We certainly still have all of that data available, so we should just check and see what the current numbers are.
And then how does this work with active server pages? That's what other people say. Well, the pages are all timed out anyway.
So on active server pages, you wouldn't be caching them, but notice, or you wouldn't be caching the actual page. Any images or things like that you'd be caching. So of course, depending on how much HTML it's generating, the caching itself of the HTML pages may or may not be as efficient, but any proxy is going to have that same problem. You still want this for the larger images, the audio, things like that. One of the things people have talked about is even pushing stuff out to the caches closer to the head end. So things that you think people want to do, if you expect streaming video is going to be the wave of the future, you may want to pre-stage it yourself. So I think the fact that we're not caching the HTML from an ASP page, sure, it'd be nice to do, but you can't. So, okay, so finishing up on the proxy and my initial statement that it's not a proxy, what I was putting there is that it's not really designed for the traditional firewall proxy duties. So we haven't set it up so there are multiple network taps and you have one tap on the open subnet and one tap on the closed subnet. We haven't done a lot of additional security verification. This is a machine that you'd want to be putting on the open subnet. There's a bunch of stuff like that we haven't done. But note that it's useful even if you don't have a closed subnet for its caching capabilities, its walled garden support, its ability to do the content reformatting. If it was inside the firewall, we would tend to recommend that it's really the duty of the network infrastructure to set it up such that this would work. So you'd go ahead and set up your routers, for instance, that proxy machines could connect out through the firewall, but the other machines couldn't. And again, this is outbound connections, and you don't have to do the additional security verification. That work in terms of the security of your firewall is done by the network routing equipment that was designed to do. So depending on the user infrastructure and what they want, I just want people hear proxy think, oh, that's the machine that routes me out to the network. And what we're trying to say is, no, you really want to use network routers to do that. That's what they're designed for. Our proxy is designed for the caching, the content reformatting, and the walled garden. Other questions on proxy before I move off it? Yeah.
So that would be a lot more explanation for someone who wasn't skeptical about our version of proxy and their idea of proxy.
Right.
Exactly.
And it's perhaps, in retrospect, we shouldn't have called it the proxy, but we did, and people here we have a proxy, and so I think it's important we explain what our proxy is and what it was designed to do.
caching, all those get lumped into this proxy thing today, but they're not really proxy systems.
Yeah, so
But technically, it is a proxy. It is made to be proxy. It's just that that word has come to mean something more specific to some people.
Yeah,
We aren't that more specific.
Think of it as a caching system with proxy and not a firewall.
Right.
It needs to be explicit that we are not a firewall. That's one of the things the point should be very involved with. Is when it helps to set up the whole architecture, you help them understand they really should put a regular firewall in place.
So I think that summarizes it. It is a proxy, but people have taken the word proxy to mean this huge, enormous thing, and we're trying to specify which part of it we really focus on and which part we believe is the responsibility of the network when you originally set it up.
But would it be fair to say that we recommend this proxy be used as an adjunct to the Microsoft proxy, and that thing does do all the stuff you set out, doesn't it?
But it doesn't have to be that. It could, I mean, I would say, yes, we could work with it, but I wouldn't go and say you have to use the Microsoft proxy. What I would say is that you need to set up your network infrastructure. If you want a firewall, you have to set up a firewall. And we're not the people who set up the firewall. Now, you can get other stuff both from Microsoft and Cisco, but even if you had the Microsoft proxy, you still need routers and everything else. So.
The only thing that Microsoft proxy will buy you, and I'm a big fan of proxy in this case, is that it will give you something basic cache. You can do it to pre-store material, such as moving content out to certain sites at some point in the future. But what you really are looking for at this point is a firewall, unless you're also using a single system and MS proxy will proxy content for PCs. But mostly what MS proxy does is cache. And what will happen is it won't cache anything because it will get hit once, and then we'll cache behind it and get hit again.
I'm not even convinced, and this is a good question for you, Stephen, does Microsoft proxy supply firewall capabilities?
In the sense that the Windows 2000 does the dual NIC and
Okay.
all that. No, I would not, and it's perfectly fine for a trial. I wouldn't go to paying customers without a firewall.
So that sort of explains it. You really, if you want, not all people may want to put their clients behind a firewall, but if they do, they should set up a real network firewall. But again, yeah, I mean, you could put it together, but as Stephen said, if you're going to do this for real with 1 million people out there, do it with the stuff that was really designed for that.
High-end hardware solutions. That's not enough.
Yep. Okay, so other proxy questions? Perfect. Okay, so moving on to the next presentation. We thought it would be useful to talk with you a little bit about some of the client-server interactions. The point of this is to try and tell you some of the things that are different than what you might expect from client-server, where if you think client-server is sort of a PC and a internet service provider, and explain what's different about that with these. And I won't go over the whole set of things that are different, but focus on a few of them that we think provide a much better experience for users based on these things. So the things I was going to talk about in this presentation was the unified login model, some of the two-way authentication we do, and then some of the non-traditional client-server split. And again, there are a lot of other things in this area. I think these are some of the key points when you're talking with people about what Microsoft TV client and server provide that give you some of the expanded functionality that we have available. So the first part on the unified login model, and that is that when someone turns on their client, it will connect to a single site, which we call the head waiter, and that's where a client logs in. They're presented with a user, they present their username and their password, although a lot of the login is based on physical possession of the box. So if you only have one user on a box and that user has no password, it will just connect right through without doing this. Now, when the box first connects, and this is something that we're working on with a combined, with a cable UI, you may want to have some stuff that's available to sort of a household account, something where you don't have to log in as a specific user. So again, HeadWaiter could provide a general purpose, non-password account, which is the household account. And then beyond that, if you wanted to do additional things like mail that required a specific user associated with them, you'd go through the login. But it's a very flexible thing where depending on how many users are on the box and whether the users have passwords, there may be no user interface involved or there may be a lot if they have to select from different people. But in any case, under the covers, what's happening is that the client is going to HeadWaiter. When it goes to HeadWaiter, it will receive back from HeadWaiter a ticket and then a list of services that will honor that ticket. And this list of services actually has multiple machines for each service. And this is one of the ways that we get our availability and also scalability, is that we determine at the time that box connects which services it's going to use, and also give it some redundant services, so if one of them is down, it can use an alternative. I'll go into a little more detail on that. This ticket is an encrypted blob, so the client can't actually read or modify or change the ticket, but the ticket includes who the user is, what their capabilities are, what the encrypted sessions are that are going to be used. I'll talk about that in a little more detail. And the important thing is when a client connects to one of our services, it presents a ticket, and that ticket both identifies the users and gives the capabilities of that user. And this is what I was talking about when I was doing the walled garden stuff with the proxy. That's how the proxy determines who is currently logged on to this box and what capabilities they should have. This is different from, say, the model of you're sitting there browsing the web with your PC and you're going to lots of different sites and you're having to log into each site. The site doesn't know you until you log in. It has to maintain its own database of who you are and what capabilities you have. In this case, it's a very lightweight thing where it's just the client sends out the ticket and boom, you have those capabilities and it knows who you are. This only works with the services that come with Microsoft TV Server. It's not a general purpose mechanism that you could put in Joe Random, service site, integrating into your Apache HTTP. But if you want something like that, you should look at using the Microsoft Passport, which is somewhat similar, but a much more general purpose mechanism. And it's not as tightly integrated, doesn't give you some of the availability and scalability stuff that we get through this mechanism. Anything else on login model?
Is there going to be some, you talked about a house account. One of the things with interactive TV content that I've noticed is if you go through this login, if you're not connected at the time you hit a link, you trip over that. And I'm just wondering.
So the question is, what would happen with this in terms of and I alluded to this a little bit, if you have a household account, when are you forced to become a user and when are you not? And that's something that I think is more of a user interface question than this. We could do it at sort of any level. We could decide we wanted to let the household account for the web, in which case, sure, you could go to all these sites and it would work just fine. The question is, though, if you find a site that you want to save as one of your favorites, should it be saved in the household favorites or specific user favorites? If you go to a site that then does a mail to URL, well, obviously, if you're going to send mail, you need to be a user. My initial thought is that when you started browsing the web, in addition, because depending on whether you have kid-safe, things associated with the account, you may not want some kid who's watching television to just hit a link and suddenly be on the web because you may want to restrict them to the kid-safe account. The first pass I'd do for our first customer ship would be to browse the web. You'd have to go out of the household account and into a specific account. But notice, if you only have one user on the box and they don't have a password, it's completely transparent. They wouldn't even notice that it happened. It's only when you have multiple users, and we could even look at only if you had multiple users and some of them had restricted capabilities. I mean, that's where it gets hard, is you have to look at, what you're really intending on doing. We could support any and all of that, but it really becomes a question of what's the user experience that they want to give their customers. So from TV server, it's not a problem. It is a problem, and I don't think anyone has really thought through the full implications of this and what they entail and what they mean. Okay, so moving on from here, the two-way authentication. One of the things that we do, and this is fairly low-level detail, but I think it gives you some idea of, if people hear, oh, I hear that you guys encrypt stuff, why are you doing that? Why not just use BPI, which is built into DOCSIS? Well, BPI, first of all, only encrypts from the cable modem to the CMTS. If you're going any sort of long-haul network or any sort of IP traffic, it's not encrypted over that section of the communication link. In addition, BPI is an optional part of the DOCSIS standard. I believe that the cable modems that are going into the DCT-5000s will all have it, but some customers may have cable modems that don't actually have BPI. So we have a end-to-end encrypted channel that will go ahead and give you that security regardless of whether you have BPI, didn't have BPI, whether you were going over some part of the IP network where you wanted stuff encrypted or not. We do the end-to-end encryption. That gives you the privacy. But perhaps what's even more important is it provides a very light way of getting two-way authentication. This two-way authentication means that the server knows that it's an authorized that's talking to it, and the client knows that it's talking to part of the MSTV service and therefore can trust it to do things that it wouldn't trust any random website. So a good example of that is that because the client trusts the service, it can allow the service to modify its NVRAM, update EPG listings, reboot itself, remove pages from the client cache, and this can give us much better user experience. For instance, when you're viewing mail, normally you have to hit refresh to see if any new mail has showed up in your inbox when you're sitting on that page. We can go ahead and automatically remove that page from cache, forcing a refresh when a new mail message arrives. So there's a lot of stuff that we can do because we have this two-way trust between the client and server that's provided by this light two-way authentication. And I'll talk a little bit more in the details of how we do it if anyone's interested, but the nice thing is, SSL, first of all, is not two-way authentication. It's only one way, and it's a quite expensive protocol. It involves multiple round trips on the way up, and it's a fairly expensive encrypted connection. This, because it's based on keys that are already present on the client and server, is a very lightweight encryption that involves no extra round trips. You just start encrypting it and sending out the data. And in addition, this means that the service can trust that that's a client where they've paid their bills and everything's okay, because they wouldn't have received the ticket from Headwaiter if they weren't an authorized client. So it's a nice way of knowing that each service they connect to, be it mail, favorites, whatever, doesn't have to re-query the billing system and database to see, is this user still okay? But based on the presence of that ticket and then that ticket provided over the encrypted connection, it knows that everything's working. So a little more detail than you may want to know, but I think it's a useful feature, and if people start asking about security and encryption, all of that, it's useful background information. The other thing I alluded to is some of the client-server split. And that is that because we have in both the client and the server, we can move functionality around from where it may take place on a traditional PC ISP system. So for instance, we can go ahead and store the cookies and favorites on the service instead of on the client. Some of the advantages of that is it allows for cheaper clients. You don't have to have local storage, better availability. If that client dies, you can throw it in the trash, get another client, bring it out to your home, and it still works. All of your cookies, all of your favorites, anything else you've set it up is still there. It also can allow shared access if you have multiple boxes in the home. If you favorites list, that favorites list can be available on any of your boxes. For those of you, with the PC, you have your favorites list and your favorites list at home, and it's always that the machine you're on doesn't happen to have the favorite that you'd stored because it was on the other machine. This way, it's stored on the server. It's provided, no matter where they're coming into the service from. We can do some optimized. We can do some optimizations because we know what the client is. This is some of the proxy content reformatting work. And it allows you to centralize some of the expensive shared resources with the backups, upgrades, things like that. So there really is, by having both the client and the server, we think you can provide a better end-to-end experience as a whole package. Questions? Yeah? There's not a benefit to the subscriber in their home. It's completely transparent to them. The main benefit to the MSO, the customer that we're selling it to, is that it allows a lot of the capabilities that come with our system. Without doing that, if we did some of this, we, for instance, could enable those client functionalities without worrying how do you trust whether the site you're talking with should be able to modify your NVRAM. So you could, without those, you would have a lot fewer things that you could do with the client, so the overall experience that you saw would not be the same. So for instance, you can connect one of our clients in an OpenISP mode to just random ISPs. But when you do that, these client functions aren't available because there's no way we can know whether we trust those or don't trust them. So it's sort of an underlying, some underlying technology that enables a bunch of nice things on top of it. It's not really something I see as a direct selling point, but it's more if people start asking about the security of the connection and what you could do with it, I think that's something you could bring up and explain. I would, as a selling point, I'd look much more at what it enables on top of it. That you have this trust relationship between the client and the server and can therefore do all of these additional things. It provides this at a much lower cost in terms of number of round trips and amount of bandwidth that's taken up. But again, that's not really a visible feature, except as you try and scale up to 1 million users, it means you're making better use of your network. Is that sort of, it's sort of a funny feature, and I wasn't sure I really wanted to go into it, but I decided it is important because people hear about it to understand what's down there. Okay? Okay, so the client-server split is moving into another area I've labeled initial connection and logon. This, again, sort of a description is an interesting area because what I'm going to cover here is sort of the process that happens from when a box first comes from a manufacturer until it's to the point where it's in the customer home and they're just using it on a day-to-day basis. There's a lot of detail here. Please sort of interrupt me and stop me as you have questions as I go. It's, I think, important to understand the process because we help deploy this to customers and set it up. They need to have some understanding on which parts we're responsible for, which parts they're responsible for, how the process works, what the security is involved with it. It ties in somewhat to what Mike was talking about on the provisioning earlier, and I'll point out places where we start talking with the database. But this sort of covers the whole flow scenario of what happens. Again, it may not be directly applicable to what you're doing, but I think it's a useful background to understand what's happening on this. So when the first thing happens is a customer is going to call their customer service rep and say, I'd like to get this new set-top box. I've heard great things about it. Give me one. At that point, they're going to talk with the customer service rep. They're going to give their name and address and billing information and data like that. And the customer service rep is going to create an entry in the database that includes a work order number associated with that new customer. This will go through some of the stuff that Mike was talking about, where it will provision the billing system, it will get into our service, and any other people that need to get that information at this point. So at this point, within our database, we have a record of other people may have records in their databases depending on how it's set up. But this is being done over the telephone by the customer service rep. Next thing that happens is a technician is going to go out to the customer's home with a set-top box and the work order number. And he's going to set up that set-top box in the customer's home, fix up the RF cables in the customer's home because inevitably they have all sorts of splitters and they have bad signals on it. So almost basically my understanding is that all of our current customers are planning on a truck roll because they believe that the cable infrastructure in the customer's home is almost never correct for what they're trying to set up. He will, at this point, pull a set-top box out of his truck and notice it's any random set-top box. Up until this point, we don't know which box that customer is actually going to get. At this point, he takes the top box from the stack, he's gone into the home, he's cleaned up the RF, and he goes ahead and turns it on. At this point, the set-top box is going to power up. It's going to talk over the radio frequency coax cable to the CMTS hub. And it's going to go through the DOCSIS protocol of coming up. That will include some low-level RF stuff, and it gets to the point where now it's going to talk IP traffic. At that point, it's going to send a DHCP request looking for an IP address that will come down to the DHCP server associated with that CMTS, and will return an IP address to the set-top box. At this point, the set-top box is up and running and is available to talk to other people on the net. Yes, Dan? CMTS is the cable modem termination system. It is a box that is in the cable operator's head end, and what it does is it mixes IP traffic and video traffic and sends it out to the customer. So that's the point at which you would be merging video streams and IP traffic out to the customer's home. And DOCSIS is one of the two competing protocols for talking to CMTSs from a cable modem to a CMTS. The other protocol is the DVB-C, I think, which is also known as DAVIC, which is the European standard. All PC is actually using this. So DOCSIS is way further along than the DAVIC/DVB-C, but Europeans are trying to force that as another standard. So From our point of view, we actually don't care, because what we care is that from TV server point of view, we don't care. The client cares. They have a cable modem. From our point of view, though, all we care is that the client comes up, gets an IP address, and can talk with us. So right now, the client, the set-top box is up at the point it has an IP address and it can start talking with people. The first thing it's going...
Sorry, the cable modem is inside the FTD.
Yeah, the set-top box has a cable modem built into it. But that's actually not required. I mean, different manufacturers might make it so it's an external cable modem. We don't really care. There's a cable modem and a set-top box, and often they're integrated. In the DCT5000, they are. So at this point, the set-top box is going to go and talk with a new box service. This is part of where it's a little bit fuzzy because it depends on what the customer wants. That new box service may be part of the hub provided by the CMTS vendor, so Cisco's C-Source software. It may be done by a third party, so at home for AT&T would like this. Or it may be that we run that new box service in our TV server. We're flexible on when it happens, but where it happens. But in talking with customers, it's important that someone has to do this. This is the first place a box talks to when it first powers up. And that's going to present a UI that allows the technician to enter the work order number. This new box service, because it's being talked to by the box, knows the ID of the box. So that each box has a unique ID. It may be its MAC address, it may be a silicon serial number burnt into the box, but somehow or another each box has a unique address or a unique ID that's presented to this new box service, and it is presented in general in talking with TAC server. So we enter the work order number, the box ID we know, and then based on that work order number, which was saved when we first created the customer database record, we can go ahead, look up that customer entry, and now add the box ID to that database entry. So now we know which box that customer is using. And that's important later on because that box ID identifies that box for a lot of other things. If the new box service was in the hub, there would probably be a database associated with that hub where it was, for instance, only giving out valid IP addresses to people that were within its database. That's one thing that you may or may not want to do. In that case, the new box service here would have to call through some of the provisioning APIs that Mike talked about to TV server to add that box ID to the database. If we're running the new box service in TV server and there was that database in here, again, we would need to call out through a SCO to this. Or a customer might not have a separate database associated with their hub. It's really one of those flexible things on how they're wanting to sell it up. This is hardware they're buying from Cisco or 3Com, and they're needing to make some decisions with them on how to set up and run the service.
And this one point, if the box ID isn't a serial number, is it software that is handled by TVTAC client,
MS-TV client needs to provide a unique identifier. That unique identifier, if it's burnt into the box, is something we would call a silicon serial number. With the DCT5000, my understanding is there's no way to burn something unique into each box. However, each box has to have a unique MAC address. That's required by the TCP/IP networking protocol. So in that case, you would probably use the MAC address as the box ID. From MS-TV server, we really don't care. It just has to be some unique number. My best guess is that with the DCT5000, that's going to be the MAC address. Smart card could be an option, and that provides the unique address, and then that becomes associated with it. So that would allow users to travel with a card that identifies them. That's something that is going to be used to tie to the subscriber in the database. So from here, the new box service is going to redirect the set-top box to our pre-registration server. This is the first point at which we actually know we're talking with TT server. The new box service might have been or might not have been, whatever. But here we're finally connecting to TV server. So when the set-top box is connecting to pre-reg, it's going to go ahead and provide its box ID. Pre-reg will then look up, that user knows who it is, and is going to pick an initial shared secret and a list of head waiters and send that back to that set-top box, and at the same time, we'll save that initial shared secret, the database record associated with that user. So at this point, we now have a unique key in the set-top box and a unique key that the server knows about in the database. And that is over an SSL connection, because we don't have any other way of setting it up at that point. So we do it over SSL, it's secure, and we have the initial key that's shared between the two.
Mark, just the head waiter list, what exactly do you mean by the list?
So, I'll get to that on the very next step. The other thing that happens is this is the first point at which the user, rather than the technician, is starting to use the box. This is where we're going into UI that's asking the user what would be the email address or the account name that you want for yourself. Because we didn't force that to happen at the customer call. We want to give the user the option. Of course, they're going to try some names that are already being used. We can present alternatives, etc. This is where we actually get that, and we'll put that in the database also. And at this point, the database is fully provisioned. We know for that user all of their address information, billing information, the box ID associated with them, and the account name that they need and are using. This is also the point where we would use our general provisioning SCO to talk with the mail backend to make sure that we can actually create an account in that mail backend that can be used with that username. So I'm not really going to be talking about mail at this meeting, but we do have multiple mail backends, and so you need to communicate with it to create the account on the back end. The box at this point, and I've indicated a line, is fully provisioned. The next set of steps that I'm going through are the set of steps that will happen in the future anytime someone powers on that box. And what's going to happen is at this point, you're going to want to talk with head waiter or one of multiple head waiters for redundancy. So the box will go ahead and communicate with head waiter, and because we gave it a list of head waiters, if one of those head waiters is down, it could actually go to an alternate head waiter. And this is the initial connection point for when someone is trying to log into TV server. So the set-top box will go to head waiter, it will send its box ID, and then start encrypting the connection based on its initial shared secret. Based on the box ID, we can look up that shared secret so we know what it is in the server and start the two-way authentication over that encrypted link. At this point, we know it's the real box because they can talk with us. And even if someone sent out the wrong box ID because they tried to clone it, they don't know the shared secret. So when they tried to communicate, we're just going to see garbage and vice versa. So this is both the box ID and the shared secret are what guarantee that it really is the box that we know about. And when they're talking with us, that they really know it's one of our authorized head waiters. At this point is where you get the UI that will ask you to select which user you want to log in as if you have multiple users associated with that box. And also then what password, the password associated with that account. Again, if you only have one user on the box with no password, these two steps are skipped and you go directly, you bypass them entirely. And that's where head waiter then at this point knows which user on that box. So initially it just knew the box. Now it knows the actual specific user that it's logging in. And it can generate 4 pieces of information. One is a set of session keys. These are what will be used for all further encryption. Another is the ticket I talked about earlier. So this is the name of that user and the capabilities of the user. A server list, which I'll talk about in a little more detail. And then the initial home service. The server list is similar to what I talked about when I said a head waiter list. In this point, you gave them a list that was really short. It had head waiter and then several head waiters to go to. At this point, the server list actually has for each service that we have as part of MSTV server, a list of servers that will provide that service. So this may have home page with a couple servers, mail with a couple servers, favorites with a couple servers. This is what we then use again for the availability and the scalability purposes. And then the initial home service. So at this point, the box has all of the information. It's got it from head waiter, and then it will go to its initial home service. So I've indicated that as WTV home, and it's the initial home service that perhaps this box has. And when it connects to that initial home service, which it got from the service list. So if that particular server that was serving up happened to be down, it would fail over to another server on that server list associated with that particular service it was trying to use. It will go ahead, send its ticket, and then start encrypting with the session keys that were provided to it from Headwaiter. The service that it's talking with will read in the ticket. It will decrypt that ticket with the service key. So each ticket is encrypted with the service key that's known to all the services but not the client. So the service, in this case WTV Home, can decrypt the ticket. It will pull the session keys out of the ticket that were assigned to that user, and now you can start the lightweight two-way authentication. You know who the user is. You also know, you know that it's a valid user. You've encrypted it, and you know who it is based on the information in the ticket. The thing that's interesting about these two steps is this is what you repeat through any time you're using any other service, mail, favorites, whatever. You go back, you first connect to it, you send out your ticket, and then you start encrypting with your session keys, and the service that you're talking with will unpack the ticket, read the session keys, and communicate back with you, and also knows which user you are. So these are the steps you go through as you talk with different services within the TVPAC server. So that was a whole lot of stuff, and I went through it without stopping. So if you have questions, feel free to ask. It's sort of a lot of technical detail, but I wanted to give you an idea of the process that went through. At this point, we know what we're doing when we talk with any other service. And as I said, anytime you go ahead and turn the power on the box again, it will restart at step 8, get a new set of tickets, select which user you're logging in as, send out the stuff, and repeat through these steps. So it gives you a general idea of what's going on. It also gives you an idea from the earlier steps, 1 through 7, some of the work that needs to be done with the vendors on the CMTS and through the provisioning steps. I glossed over a lot of the database interface, but that was covered by Mike earlier, where you're provisioning multiple different systems and billing interfaces and things like that. So, questions?
You may suggest and touch on when the cable model, where the TV home and the web home are integrated on one page, and we go through all these steps.
So that's a question that was brought up before, is what's happening as you start to integrate web home and TV home. And I think the answer is the same one I gave before, which is it's a UI question. We could support almost anything. At some point, obviously, you will want to authenticate the user, almost certainly before you let them send or receive mail, quite likely when they're accessing their favorites. You may want to do it before you let them do any web browsing at all. Certainly, if you have a household where you have some restricted accounts and some unrestricted, it would be unwise to let the household account be totally unrestricted. If something's setting up so like there's just the mall and there's nothing else but the mall and no one can go outside the mall, then certainly I would expect that you would allow general browsing in the mall at any time. But maybe you would require that if some users had unrestricted access and they tried to go there, it would bring up something saying, please log in as one of, or present your user ID to go outside the mall. So we have quite a bit of flexibility on that. But the real thing is I think this is a big unknown area. I don't think people have actually explored a lot with what to do with this. We certainly on the development side are looking at some various scenarios and will probably present a combined user web home integrated homepage as an initial place that people could start with. But it's something that I expect that different operators, as they work through, may want to make some changes to. Yep. There is nothing in our service that would prevent you from logging in from 2 boxes on the same time. Note, however, that our service is set up that the only people who can log on to a given box are people who are associated with that box ID. So you couldn't go over to your friend's house and log in on their box, because we actually present a whole lot of the security as physical possession of the box. But if you had 2 boxes in your own household, one upstairs and one downstairs, and it had been set up so that you had accounts on both, you could certainly go and log into both at the same time. However, this again brings up some of the UI things that you may run into. If an MSO wants to enable that capability, we have to say, okay, if a user goes to their mail and upstairs and downstairs, two people are logged in as the same user on the same mail account, one person deletes the message and another one tries to read that message, they may get an error message like, that mail message is no longer available, sorry. I mean, that's sort of a UI type thing that we can't do much about. So there are some interesting cases that happen with that. If one person is manipulating the favorites list while the other person is in the middle of using it, it's not well defined even what you should do in those cases. So our only guarantee is we will try and do something reasonable. The box won't crash, but they may get some error messages that are not intuitively obvious to them without thinking through, oh, my husband just deleted the message I was trying to read. So we do expect that might generate some calls to customer care. But on the other hand, I'm not sure, if you really had two people in the household in two boxes, why would they both be logged in as the same user on the same time? We could prevent it if people didn't like what they got, but we could also enable it.
You mentioned smart cards, though, too. You could have the physical manifestation of the smart card, not
right.
necessarily in the box.
Yeah, I'm not sure that our 1.0 release is going to support smart cards because I'm not sure the capabilities with the DCT5000s. But yes, if your physical manifestation of yours was the smart card, then you just go and plug into whatever box you're in. That's certainly a model we'd like to get to, and I'm not sure what the status is on that.
Does the server actually care about smart cards?
No. I mean, it would care in that we would have to be recognizing both a box ID and a smart card ID and care about it. It's not a huge difference. Server, it's like, okay, well, it's another entry in the database. Other questions?
Are there any export restrictions on any of these?
Yes. The current encryption that we use that I described is 128-bit RC4 encryption. TVPAC server, as it ships, standardly comes with 40-bit, which is available for export, with an upgrade product that gives you 128-bit. We believe in talking with the NSA that we will be able to let UPC use this without any real problems because they have American-based owners. In general, though, for sales overseas, this is a problem and would need to either get a separate license for the 120. I mean, they could get 40-bit, no problem. If they want 128-bit, it needs to be worked out on an individual license. We're hoping some of the stuff that we've read about in the papers about relaxing these restrictions would make it go away. But we do have the capability of shipping the 40-bit. That's the standard default, and you actually need to do an upgrade on U.S. Cable operators. Other questions? Perfect. Well, we're only about 10 minutes behind, so I'll let the next person go.
Cool. Okay. So I'm going to talk a little bit about server scalability, and I'll try and make this quick, actually. Maybe we'll catch up a little bit. So I'm the manager of operations development. I'm responsible for making sure that things scales and can be operated, and that it logs, we know what it does, and it's reliable, and we can monitor it and know that it's working, things like that. So I guess we'll start off with the basic scalability goals. The DPR that we put out right now is suitable for use by fully dozens of people at the same time, which really means that we did no performance testing, so we gave a really low number because we know we can support that low number. The alpha of the 1.0 release similarly will not support a huge user base. It'll support 1,000 users, suitable for technical trials, use within cable companies' offices. It's not a great choice for large-scale commercial deployments because it'll scale well enough to handle 1,000 subscribers, but once again, it won't really receive the full testing for scalability to large installations. Yeah.
I have a quick question.
Yeah.
From a non-technical person.
Sure.
What happens? I realize that you guarantee that certain.
What happens if you put more?
Yeah. So what happens when you put more on an earlier release? What do you guys do to go from 1,000 to 100,000 at very high level terms?
In high level terms, we try it. We see if it works. Certainly, from the beginning, we have to design it so that it'll support 100,000 or 1 million or 10 million. And, really, in terms of design, the goal is millions. It's greater than 1 million. And so we won't do anything up front that we think will interfere with the goal of supporting 10 million users.
Okay.
We might have done something inadvertently.
Okay. So, you're not designing one for 1,000 and then saying we're going to change the database now on the side and all that stuff. You're actually designing for the high water mark and then just don't get around testing and QAing it until these times.
That's right.
But just one thing I've been wanting to ask now for a month, I keep forgetting.
Yeah.
What are the issues scaling, say, from 1,000 to 1 million?
We'll get there. We'll get there. So 1.0 beta, we will test and certify to support 100,000 subscribers, which I think is larger than any of the installations we expect to see based on beta. Beta is suitable for field trials and should have a higher level of quality. The 1.0 RTM release will support 1 million subscribers, and we will have tested that. We'll know that you can support subs. And as I said, the design is intended to work for much larger bases than 1 million. So the post 1.0, it should support many millions without a whole lot of trouble.
So is that a hardware that is like hard-coded in essentially?
Nope.
So you just guarantee it for that number?
That's right. That's the number that we will have tested and verified that it works. All of these, certainly the early releases, there's reason to believe that you could do more than what these numbers are, but we can't tell customers that because we will only have tested to these numbers. The architecture for allowing the service to scale, and one of the reasons we can believe we can scale to a large service is that when you make a TV installation, you essentially build a bunch of mini services, and we call those service groups. Each of the mini services is intended to be almost a complete service. It has most of the pieces of MSTV server, and that's actually the piece that we do performance testing on. So when we say we support 1 million subscribers, that doesn't actually mean that we have a lab where we're going to build up a 1 million subscriber service. We're not going to do that. That actually costs a lot of money. And it actually wouldn't have a lot of benefit. What we're going to do is we're going to build up a service group to support some number of subscribers, let's say 50,000. And we will test to make sure that supports 50,000 users. And then we know that we can more of those, and since they don't have interdependencies, we'll scale linearly. And that works for many of the components of the service, but not all of them. And the reason that works is that there are no interdependencies between service groups. Two service groups will never talk to each other. It's not like when you add more service groups, they start getting slower because they're talking to so many other groups. They don't talk to each other. They're independent. And in the future, when we support geographic distribution of the service better, this will be the unit of hosts that you can put in a different city in a different data center. Yeah.
No interdependencies, but you do have separate databases for each service group, right?
Mm-hmm. That's right. Funny you should ask that.
That seems to be a dependency.
You're right. There are some shared components between the service groups. Actually, we can jump ahead to there. Well, actually, I'll show the diagrams first. So this is a service group. It doesn't have all the components represented on it, but it's got a sort of representative sampling. There are front-end machines that run applications like home, centers, search. The operators can actually decide exactly how to divide the applications between hosts. But you would expect that some of the higher load applications will be on dedicated machines. For example, the reformatting proxy will almost certainly be run on separate hardware from everything else because it's probably the most heavily loaded service, and it also has a slightly different hardware requirements. It requires a lot of disk space, for example. You could imagine combining a bunch of the UI applications because they're fairly similar in terms of their requirements, and they probably do quite a bit less work than the reformatting proxy. Operators that are used to use server-side cookies, they may very well deploy those on separate hosts because they get a lot of load. But favorites and mail, you wouldn't necessarily have to put those on their own machines. Then within a service group, there are a couple of shared components that a lot of different servers access. The most important is the main subscriber users devices database. You'll hear this called the SUD a lot. That's a database that stores information about subscribers, users, and devices. And it's worth noting that each SUD only has data about the user assigned to that service group. It is for any given household, all of the data for that household will be on exactly one service group. Whenever they log in, they'll talk to the servers in that service group. And they can be moved to another service group, but it's an administrative operation you wouldn't do routinely. You don't do it dynamically to load balance or anything like that. The mapping of users to service groups is generally static. The second important shared component of a service group is the user store. This is the store that we use to store some higher volume data that changes more often and that we don't necessarily need to protect in a transactional database. So examples of that are cookies and favorites. Both of these applications store the data in the user store. And right now there's some investigation going on what the best user store to use is. We have an implementation right now on top of the SIFT's file sharing protocol, Microsoft's file sharing protocol. Well, I'm sorry, we don't have it. It's being implemented by a contracting firm. And we have an implementation on top of SQL 7. And so right now we're doing performance numbers to figure out which one we actually recommend that customers use, or both. If they use SQL 7, actually these two classes of machine may collapse into one. You could imagine putting this database and the user store database on the same machine. So when we scale up to a larger service, we take a bunch of these units and we replicate them. They have interdependencies, but they all do talk to several global components. So every SUD database is going to talk to a global database, and this is the answer to your question. the databases do need to share a bit of information. So there's a small amount of information that's replicated up from these to that database. And so this database actually does have to scale. When the bigger the service, the bigger this database. So this is a scaling point for the service. However, that database does very little work, so we actually don't believe that we'll run scaling problems with it until many, many millions of users. Similarly, there's a log aggregator that aggregates logs about what's been going on in all these services. All these services, every machine logs information about its activities, but it's distributed across 300 machines. It's really hard to get anything useful out of. So we take those logs, and every machine sends its logs up to this machine. So this machine similarly has to scale to support a larger user base. And in the one time frame, it's likely that there will still only be one or a small number of these in a service. There won't be one per service group. So this is another component that we have to worry a lot about the scalability of. And then the final global component is the data warehouse. If a subscriber deploys a data warehouse, in the 1.0 time frame, it's one warehouse for a subscriber base. So that'll actually be quite a big database installation.
Is there going to be an exercise to be able to provide size and documents that will include both the relative size of machines, but also the bandwidth between the machines? In other words, you kind of get a picture for, bigger than a bread box, here, right? I know you guys have more detail on the size of the machines, but what about the bandwidth, the communications between them? You take a 1 million user scenario, and you say, okay, roughly this is how much communication we think will happen, we'll model, right, between the data warehouse server and these servers. And so this is the kind of pipe you should put in between them.
Yeah, that's a good question. I think that we'll have to provide some of that information. We need at least basic recommendations. As you add more and more service groups, I haven't drawn all the networks in here. There are a couple networks. All the machines are probably dual-homed. And there is certainly a point you reach where you need to start splitting these networks into separate subnets.
Well, some of the operators, not some, maybe most, I don't know, want to actually spread this physically, right? So they need to actually put links in between the different. We won't get into that right now, but
right. Yeah, that's a whole.
Bandwidth.
That's a whole interesting subject. I think that we have some work to do to figure out what sort of geographic scaling we support well and what sorts we don't support well. If you took the service today and you distributed it geographically, you could do that with appropriate links between them. But right now there isn't logic to make sure that, for example, users go to the servers that are near them. So we'll probably need, I think we'll have to add that into the 1.0 product plan, but that discussion is going on right now. So I guess my take on this is that what we need to do is figure out exactly the geographic distribution models we support for 1.0. I believe the plan of record actually says none of them, but I think we're discovering that's not realistic. So we need to carefully choose a very small set of the possible geographic distribution models and then document those. So I agree with what you said and haven't figured that out yet. So as I said, there are a few components that really have to scale up to support the installation side. If you have 1 million subscribers, this global database has got to handle 1 million. The log aggregator has got to support 1 million, and the data warehouse has got to support 1 million for 1.0. In terms of how we're going to test that, as I said, we're going to build one service group. We have these machines on. They should be in a few weeks, and we've got a performance lab that'll be up on Charleston Road. So we're going to rack up a bunch of machines in the lab, and we're going to build out services like you'd have in a real service group, and then there's a Microsoft load generation tool that we've got called Homer that we're teaching to simulate a web TV client. So we're going to run a bunch of machines simulating clients, and we're going to have them talk to the service machines, and we're going to deliver what we hope is a very realistic load and see how the servers do. And if they don't meet the load, then we're going to have to go in and analyze what they're doing, what they're not doing right, what's taking so long. It's worth noting that in terms of the schedule, much of the performance work is a little later than most of the other features. The features will be complete in the alpha release, but the performance work will not all be in the alpha release, and that's why we have the not very optimistic goals for scale for the early releases. A lot of the scalability work comes in later in the product cycle, and so it's the beta and the RTM release that you want to look at for large-scale deployments. Then in the separate components that we talked about a minute ago, the database components, the aggregator components, and so forth, we have to separately test because we're not going to build 1 million subscriber service in order to test the global database or in order to test the aggregator. So we have separate test plans for those, particularly the database and the aggregator. The data warehouse scaling, actually, I'm not quite as familiar with what we're doing. I'm not sure that whole story is known, although to a large extent, that's what the SQL Server group can help us out with because they know a lot about how their product scales. So This talk was originally titled Scalability and Performance, and in some sense there are two issues that really matter for this product. One is how many subscribers can we support if cost is no objective. But in terms of performance, and you know you do run into bottlenecks like that, right? You know, eBay is a really large service. If they could spend $50 million and scale bigger, they'd do it. They don't care about the cost, but they actually have run into hard limits. So scalability is the first question. Where are the absolute limits where no matter how much money you spend, you can't scale any bigger? But the second thing that's really important for this product is the capital cost per subscriber. And so when we talk about performance, that's actually a number we care about. It's not it's not how many tenths of a second it takes to serve up the home page. The main metric is capital cost per sub. In a broad scale, the goal for capital cost per sub is to be in line with the Web TV service. We actually expect to be cheaper than the Web TV service, but that's kind of the line for accepting this release. There are some spreadsheets floating around that estimate what the Web TV service costs per sub, and I'm not going to try and quote them in this meeting, but and then I think as we go yeah. So, and then we're going to try and drive that down. But I have to make one big caveat, which is that the cost of the service depends a lot on what the users of the service do. As you look at operators, we may have some operators that deploy one of these set-top boxes to every sub on their service, and it may be that 5% of them never sign up for web service, only have access to a very small walled garden, and may not even use it. We will have other cable subscribers where the only people that get this box are people who sign up for web service, and so every user will be a heavy user. So capital cost per sub is a slippery concept too. Right now, we're probably biased towards capital cost per active sub, but for the deployments where we deploy a large number of boxes to people who aren't going to use them a lot, once again we'll probably handle significantly more subs. And I don't know that for 1.0 we're going to have that quantified really well, but as we learn about the operators' usage patterns, that actually we should start talking about cost per sub for modes of usage, because there will probably be an order of magnitude difference between what you can simply active service or less active. Yeah. When I refer to capital cost, I essentially mean the cost of the server hardware and the networking equipment. I'm not including, for example, operator salaries. I'm not actually including physical space directly when I talk about capital costs, although sort of proportional to hardware costs in a lot of ways. I think that's roughly the list of things. And I definitely don't include set-top boxes. Just as an aside, it is interesting to note, if you look at sort of the cost structure of these things, you know, the set-top box is probably number one, and my personal view is that customer support is probably number two, and the server machines are probably number three. So that's another important thing to keep in mind, too. Yeah?
Maybe you said this and I missed it, but what happens as you scale, you know, from 1 million to 10 million? Does the cost per subscriber go up, down, or stay the same, or you don't know, or you don't care?
Well, if we didn't do any releases between the 1 million and 10 million, it would probably be roughly linear, because service groups cost the same amount to build, right? And so you just build those out. The only things where it becomes more interesting is when you start talking about the shared components like the global database, the aggregator. The global database, you could get to 10 million and not spend very much on it. It's sort of irrelevant. The aggregator is going to go up roughly linearly. The data warehouse probably goes up more than linearly. You're talking about a big iron to have a 10 million sub data warehouse. Although the data warehousing group has plans for how to keep that cost down. If you have 10 million subs, you could choose not to store every hit of every subscriber in the database if you didn't want to. So there's actually an architecture in place now for sampling of data so that you can get good aggregate number on your users, and you can get specific data for every user on the things you really care about. But you can throw away 80% of the data on the way to the warehouse.
So your answer is you really don't know.
About the cost going up?
About the cost per subscriber as you go, say, from 1 million to 10 million subscribers.
I think we know for most of the components except the warehouse. And the warehouse, it depends on the decisions you make.
Overall, bottom line.
It scales pretty linearly because of the service group stuff, right?
Yeah.
You should have this little complex for 50,000 users. You just keep doubling it. So you just keep doubling it.
Yeah, sure. That's linear. Right. The groups are linear, but like I'm saying, you don't. Your initial cost on your data warehouse is not going to change until you get a million.
Right.
So actually, your cost per subscriber is dropping for a while until you get to the point where you've overloaded your shared databases. And then at some point, you've got to scale those up because there's going to be another increase in cost. But you don't know where that point is.
That's right. In a lot of ways, it depends on your strategy, right? You can choose to deploy service with a very small data warehouse and and grow it very conservatively, buy a little bit bigger and bigger and a little bit bigger and a little bit bigger and rely on the trade-in plan from your hardware manufacturer. Or you can choose to buy a big one up front because you know you're going to get big.
We did a best case for Charter, and we had like $4.80 per stub. So 50,000 user system, and it went to $1 million, it dropped to like $3.40. Okay.
Yeah.
But we scaled like you just described with a bigger warehouse up front,
Right.
the bigger cost.
Right.
But just to be clear, the warehouse was sort of some unknown. We made some pretty wild assumptions.
Right.
There's a lot of unknowns around the warehouse. We made just some wild assumptions.
Oh, okay.
We're
Right.
not sure if those are true, but I think we had a pretty good handle on the rest of it.
Yeah.
It's just the warehouse that could easily pull those numbers out.
Yeah, I mean, in some sense, the warehouse is probably a weird curve. Where, like, when you're small, the warehouse is very expensive, right? And then as you scale up, it gets less expensive because you have greater utilization of the hardware. And then as you get really big, if you don't start throwing out data, it goes up because expensive hardware is not linearly more expensive. I mean, high-end hardware is not linearly more expensive than low-end hardware. It's exponential. So by the time you're buying like 16-way machines to do it, you're at a very high cost per step. So somewhere around here, you don't want to start throwing out data unless your business justifies spending this much money on your warehouse. Maybe it can. I don't know. So the answer in a lot of ways is that the operators will be able to choose. However, this line is really post 1.0. We expect to support 1 million subs on one data warehouse machine within a manageable size. You don't have to be like talking to Cray to run 1.0. So that's actually most of what I want to say about performance right now. Anybody have more questions?
The other cost I think that's missing there, but is the development issue, but is the operations cost.
Yep.
Because I think that's where we win from a business perspective in the marketplace. Is first your capex is important, but then if you have to have an engineer beside every little machine watching it, your overall total cost is crazy.
Absolutely.
I do actually think I'm pretty bullish that I think our ops costs will be very low because of the good design of the architecture, but we need to get some science behind that.
Right.
So we can start putting that out in the marketplace and say, look.
Well, I'm another assertion, which is in terms of the overall cost structure, the quality interface may dominate the hardware cost. That is, if you look at the dial-up service that we run, which in some ways is similar, in some ways isn't, we probably spend, we take in $25 a month, we probably spend 8 to 10 on connectivity, which is totally different in the cable space. We probably spend 5 to 8 on customer support, and we spend less than 2 on all the hardware and operators put together. So if you look at where optimize, if you can fix a user interface problem that results in customer care problems, that can save more money than all the software optimization you can do in the world. And that's going to be a really interesting thing to try to measure.
Yeah. But it's good that we actually share that experience in a way that gets cable operators and our network operators, focused on the right problem.
Yeah.
Because our competition might get to focus on the stuff that, gets them all excited about, one metric, and then they come to us and say, your price is too high for your software, right? Or whatever the metric is they're worried about. And then all of a sudden, we need to show them that.
Absolutely.
I think that's actually a great point.
Yeah.
That's a great point.
And honestly, one of my fears is that the operators don't understand the customer care ramifications yet. Because
We haven't done a good job. Point to the microphone. This is a good point to capture on the tape.
yeah. If you'd said that before he'd said it, then I would have been more prepared to do it. Here. Speaking to the mic.
We'll capture it. Prashant's got it.
Yeah, Prashant will put it in the notes. Yes.
So, to summarize, the reason why you guys have designed service groups is one, for scalability, right?
Yep.
Any other reason why?
Yeah, actually, so this is number 2. Number 1 is for fault isolation. One of the big problems running a service like this is, WebTV's U.S. service has probably 400 machines right now, and if you add up all hard disks, it's like over 1,000, maybe 1,500 hard disks. Turns out that there's a disk used to be failing every day. And so you have to assume that at any given time, one or more of your machines will be down. And so we try very hard to have all the machines be redundant, so that whenever a machine fails, it's not a fire drill. You don't have to fix it right away. But if there are dependencies between machines we don't patch, what the service group structuring lets us do is make sure that if a machine goes down, the only users hurt are the users of that service group. So the worst case scenario is you lose.
They're not necessarily hurt, right? Because you fail over to another machine.
Right, but say that something fails catastrophically. Say you lose a switch. Say you lose a database machine. Say the database machine is a clustered machine, but Wolfpack fails you, and you lose database service. for most kinds of failures, the largest system-wide failure you ever get is one service group. And so that fault isolation is very important. It also knows that if a machine fails, and so you roll over to the backups, you want to figure out what users might be impacted with lower performance. When you get calls, you know whether they're reporting a problem that you already know of or a problem that you don't know of yet. With service groups, you know what machines failed, and you know what users that could impact. And so if some other user calls up, you know that that's not the cause of their problem.
So it facilitates.
Yeah. Otherwise, as your service grows, the problem diagnosis gets much harder because any given user could be hitting any given front end, which is sort of the Hotmail model actually of until recently. And so when you do have problems, the problems tend to be much more wide, whereas in this architecture, the problems tend to be much more limited to a small set of users. It also means that if you register users into a service group, it doesn't hurt everybody. Only that service group starts to slow down. You can solve it by moving them into another one.
So it helps you manage your whole operation.
Right.
But was another reason for service groups to lower capital costs for subscribers?
Nope. Actually, I think it probably marginally raises capital cost per subscriber. There is a third reason, which is versioning. When you roll out a new release, the last thing you want to do is put the new release out to the whole subscriber base, which is sort of another classic Hotmail. How do you put out a new version to Hotmail since everyone's hitting all the same hardware? You can version one service group at a time. So, for example, you might have a small service group that you just use for some users that you're friendly with that are willing to test new stuff. And when you roll out a release, you might send the release to that service group first, and so they run a new version. You see how it works. Then maybe you roll it out to one full-size production service, and you see how, you've already done lab testing, but you test it with real users, and maybe you'll catch something you didn't catch in all your QA testing and small service group testing.
So you're saying the test group.
Yeah. And once you're confident, you can roll it out service group by service group.
So you can use to specific service group.
Absolutely. Every user is assigned to a specific service group. Actually, every subscriber, all the users of a given box are all in the same service group. And when you start geographically scaling, you want them to be assigned to service groups close to where they are.
So is there a strategy for how many users?
Today there is not. I know. Honestly, I'm not quite sure what the code does. I know in the Solaris service, at any given time, the operators can say that all new user registrations should go to the following list of service groups, and it just round robins between them. I think we probably say the same thing. And that lets you sort of have this fire hose that's pointed at one or more groups, and then when they fill up, you point it at somewhere else, and you point it somewhere else. I think we're going to have to. We may have to do better than that as we start seeing geographic scaling. Having some smart user registers, you figure out what part of your network they're coming from, and then you put it into something close by. So that's something we're talking about right now. How much that'll be in 1.0, I'm not sure. Okay. Any more questions?
Okay, so let's turn it over to Suresh now.
Here? Okay. Hi, my name is Suresh Babu. I manage a small group of developers focusing on commerce applications. I think the name is a misnomer because our team doesn't commerce and a little less than commerce. So in the commerce arena, we are not doing commerce applications. That explains why we are doing less than commerce. And we do electronic program guide and some other applications that are not in the commerce arena proper. So today I want to talk about two things: the content and ad targeting services in TV Pack Server, and also about electronic program guide in TV Pack Server. To start off, we will do the content and ad targeting. In this session, we are going to talk about the different kind of advertisements that we support in the TV server. We will talk about two different categories: what we are going to support in 1.0 time frame, and what are the things that we are thinking about for beyond 1.0. So you just have an idea of the direction that we are heading on. And then we will talk about some design, and finally we also will talk about some of the targeted content delivery as against advertisements. All the different parameters can be used to target content. How much of a granularity we get on that? Looking for any questions. As I'm going through, if you have any questions, please stop and ask me those questions as well. In 1.0, we support two major type of advertisements, if you would. Let's start with the banner ads first, because we all know that what it is. It's basically any small window of space that's on your applications that gets filled with an advertisement. It's called banner advertisement or top ad. So in this specific case, applications called content ad targeting services gets a piece of content, gets that into the content object go. That's how the banner ads work. The second part of advertisement, which is more specific or specialized to TV and TV fax over, is the source part advertisement. What that is, when a user is browsing the web, let's say the user goes to Microsoft.com. The moment the user visits Microsoft.com, the proxy delivers a page. At the same time, the proxy checks a list of pages to see if it is something important. Like, for example, joesgarage.com would not be a well-known URL. How about but Microsoft.com or Chat.com or Ford.com are well-known addresses that we can map to some categories. So when that is true, the proxy server tells the box, all right, there's something important and interesting about this specific URL. Go talk to the source part ad to see if you can get a targeted ad for this specific URL. And then as the user is viewing the web page, the set-top box keeps talking to the server. In this case, it's going to be the source part server. And it's going to say, all right, here's the URL. Give me an ad that pertains to that URL. And then at that time, we take that URL, we massage that, and we get categories. In this case, it may be personal computers and software, maybe two categories that may be matching to Microsoft.com. And then we use that as targeting parameters and go get some ads that pertain to that URL. Now, then what happens to the ad? The ad gets delivered to the client, and client stores that, doesn't think about it. And then the user goes to, let's say, Toyota.com from that point on. We call this a domain transition, going from one domain to the other domain, which typically takes a longer time frame to get the content in there. At that time, the box may show the ad. Again, the box may show the ad. Depending on latency that the box is experiencing, the box decides whether to show that or not. So there are two kind of complexities in that. Number one, when we give the ad, we cannot be sure they're ever going to be shown to the user, so we do not track that as an ad delivery. And later, how long the user gets to view that, we don't know about. So there are some thresholds that are set in the client. Like, for example, if the user gets to see that for a second and a half, it's not counted as valid time that we can count. If the user saw that for 3 seconds, we say, all right, we can count that, but at the same time, the ad should be seen for a total of 15 seconds or more to be counted as an impression. So the box does the job of accumulating all the times this ad was shown to the user if the amount of time exceeds the minimum threshold. If it is shown 3 seconds or more, it starts adding that up, and when it's shown for 15 seconds, it calls us later and then reports that as an impression. So that's all the dynamics involved in the source part ad. Both of those ads are supported in 1.0 time frame. We also have targeted content. The targeted content is anything that let's say you have an app. You don't want to fill a space with advertisements, but if you want to put your own content, at the same time, you want that to be targeted. You want that page to look different for different demographic of the users, that you could use the same engine, same interface for delivering your own content. That is targeted content. And beyond 1.0, we are thinking about ad insertion in video streams. Like if a national broadcaster has a slot that the local broadcaster has purchased, then we will be able to do a targeted video ad, just insert that at that point. We'll be also able to do what's called a click-through to video ads. It looks more like a banner ad, but you click on that, it takes you to a full-motion video ad that you can see. And then we also, full-motion video ads are more like for if you have a box that is not on the cable or satellite link, and it has some time to connect. Whenever there's a time that we could show those ads. So all those video-related ads, we're planning for that beyond 1.0 time frame. I'll be that 1.0.
Using video flash, are we having the transcoding in the server? So if somebody wants to put a video ad, they give us their normal source of video, whatever it is, and then we serve it down to the box. Are we using that format? Or
right. Right now, we do not do anything on the video ads. For the 1.0 time frame, we're not. For what we're planning, we are thinking more like a streaming video, and we've not worked out all the details. By the way, the question was, what is our planned media for video ads, whether we're going to do any flash transformation or not. We've not worked out those yet. But the direction is to go with the streaming video for delivery, and no other details have been worked out at this point.
The mechanism you just described for targeting the content almost seems like a high probability of putting Toyota ads in front of somebody who is going to Ford, or putting, competing people together. So if you have content partners,
right?
So you've got a lot of people going to your content partners, but you've got other advertisers. I mean, aren't you sort of setting up conflict between your content and partners and your advertisers? Is that type of a model?
Okay, the question was, looks like the targeting process may place competition's ad Like, for example, when you were going to Ford.com, you might show Toyota.com, and the user clicks on that ad, and the user ends up going to Toyota.com. It means more like a hijacking the user from where they're really going. So are we not setting up a conflict? Number one, the situation is that we do that after the fact. Like, for example, you go to Ford, we don't do a Toyota.com ad at that time. But we capture that fact, and when we do transition, at that time we show the ad. Now, it's quite possible that the user may be trying to go to Volkswagen at that time. But we are not really doing any protection against that. In terms of a topical ad or a banner ad, we can specify content that that will not get put in there. Like, for example, if we have an app that has two ads sitting next to each other, we don't want that to have Ford and Toyota side by side. And that can be done by targeted expressions that we will be talking. So,
I think the targeted search bot really under control of the network operator, and they have control over which sites are targeted and which sites aren't. They also have control over which categories their ad campaigns are targeted to. So they can choose to do that if they want, or they can choose not to do that. So it's under their control.
Right. So in terms of our design, we are doing that as an open design from our end-to-end connectivity perspective. Our solution out of the box is to integrate with Commerce Server. Commerce Server has a component called Advertisement Server, and Commerce Server Plutonium, the 4.0 version, has a lot of improvements in terms of scalability and performance of the ad server, and that is what we want to offer for out of the box with TV Server. However, Commerce Server will not be totally bundled with the system. It has an integration layer that is available for you to install by default. So the way, on a higher picture, let's go from the bottom up here. This is where the clients interact through IIS, and it goes to the WTV filter and to ISAPI layers. And this is where all the applications are common components. They are at the extent which serve content. As part of delivering the content, applications may want to extract targeted ad or content. At that time, they would call CATS, or Content and Ad Targeting Services. Now, CATS is a defined layer that we have the interface. We're going to publish that. It's a standard available interface. And also, we actually, CATS publishes two different layers of interfaces. One is the API, or the Application Programmers Interface, so that TVPAC application developers can take advantage of that. But we also have an SPI layer at the back that allows you to plug in a different backend other than the Commerce Ad Server to deliver your ads. Some of the competition in that space is NetGravity, Cipitor, and a variety of other technologies. The reason we want to do that is many of our MSOs may already have a solution in-house, and they want to integrate with us. And this SPI layer is not unique to TVPAC Server. We are taking advantage of Commerce Server totally in this regard. The way we do that is Commerce Server has a technology called the pipeline, and it's the same thing as MSO's core architecture that you probably have heard about this morning for the billing interface. And the pipeline, Commerce Server defines two pipelines. It's a content selection pipeline and an event processing pipeline. These two pipelines are nothing but arrangement of multiple COM objects to complete the process of selecting an ad or the process of recording an event, like that was shown, or the user clicked on the ad. Those kind of events can be recorded also. Given that pipeline, all the user also would have to do is basically write an appropriate COM component or set of components to integrate their backend. It could be a deployment time development option, or it could be later that they do that at any time. They could just install something. From the CATS perspective, we would always run those pipelines, and we just have no idea as to what components the pipelines end up calling inside to that. All parameter passing is done through dictionary objects with the name value pairs. Any question on the backend integration? So that's the SPI layer. On the API layer, we talked about applications. We also have two other small pieces of ISAPI extensions sitting down here. One is the SourcePod API server, which implements the SourcePod protocol that we talked about. And then we have a content tracker. Content tracker is used for the delayed impression tracking. Once the SourcePod ad is delivered to the box, at a later time, the box can turn around and call content tracker and report either an impression, meaning it's been shown for so many times, or a click. The user clicked on that, the box calls the content tracker to register a click, and content tracker in turn will redirect the user to go to the page that is the target of the ad. So at the initial time of ad delivery, we do not give out the URL to the box. The box has no idea what is the destination URL for a specific ad. When a click is made, the only destination URL the box knows about is the content tracker with the parameter of the ad ID. And content tracker goes through all the layers to the backend ad storage, gets the corresponding URL, and redirects the user to go to that site. Any questions on that? Mm-hmm. Over here, this is kind of a different shade because this is not going to be implemented for 1.0. Originally, we were trying to. That's why we see that right here. But for 1.0 time frame, this will not be there. And when we have that, the video ads will be delivered to the client using CCS, the client configuration services. One more thing before I go to this one. We also have something here called TV server configuration system that has its own content storage. What happens if the ad backend was down for some reason? No users are going to complain if they don't see source part ads. In fact, they won't know that they're not seeing those. However, they will if they see a hole in your app. Your home page appears with a frame and nothing in there, then they will complain. So what we have is that the default content storage mechanism that is XML based, and it is accessed using our TV server configuration system. As a MSO, as a deployment manager, what the deployment person can do is to go in there and add a set of contents. It can be 5 or 10 pieces of different content. When the ad system is down, CATS automatically reverts and goes into the default content storage. Retrieves the number of pieces that matches that specific application that is requesting an ad, and chooses one randomly between the number of choices available. So that is the default content mechanism. And no matter what backend is being used, whether it is ours or somebody else implemented that, CATS always knows how to go to the default content to get default content. So in terms of the default content, as we talked about, it uses the configuration services, and it is not targeted at all. We will talk the extent of targeting that we support. There are about 40 different parameters that you can support: the zip code, the time, the user ID, and the box's capabilities, and a whole bunch of stuff supported. In the case of default content, we wanted that to be lightweight, and it does not do any targeting except for the size. So if your home app has 2 different boxes, one is a small one, one is a big one, and we don't want to mismatch these content sizes and give smaller ad for a bigger space and bigger ad for a smaller space. So the only targeting that the default content would do is the size that is given. An application, when it calls the content ad targeting services, would specify the dimensions, the width and height of the area that it is trying to fill. If it doesn't care about that, it would just say 0, 0. And then that is the only targeting that would happen. Source part ad does not care about the size. It can be as small as needed, or it can be as full to fill the entire space. So the source part applications specify 0, 0. And again, there's no click-through or impression tracking will be done for default content. In the case of default content, the destination URL will be sent along with the ad delivered to the client. So the client does not have an ad ID to talk about. It just uses the destination content to just go directly to wherever it's going. So it's just a fallback mechanism. It could be also used by CATS dynamically when the ad server is busy. If you have too many ads, too many campaigns in there, and it did not get an answer from the ad system, when it is running, it just automatically reverts to the default content, and it can come back to talk to the backend server when that is available. Any questions on the default content? In terms of the other systems, we use the Commerce Server backend integration with the pipelines. And the 2 pipelines that I talked to you about are the content selection pipeline and the event processing pipeline. The content selection pipeline allows you to retrieve data. So what you would do here is, for this pipeline, you would supply all the targeting parameters, the client capabilities, the time, and all the parameters that you are interested in using for targeting. And the pipeline will end up by giving you however many ads you are asking. You may be asking for 5 ads. And sometimes for the source part ads, we have what is called low priority and a high priority ads. When the box does not have anything to do, it's sitting idle, it may talk to source part ad and say, all right, I'm not doing anything, give me some ads. No guarantees that I'm going to show it to anyone. It's a low priority ad. At that time, the box can specify a cache size. It says, I can store 5 of them. Give me 5. So then the client can make a decision when it wants to show what. So the content selection pipeline can more than one ad depending upon how many is requested. Event processing pipeline always acts on only one ad, takes the ad ID and records the event, and redirects the user to the destination URL. The content selection pipeline, the pipeline has different stages, and we do have some recommended stages as defined by Commerce Server. These are the different stages that are currently there. If you install TVPAC Server, we have a pipeline for content selection that has all these stages defined. And also deployment manager, you may decide to leave out some stages, or you may decide to add some stages. Does not matter. But just we have a tech that defines all these stages. Number one is the load context. That's the client information, the targeting information, the application who is calling. All the context is read from the dictionaries, and then it filters the content in terms of what all the different contexts that we have that can typically match here. And then it does an initial scoring of all these ads that passes the initial filtering. And then it does the final scoring and does selecting of all the ads that match the criteria. And here is the recording. The recording event basically records the fact that the ad is being delivered to the client. Now, in our case, this is a no-op. We do not record at this point for source parts. For the regular banner ads only, we do recording at that time because we know that it is the impression is already taken care of. The source parts, we don't do any recording. And the final formatting is it returns the data in Excel format, so CAS can take that and return that to the application calling. Question?
Yeah, can you just explain initial scoring and scoring and what is that?
The initial scoring and scoring are concepts defined by the Commerce Server team in terms of how they want to shortlist the number of ads that are available. There are multiple criteria in there. For example, you have a campaign that you define for the ad, which you want to deliver about a million hits, a million impressions by tomorrow. Now, according to the schedule, you are lagging. Whereas there's another piece of campaign that also, an advertisement that also matches the criteria specified. However, it is ahead of your schedule. So what we do is in the initial scoring, we take only the ads that are lagging behind the scheduled hit rate. And then we deliver, we do a final scoring based on the what is lagging. And we don't really, like even though there are ads that may be totally matching the specification, we may end up giving an ad that is not as well targeted based on the revenue criteria. So it's just a segregation of logic. And again, we just replace them both with only one scoring component that you want it on. Event processing pipeline has two steps. It just records the event impression or click, it writes to the event log, and then the CAS redirects the user to destination. In terms of the content targeting, if you think of that end-to-end, there are two major steps that are involved. And they need to be kind of procedurally followed together. There is no enforcement in the system to make that happen. Now, the first one is that the backend ad storage system must be tagged with the appropriate tags. If you run a campaign with 15 ads in there, each of the ad may have some tags. So what the ad sales team typically does that they have to tag the different content with the appropriate tags. And then applications must specify those tag names to CAS when they're selecting that ad. So there should be a synchronization of the tag names that are used in the ad storage, what the application specifies. And those names, we specify that. We have the names as we receive from the client. Like, for example, the client ticket has a whole lot of information about what the client capabilities are, what the user information are. And we use those tag names when we call the backend. And the backend storage needs to have the same kind of attribute. In terms of names that we have these 5 different categories of parameters. We have request side parameters, which is the application-specific parameters. Environment attributes such as time zone, etc. Ticket attributes, what we receive from the client ticket. We have device and client attributes, capabilities, and then subscriber user attributes. All these attributes are available together to the backend targeting to make decisions on. In terms of the request side attributes, we have 4 of them: the height and width, self-explanatory, we know what it is. Then we have what is called a service region. Service is the name of the application. Like, for example, for home is a service, mail is a service. And within that, we define this further granularity called region. The reason is you may have a home page. Currently, it has 2 different areas where you can have add or content delivered. You may, for example, somebody else may define a new template for the home page that has 5 of them. So the region may have a different name depending upon which that you're trying to fill. And the back add must be tagged with those names so that you can match them appropriately. Then in terms of environmental attributes of the local time, client version, or the version of the TV pack client that is running on the set-top box. Ticket attributes, I'm not going to go through all of them, but this is most of the things that you can see in the standard ticket in terms of the client user attributes and the client capabilities. And all of them get delivered to CAS, and CAS makes that available to the backend ad system to make the decision for targeting. Also, device and client attributes, I'll be more than happy to give you the slide. I won't read that feed through. And one question obviously comes in here. This is convoluted names. Why do we have this kind of names? And some of them don't make any sense. Like, for example, this has some kind of a history to it. If you go back one here, let me see, client supports Funk E release or something like that. So I'm looking for that. So now it has Spot Ads 1 and Spot Ads 2. We define the original. Oh, there it is. The classical services. Client supports classical services. So there is some web TV kind of historical background to these, and these are available in the ticket. We are currently thinking about providing flexibility for the back-end operator to change these names. The way we are currently thinking about that is go to the Atlas configuration system, the TV pack configuration system, and provide these names and map that to different names. Some backends make that mandatory. Like, for example, Acipiter is one of our competition in terms of ad serving machine, and they cannot have a tag name that is more than 10 characters in length. And we have really long names in here. So what the deployment time, you could just go into the configuration file and add a bunch of names which are these and map them to different names. If a name that is appearing here is not in that list, we will never pass that over the backend. So there's more control over the names, and what you want to pass to the backend can be achieved that way. All right. And in terms of, in addition to all these parameters, if the deployment is using Commerce Server, there is another way of doing targeting also, which is what we call the implicit profiling. Like, for example, let's take the example of AT&T. Let's say AT&T has a website where people go there and subscribe to many of their services. It has nothing to do with their device, set-top box device. Let's assume that they go to their cellular services site and they pick and choose what they want to do. Now, AT&T might want to do some targeted ad on the set-top box device for those users who have the long-distance service with AT&T but do not have an international client. So what they could do is they could run a query on their databases overnight and put that information into Commerce Server user profile tables. Once that is done, automatically those attributes are used for targeting as well, in addition to everything that we provide. Again, I want to make sure that this feature is not available if the MSO decided to use some other ad targeting system. It is available only for Commerce Server, and it is using user profile as a mechanism for that. So as a deployment time, what you will have to do is you have to use Commerce 4.0 user profile designer and create additional fields. Like, for example, has a long distance plan, yes or no, has internet calling plan, yes or no. And all these attributes must be populated through some other mechanism other than through TV pack server using standard SQL database interfaces. And once that is done, then you are just done. You don't have to do anything to modify CAS or any of your applications. It automatically takes into account all those implicit profiling. And also, the UPM has another facility to track the history. Like, for example, if I give you a Ford advertisement about a minute back, I don't want to turn around and give you the same ad again. So we want to be able to track how many, what kind of ads have been delivered to the user. And that is done through User Profile Manager as well. Currently, Commerce Server handles or remembers the last 5 ads that are delivered to the user So it makes sure that it is not repeated itself of the scoring process. And writing that the ads that have been delivered to the user, we found that to be time consuming. So we may, at the 1.0 time frame, remove the record event component off of the pipeline so that we will not track the history. And if you want, you can just go back and add that in there, but there is a performance implication on that, which we totally don't understand at this point. But we suspect that many of our customers may not want to have a lot of performance delays on that. Any questions on question?
Is there anything different about ads in the EPG? I mean, that's just a different size, different region, different, but it would work exactly the same way.
Question is there a difference between the ads that are in the EPG grid? They are different size, they look different, but it's the same kind of concept. The answer is we will talk about that in the next presentation. And the short answer is that we will not do EPG ads in 1.0. But when we do that, EPG will call CATS to get the ad.
I'm just wondering if there would be additional sensitivities about putting ads, you know, if you've got video for one program, putting an ad for a competing program up against it.
Right. The Commerce Server has this really powerful expression evaluation where you can say exclude any ads that have this type. So not only does targeting based on what should be included, it can also do targeting based on what should be excluded. So we can definitely use that facility to make sure that there are no conflicting ads on the EPG grid appearing. Yeah. Any other questions? All right. Going to switch and go. All right. So again, coming back to EPG, we want to talk about the electronic program system, the system overview. The reason why I'm talking about that is just to give you some ideas of the end-to-end dynamics. Who does what? What's the business context for EPG? And then we'll go into what we support in that entire spectrum of EPG business, and we'll talk about the design, what kind of options do we have, and we'll talk about some of the plans that we have for future of EPG beyond 1.0. In terms of the EPG system overview, it all starts with some listing providers. Providers compile the data like TV Guide, TV data, and they collect their data from various sources and they make that available for people. So their business is to sell that information to people. What we do is, right here is the MSO, the multi-system operator head-end. And they want to receive that information from the listing provider and make that available to the end user through the set-top box device. So that's the end-to-end picture. It may be possible that a space system vendor or multiple system MSO might want to have relationship with more than one listing provider. It's not today, at least based on the information that we have about various MSOs, many people do have only one listing provider. But we've learned that there's some pain in relying on only one listing provider, especially the area of translations. If you want to have the same listing available in 15 different languages and it's done by 15 different companies, why would you have to have all those go through that one listing provider and have them do some special logic for you and incur additional cost and a lot of different business dynamics behind that listing provider. So in terms of our implementation, this is what we consider to be the business. A system head-end must be able to collect information from multiple listing providers and consolidate that to be able to provide that to the end user. And for our feature highlights, we do support multiple listing providers, and we have a comprehensive database at the server side to store the EPG data. And our EPG implementation is much different from the DPR release to 1.0. In fact, we could even think of that as, in more senses, a new beginning for EPG in the 1.0 time frame. The DPR's release, we have all the EPG information stored in flat files and different dictionaries. We did not have a database. And in the 1.0 time frame, we do have a database, and we create the files dynamically to be given to the clients based on what the client or the setup is requesting. And through all of that, we have totally focused on an extensible architecture. We wanted to have a transport independent EPG system. What do I mean by transport independent? For example, from the head-end to the set-top box, the EPG data can travel in multiple ways. We don't know what way it is, and we want to be agnostic to that transport. It could be an IP connection, or it could be a broadcast, or it could be a web page that is requesting information to deliver to the user. So we want to be totally ignorant of that, and it is independent of that transport. Then we have a listing provider format independent. The moment we say we support multiple listing providers, now how are you going to bring all these listing providers together and have them agree upon the format? That might happen down the road, but to start with, we do not care about the format in the sense that we could receive data in multiple data formats and be able to consolidate that into our database. We also are independent of the client PG data format. We support a PGL format in our current set-top box, and that format is somewhat extensible for multiple languages. So if we wanted to deliver multiple language EPGs, we could just improve that data format and deliver the data. At the same time, we want to be able to also deliver DVB formats or any other format that may become necessary in the field. And so we want to be extensible in that regard as well. And also we have, in terms of the merging of the listing data, the head end, we provide what is called a simple merging. Going back to the previous slide, we talked about multiple listing providers giving data. And some of the situations is that you have one listing provider per language, or you trust one listing provider more than the other ones, or you have listing provider one providing data channels 1 through 20, but two providing 25 to 65 or whatever. So there are all different possibilities may exist in terms of how these data should be brought together into one piece. For the 1.0 time frame, the only way we allow is simple merging is in the sense that you need to have a segment data based on channels from listing providers. We don't provide language aggregation yet. We do not provide priority-based aggregation yet. So for the 1.0 time frame, it's going to be a simple merging of the multiple listings. And if two providers provide data for the same channel, the second one will override the previous one. And the order of execution depends on how you schedule the jobs. This is our logical design. So we have all the listing providers, and this here is our system head end. And we have two task force, IP network or broadcast network, going to the client. The first step in the process is to get the listings into the system head end. We do that using a staging directory. It may be a simple FTP transport, or it could be some mechanism that you expose to the listing provider that they can initiate an action to post a file into that directory. So as far as we are concerned, our processing starts if a file is over here. At the same time, we do provide an optional FTP component at the deployment time. You can specify, saying that, all right, my data is coming from this specific URL. This is the FTP username. This is the password. Use this all the time to download that. And I want you to try to download every day at 5 o'clock in the morning, or try that every hour. Just you can schedule that in whatever way you want. And if the FTP step was given in the EPG side, we will do the file transfer through FTP. Not to say that FTP is the only protocol, but out of the box, you have only FTP available. If you have other mechanisms, you could write an additional job step that are in there for your processing. And once the file is in here, we have, again, the same kind of architecture. We call it pipeline architecture. But the difference is that in EPG, the pipeline is implemented using DTS job steps, SQL data transformation services. In the case of CATS, we use a total COM paradigm that you have a COM object called pipeline that call different COM objects. In here, the reason why we chose not to do that was many of the transformations that you want to do could be SQL aggressive. You might want to do select state, insert, or updates and deletes and transactions begin and commits and all of that. DTS was the language choice for us. At the same time, DTS also allows the extensibility to go out and call a COM object. So you can create a COM object and call that COM object, and one of the DTS job steps want to do something really high performing and something so specific to your needs. So the listing load pipeline process gets invoked when the file is there, and the data is transferred from the listing provider format into the database. Be able to specify multiple listing load pipelines, one per listing. So that's where the data format independence comes from. You might have different parsers in different pipelines, so you'll be able to do that. Once the data is in the EPG database, we have a listing extract pipeline which supplies the data out to the clients. It could be a web page, it could be a set-top box calling through an IP network, or it could be a broadcast agent trying to broadcast EPG data to all the clients. So all of them are clients, and they call the listing extract pipeline, and the extract pipeline gets the data, formats that in an appropriate way, and gives that over to the client. Now, I labeled something here called production tables and something here called staging tables. The reason for that is that the staging tables contains invalidated data, or data that has not been validated yet. When the data comes from the listing provider first, it comes as files in the staging directory, gets transformed into some portion of the database that is staging tables. It is not being seen by the client yet. So you could theoretically have two different sets of data. One set of data currently being seen by all the users through the listing extract pipeline, whereas you have a staging table having a different new set of data that you're still validating and working on. And once the data is validated, the data is moved into the listing, the production tables. That also allows us to provide some kind of neat capabilities like the user may be able to go into an MMC console on the server side and view the EPG just like how a client would see that and make any modifications to it using the staging table and then push that over to the production tables. Coming down to the client over here, we are told the client delivery is totally centered around client configuration services. Client configuration services defines a channel manager or channel file that's registered, which allows the IP network unicast. That is the only path that is supported in DPR. We do not have any broadcast in DPR. In one panel, we are planning to integrate a broadcast agent that is being worked on by another team, and Dave is coordinating that effort. And the broadcast agent is not a topic for this session, but on a high level, broadcast agent basically brings the broadcast hardware into our system. Basically defines an interface where you would be able to work with the GI broadcasting or Philips broadcasting or any other broadcasting vendors that you would have. You could buy their hardware and expose their APIs to a COM object so that we could take advantage of their broadcasting system. And based on that broadcasting system, we would be able to provide throttling of information using data carousels on the server side. We'll talk a little bit more about carousels in a couple slides down. But that's the high level what is the broadcast service is all about. And the listing extract pipeline doesn't care whether it's the request is coming from a broadcast agent or from the client directly. So that's the high level picture of what the different components we have in EPPG.
Is the broadcast agent DVB agnostic? Does it care whether it's supporting DVB or ATSC or anything else?
The question is, does the broadcast agent care about the data format like DVB or HTSC? Does it have any specific for that or specific for that? The answer is no. It doesn't care about that. And Dave can answer more. Dave, do you have any more information to add on?
Yeah, I agree with the response. We don't care because we've designed this API, Suresh mentioned, to abstract our servers from whatever particular broadcasting gear the operator uses. It could be VDI, MPEG transport stream, IP encapsulation, DVB, VSMCC, or any of those. We need to deliver the data to whatever it is in a consistent way. It's our API that does abstract those different things.
Right. So going to another level of detail in terms of the pipeline design, exactly how we do the listing load and the extract pipeline. Again, there are many different stages that we have defined here. Not all the stages will be implemented by us out of the box, and the user does not have to have all the stages in there. But we want to kind of come up with our notion, and also for IP purposes, it's very important for us to make sure that we communicate our entire idea into one area. We can get IP protection for all of them. There are some components here that people have not thought about so far, and we believe that it's very valuable for us to get IP protection, and that's the reason we have all of the stages defined in here. So this is a download listing, the FTP, and the file stage translates the file, parses that, and puts it into the staging tables. The staging table does the validation, make sure that all the data is valid before moving that to the system. If it was an error, this component can also trigger an email back to the listing provider. And at this point, the staging to system has about 3 different things to do. It aggregates multiple listings, because simple aggregation is what we're doing right now. But in the future, we would also allow language-based aggregation and priority-based aggregation. And then it also provides what is called, the first one is the aggregation itself simply is not being thought of in the industry. Nobody offers that, and that's why it's valuable for us to mention that. The second one is handle translation. Translation is something very expensive process. What people do is they just go off getting some translation services company to translate them into multiple languages. But if you look at the EPG listings, for example, the serial cops is appearing so many times on the EPG listing. And why would you want to translate that program 500 times through the year? You don't want to do that. And it's not one program, it's scores of programs. What we do right here is we get the data in one language, which is your primary language. We go to the database and figure out if you have the translation for that done already. If not, we write out a file saying need to be sent to translation, and then we go on. Then the MSO can take a file, or we could write a component to take that and FTP that down to translation service, and they can come back and submit a translated file to the same job and aggregate that. It's as simple as that. But again, I want to make sure we understand. We don't do that in 1.0. It is just a concept at this time. We want to make sure that it is documented. We want to make sure that we get the IP protection for that. And translation storage is something that will be coming on in the future, not right now. And we also will go through our cache files, the files that are already generated, and mark them dirty because they need to be generated next time they are requested. Do a log event, notify the provider that everything's done. So that is the input side. On the output side here, you can select the UPG data, add interactive selection links, add of links. This is where ad advertisements come into picture. This stage we'll call CAS to get some ads. Again, CAS can deliver multiple ads, not only one ad, and those ads will be merged into the EPG listing and format the data into PTL. Now, this can be swapped out and you put a different component, format that into UP's DVB format or anything else that you want to do. And we have digital signature, transport the data. So that is, we conceptualize the extract pipeline or how the data goes out from the EPG system client. Any question on these details? All right, now we come to the deployment model. In terms of scalability, how do we really do scalability? Before we do that, I want to make sure that I talk a little bit about data carousels. I don't know how many of you know those terms, and maybe a repetition for you. Please forgive me if it is.
Might as well define what it is.
Okay. So broadcast world, or the DVB world, the data is transmitted in what is called carousels. So in an ideal broadcast environment, for example, for EPG, let us say we might define multiple chunks of data. We want to do present following information, which is what is running right now, what is coming next. That much information to feed the broadcast stream constantly. That means this data must be broadcast every 10 seconds or every 30 seconds or whatever that. Very high frequency, very low granularity. And then the next level of granularity may be 6 hours. So what's going on in the next 6 hours? Now that data may have to be broadcast only 1 hour. And then a day long of data will have to be translated only every 2 hours or something like that. And as the system operator, the MSO makes a decision on how many carousels they want to define and what amount of data they want to put in each carousel. And these carousels spin at the appropriate time to get the data out into the broadcast stream. Our job is to implement the carousels and provide throttling. So you go in there and say, I want to have 6 carousels, 6 levels of carousels. This is how much data I want on the carousel number 1, 2, 3, and 4, and I want this to spin every 5 minutes, every 20 minutes, or whatever. And just to put that into context, UPC is planning to do 4 levels of carousels for broadcasting EPG information. And only the carousel support is added by us. The actual transport mechanism is provided by the broadcast vendor. That is where the API that we talked about comes into play. Now, going back to the deployment here, ideally, again, I come back to UPC because we talked to UPC quite a lot, and we find that they are a very ideal customer for us to learn from. What they have is they have about they have more than 100 headends, or they call the affiliates. So they have the EPG data for let's say for most of Europe in one place. It's a lot of data, tons and tons of data. But not all the data is used in all the places. There are different affiliates, they have different names, they have different pricings for different pay-per-view programs, and they have different languages that they offer. So all of them don't want to get all the data. So the way we conceptualize that is there is one headend that we label as system headend. The system then will receive all the data from the listing providers, and it gets processed at one place. And each of the affiliate headers, we have SQL replication. So we publish the data, a subset of data that is necessary for each affiliate, from the system headend database. And each of the affiliate headends subscribe to the data. So it's all done by SQL links, assuming that all these headends are on a fast Ethernet connection on it. So that is one of the deployment options. The other option is to do everything at the same header and then distribute only the TTL files over or any other mechanism that you may want to do. And in terms of this, I don't have other information here in the slide, but let me mention that in terms of our deployment strategy for 1.0, we are expecting that there will be one EPG server per service group, and we don't provide replication between the service groups at this point. So we are thinking of doing the same way what we are doing in the US services today, which is each of the EPG server, even though they just are part of different service groups, they receive all the information from the hosting provider, they do all the processing themselves. That's what we will support for 1.0. But for beyond 1.0, we might provide more sophisticated replication support between service groups as well. And in terms of the deployment between the system headend and the affiliate headends, we don't have any MMC controls to make that happen. But you have to go through SQL UI to set the subscription and publication. Any question on the deployment model? Right. I have two slides, I guess, on the future. There's tons and tons of things that we're thinking about. Just to give you a taste of what's coming, and we're not planning to do that for 1.0. Again, first one is advertisement delivery. We want to add ads to the EPG. We want to do notifications to the listing providers. Right now, we have one notification component that just tells gives a timestamp, where's the file. That's the information it gives. But we want to have more detailed information on what failed and provide total notification system on the processing. Then we have a multilingual EPG download. I had to clarify what is multilingual EPG download. Today, in the 1.0, we will be able to send listings in multiple languages. But for one set-top box, we will always send only one language, not multiple languages per set-top box. When I talk here multilingual download, that allows you to send more than one language to a specific set-top box that the user can dynamically switch between languages. The user may say, all right, I want to be able to watch the EPG grid always in English, but I happen to see there's a French show on there. I say, oh, I know read about this program in French. So they could just briefly switch over languages and come back. And that is what I'm talking about with multilingual here. And we also will implement an XML-based listings load. There's nothing stopping people doing that today, but you want to do that out of the box in the future. And we will also provide template-based EPG extract and multilingual program descriptions and narrations. Like, for example, you might want to see the title in one language, the narration in another language, or vice versa, or closed captioning in another language. So all of those different combinations will be available. Continuing with that, there is this request called randomizing sequences of broadcast. Assume that the client knows what broadcast schedule is for the day, and at the head end there's some commotion, something happened, they want to switch it. So instead of going programs 1, 2, 3, 4, 5, which already was being communicated to the client, they are going in the order of 1, 3, 5, 2, 4, or a different order of the same programs. To be able to do that, we want to be able to broadcast a different randomizing sequence and have the client rearrange the EPG appropriately. And we don't do that for 1.0, but we are planning for that for the future. And also, we have something called alternate schedule support. Again, this is more of a European touch to it, because see, you have 5-day crash going on, morning till evening, right? And nobody knows if the play is really going to happen. If it rains, the program does not happen. So what happens if it rains suddenly? We want to be able to send an alternate schedule to the box and say, hey, box, I'm switching to this alternate schedule because of rain in the match. So it automatically switches to an alternate schedule. And also, we want to provide program overrides that allow the original schedule to be changed to backup schedule that's slightly different from the alternate schedule. And also, we want to provide a tiered access control of EPG fields between the system headend and the affiliate headends. Like, for example, most of the program information does not change between system headend and the affiliates. But some information, such as pricing, might change. So we will be able to allow access control of the EPG data in a more granular way between the headend operators. And then we also would would allow priority-based and segmented data merge, as we talked about earlier. So what can be done today? Take your DPR and you can run with that with the files. And 1.0 will have complete compatibility with the DPR release in terms of the data formats. And deploy that with 1 or 2 headings, and we'll be all ready to go for future expansions. Question? Where do you want to go today? Thank you.
Okay, so Mike, you're up. Okay. As I said, I'm not Peter Chain. I'm Mike Caron. I manage the group building service applications. Makes more sense for me to talk about that than Peter. Peter did say, though, that if you have any questions on the topic, you should feel free to call him anytime, day or night, and be happy to respond to it. I'll put that up here in a minute. I also understand that I'm the last thing before the break, so I'll try to be quick. But stop me if you have any questions. So what I'm going to talk about is which server applications we're doing at a high level, how they're put together, and from that we can derive what the customization story is. We'll look at the technology and see how you can use the technology to pull it apart a little bit and reassemble it in a different way to meet the needs of individual NetOps. So first of all, when I say applications, what I mean are server-side applications, which is pretty traditional web-based applications. URLs come up, HTML goes down. These are not applications that are built into the client like the EPG. So the list is web home, centers, mail, although this actually isn't being done in my group, it's being built in a similar way. Favorites, the search application, help, registration, which is the application that guides the user from having a brand new box in their living room to being signed on to the service, and some application it's actually broken out into 2 separate ones called Things and Account. So these are the applications that are covered by what I'm going to talk about, and now what I want to get into is how they're put together. So the basic idea is, here's your TV, here's your set-top box, cable, no antenna, sorry. Yeah, I've been drawing it that way for a couple of years, but that no longer applies. Some cable connectivity. This represents an application backend. An application is a COM object. But the flow of information, as I said, is URLs go up from the box. We send HTML back down, and then it shows up on the screen as something. And that's basically what our applications do. In a little bit more detail, the URLs that come up this is an example of what one looks like, WTV, NTT favorites, / folder list. So this part identifies which application COM object the request should get routed to. Everything after that is specifics about what that request is asking to do. So you can imagine that requests for the mail application would be, show me which mail I have in my inbox, show me message 27, reply to message 82, things like that, encoded as URLs coming up. The HTML that comes down is more detailed than I get into, but that's pretty much everything that's supposed to go on the screen. You might look at this and wonder, let's see, this URL doesn't tell me which user this is for. There's a lot of users that have favorites, and they all have folders. So implicit in this diagram is another thing called the ticket, which I trust someone has talked about. Anybody talked about the ticket before for me? Okay, good. So the ticket is sort of like this magic cookie-like thing that has extra information, including which user we're talking about, which box, other things like that. So that helps us figure out on this side how to respond to this request that comes up. In a little bit more detail, so we'll zoom in on this part of the picture. what this looks like is, by the time this request gets to me, gets to my object, it's already been parsed and decorated and turned into an XML tree. That XML tree comes into sort of this process. This is like some Batman-like machine. The XML goes into the hopper, and what comes out is new and better XML, and that goes into some other process, another little conveyor belt thing, and out comes HTML. So, make this a little more clear. This is the raw request. It's basically the URL and the ticket and some other information parsed into a single data structure that's XML so that our applications know what to do with it. This is the application C++ code embodied as a COM object. So for this particular request, show me my folder list. It gets parsed into XML. All the parameters and the ticket data is in this tree somewhere. The C++ code gets it, chews on it for a while, looks wherever it needs to look to figure out what folders you really do have in your folder list. It looks in the user store, it looks in the database, or in the case of the mail application, and it reaches out and talks to Hotmail. But this gadget here does whatever it needs to do to answer the question being posed by this request. And the interesting part of the architecture is that rather than going directly to HTML, we represent the answer in an intermediate form as more XML. So maybe all these blue nodes were already there in the original request. Who's asking, what they're asking for, properties of the service upon which they're asking this question. Those are still in this tree, but we've gone and actually answered the question. This user with this ticket in his folder list has folders A, B, and C, and inside folder C there's favorites F1 and F2 and F3. So we come up with a richer XML representation that is really the request and the response, still not in the form that a human being would necessarily want to look at. We feed that into our rendering engine, Jinx, out comes HTML, and that's what gets sent out to the service. So this whole thing is what happens if you open up the hood on that and look inside. So Jinx. Jinx is an interesting beast. So we're going to talk some about Jinx, but one of the myths I want to dispel is that our applications are written in Jinx. They use Jinx, but there's actually a lot of other things going on. So if you took ASP and XSL, two famous Microsoft acronyms, and put them in a blender, you'd get something very much like Jinx. If you open up a Jinx file, what you see, so we'll expand on this. Here's simple Jinx. So, like ASP, Jinx is essentially HTML that has been marked up with embedded script tags, and those script tags get evaluated on the server side before this HTML is sent back down to the client. So, and if you actually look at a Jinx file in Dev Studio, it actually highlights these things in yellow, but my whiteboard technology can't quite do that nicely. But anything in a green box is a Jinx can embed in this HTML. The green stuff gets evaluated, and it gets sent down. So this is saying if this data is in the XML tree, if it's in the XML tree that this is rendering, then spit out hello, otherwise spit out goodbye if the whole thing is wrapped up as HTML and sent down. So Jinx has, let's see, the attributes of Jinx are, like I said, HTML with embedded script. It has ASP style delimiters, that's less than %, greater than is familiar to anybody who's done ASP coding, very similar to syntax. And it has, so this is sort of like ASP-like. And this part here, which is go in an XML tree for some, and then make some decisions or render based off of that, that's derived from XSL. Writing exceptions up here so that if I have time, I'll remember to come back and talk. This is the way most of our applications work. There's things that are different. I'll come back to that if I have time, but I don't want to keep you from your cookies. So a question that we've been hearing a lot is, why do we do this? Why did we go and make Jinx? Why do we invent this whole new language? Because Jinx is something that exists only in Microsoft TV Server. The answer is because other candidates tried ASP and XSL had problems, and we had to address those problems, and we couldn't do it within the framework of either of these two languages. For ASP, the problems basically boiled down to the performance and scalability wasn't there for the type of massive customer that we're anticipating support, and the localization and customization story, which are really facets of the same thing, and I'll get into that in a few minutes, wasn't strong enough to do what we wanted to do. A little more detail. TV Pack has a huge range of different customers. One installation may support people with NTSC TVs, PAL TVs, 16:9 TVs, 5 different countries, 8 different languages, 2 or 3 different levels of service, 3 or 4 different clients, and it has to vary the HTML that it sends down based on each of those axes. And ASP just really wasn't quite up to the task. XSL is an interesting technology. If you asked what XSL does, it does exactly what this little box does here. It takes XML in, chews on it, spits out HTML. And we tried for a long time, a long and painful time, to make XSL work for us. The problem we encountered with that was that even though it looks good architecturally, it's actually very, very promising for certain class of problems. It didn't quite go all the way for us. Basically, the first 8% of what we want to do in XSL was beautiful and easy and simple, and the last 20% was just flat out impossible. You could not get there from here. Try as we like. So XSL is pretty good at rendering pages up to a certain level of complexity, but our pages were more complex than that. Excuse me. I said that there was a myth that applications are developed in Jinx, and I want to explain that in a little more detail. Jinx is just the final step in a processing pipeline, and it is one of the many technologies that go into servicing this URL. So saying that Jinx, our applications are written in Jinx, is kind of like saying cars are made out of paint. Yes, when you look at a car, you see paint on the outside. And maybe that's stretching it too much. It's like maybe saying that cars are made out of paint and sheet metal. So that's largely true. You know, you can't make a car without paint and sheet metal, and the paint and sheet metal really kind of defines what a car looks like, but a car is going to do you much good without wheels, transmission, engine, things like that. And the analogy here is, you know, we're the sheet metal and paint, but things like the user store and the database and something called the server manager and the logging system and the configuration system and a whole bunch of other technologies are what this thing does to actually answer the question. So when it says, go get me my mail or go look at my favorites, this process here is doing a lot of work representing it as XML. This is just drawing it. Now, a lot of pages on a website are just drawing. So for a large number of things, this doesn't do very much. Like you can imagine for the instructions application or the health application, the thing that says, you know, this is how you put a favorite into a folder. This is very little or nothing. But for a lot of applications, this is pretty substantial. Yes?
Jinx is working like a filtering program,
basically. It's output. So we have data, and we have worked on representing all our data as XML, and that's good for sort of like process-to-process communication. No human being wants to look at XML. So the last step is to just present that data on the screen in HTML. So, like I said, for favorites, this would be like nodes representing each folder, nodes representing each favorite. Each of these would have maybe a name and a thumbnail. So it's just a tree that represents the data, which is fine conceptually, but not what the user wants to see. So this last step is just what through this tree and says, for each folder, I'm going to draw a little tab on the screen, and for each favorite, I'm going to draw the thumbnail and the name and make it a link, and that's what Jinx does. We have for loops that do exactly that. If you opened up our Jinx files, that's what you'd see. I'm out of board. I wanted to zoom in a little bit more on this part. I like it. I'm going to wipe this out because this isn't very interesting. So I'm going to explain a little bit more what the internal structure of this is. The purpose of that is to start explaining how people can do customization. Because as you can imagine, the customization kind of happens from here down. Like, this part doesn't change very much, but you can change this to change the HTML that comes out. So I want to explain more about the internal structure of this, because that's basically the input to the customization process is this XML. So we have something that we used to call the one true tree, which is effectively our schema for all the XML that ends up at this stage of the process. It used to be called the one true tree because now we can actually support many trees, and we haven't come up with a better name for it. So it's the tree formerly known as the one true tree. It has an internal structure, which is like this. This is not complete, but it's sort of gives the idea. Okay, so let me walk through this in a little bit more detail. So all trees that end up in this stage of processing are a subset of this schema. They all have a root. They all have an application branch. The application branch is where the data that's specific to the original request that came in way over on this side of the board is stored. So when we say, get me my favorites, this is where we put the favorites. Or show me the mail on my in tray. That goes here. Or how are my stocks doing today? The stock prices and symbols go in this part of the tree. The rest of the tree is boilerplate that's common across all applications, so that all of our applications have a common development story. The schema is the same, but the actual data in that schema varies. There's a branch that we call the context, which is stuff about the request, but not things that are actually in the request. So all the fields that are in the ticket get parsed into the tree and put in this branch. The abilities of the particular client box that we're talking to, this guy, get parsed and put in this branch. So if that box has a hard drive, we'll know about it. If it has a printer, we'll know about it. So these are things that can help us make decisions about what the final HTML to do or what process to take place. If we ask for it, and only if we ask for it because it's expensive, we can look up stuff in the database, either the user or the subscriber or the device or combinations, and stick those in the tree as well. And if the URL that came in had some parameters on it, like A equals 1 and B equals 2, then those would show up in the tree as well.
And so that almost gets us to the point where we can talk about customization. There's one more thing I want to talk about. That is the synergy that happens between Jinx and ABC. And no one's talked about ABC, so perhaps I should. ABC is another technology. It's one of those other things that are sort of like the engine of the transition that go into making our applications work. It stands for attribute-based content. And the great thing about ABC is that it's very simple to explain, and it does what it does very well. So what ABC does is, if you have lots of choices, it picks the right for you. So if you have to decide, should I give this guy Japanese strings or German strings or English strings, ABC picks. Or you have to decide, is this guy on an NTSC screen or a PAL screen, ABC picks. Or do I use the AT&T branding or the WebTV branding on this page, ABC picks. So basically, anywhere where we have a number of peers to choose from, based on some potentially god-awful logic for deciding which is the right one, what ABC does is a couple things. It isolates decision-making from the rest of this picture over here. This is a lesson learned the hard way from the U.S. service, where all of those decisions were baked into the code. Like, in about 3,000 places on the U.S. service, maybe that's a slight exaggeration, but in way too many places on the U.S. service, we had to decide if a user was in Canada. And if they were in Canada, we would put up a Canadian flag in the around town application, and we wouldn't ask them for their zip code, we would ask them for their postal code. And we tried but failed to spell favorites with a U instead of, O-R-I-T-S, but that proved to be technologically impossible for us. And a large part of that was because we had a zillion places in the code where we were trying to decide if someone was in Canada or not, and if they were, do one thing, otherwise do something slightly different. And the two ugly things that resulted from that are you had the same decision, or the same conceptual decision being made in lots of places in potentially different ways. Like it used to be that we decided if someone was in Canada by looking in this particular bit over here, but then we found that wasn't sufficient because some guy in northern Montana looked like he was in Canada, he actually wasn't, so we added this other test for him. But we only got like 209 of the 300 places where we made the decision the old way. And ABC factors that into one place. The other thing that it does is it gets all that ugliness out of the code. Like rather than saying, if I'm in Canada, serve a Canadian flag, else serve a U.S. flag, which breaks when you add Japan, because then you have to make it else if I'm in Japan, serve a Japanese flag. You just say, get me the right flag, display it. And so ABC sort of allows you to strip out a lot of real ugly special cases from your mainline processing and factor it all into these isolated decision files where you decide at some point in the future that your test for Canadianness isn't sufficient. You can improve it in one place. Everybody makes a decision the same way. None of the other code changes. So that sounds like good stuff, but how does that apply to this? Well, we use it a lot inside this box in Jinx to do the final rendering. And the way we do that is when we draw a particular screen, we divide up responsibility for drawing different pieces of the screen into different Jinx files, and we use ABC to pick the right one based on language, the size of the guy TV, what city they're in, what instant they're in, what type of client they have, and however many other factors we need to worry about. So let me draw that and show how ABC helps us. So here is a canonical screen. We have a sidebar. We have some logo up here, some strings. Maybe it says favorites. Favorites for me. We have some folder tabs, and then maybe a done button. And these have text on them. So there's actually quite a few files that go into drawing this screen. I'll list some of them. Screen, branding, common. Yeah. Page. Sidebar. Okay. The list is screen, branding, common, folder list locale, basic page, and sidebar. And what they do is the screen, ABC picks the right screen file, and the screen file defines things like how many pixels by how many pixels. If it's 16 by 9, it's one number, and I've had a very hard time figuring out what that number is, but I think we know now. If it's PAL, it's another one. If it's NTSC, it's another one. So that picks that. Branding is responsible for drawing that thing. I'll come back to common. Sidebar knows how to draw things like that. It has a logo, some buttons, and an identity element that identifies the application. Basic page is even more conceptual. It just kind of knows the idea of something with a sidebar and something with content to the right of it, with a background color of dark gray and text color of kind of light green. Common defines the things that are common to all screen in the favorites application, the color of the sidebar, this graphic, a couple of other things. Folder list knows how to draw these artistic little tabs. And it's drawing those based on walking this XML tree. It walks this XML tree, and for each node, it draws one folder or tab. Folder list locale knows whether to say favorites for, or whatever the German equivalent of favorites for is. It also knows that even though this is a graphic, whether to use the English or German version of this graphic. It also knows how wide to make the star, because in German, maybe not all these things quite fit, and you need to cheat, move this thing out 10 more pixels so that the big German strings don't fall off the end of graphics. And so you can see how, with ABC, picking one of three possibilities here, from our perspective, one of an infinite number of possibilities here, even though a given installation is likely to use only one branding, we have to worry about all of them. One of one here, that's not very interesting. One of n here, where n is a number of languages. You can get this page built highly dynamically on sort of a large and extensible and variable set of attributes that define the specifics of this request. The other thing is that, hey, maybe you don't like the way I drew a sidebar. Personally, I think it looks pretty good. But if you want it, if you're AT&T and you want it to look like that, if you replace sidebar.jinx and you have ABC pick it based on, whatever your rationale is for deciding when you want sidebars that look like this versus sidebars that look like that, then ABC will pick the right one at the right times, kind of auto-magically, and everywhere in the system that we draw a sidebar that you want it to be drawn differently, it gets drawn differently. Now, I shouldn't oversell that too much. Sidebar still kind of assumes that it occupies like some rectangle on the screen. Like you'd be hard pressed with a Jinx file to turn the sidebar to something that appears here, and here, and here, and here in a circle in the middle. Like, that's not going to work. But if it's kind of over on the left side of the screen, you can have a pretty bit of leeway in drawing sidebars just differently. Again, sidebars draw based on a certain API. There's a logo up here, some text here, and a graphic here. And you can imagine different mappings of that, and different font treatments, different graphic treatments to produce different results. So given all that groundwork, I can spell out the customization story with a more complete picture. Really, three types of customization that we can do. There's really simple customization, which is just changing the branding. That's good for trade shows and for partners who want to get something up and running quickly. There is skinning, and then there's using the app APIs. So branding is going all the way back over here. My apologies to the cameraman. use ABC, pick a different branding file. The branding file implements a different set of Jinx templates that draws the logo the way you want to draw it. This file actually has about, I think, 6 different templates that represent 6 different treatments of the logo, how it appears on this kind of page, how it appears on the home page, how it appears on the registration pages, because it's slightly different. It's not just a different file. It's how you place that in a table cell and the spacing to center it and make it look nice. But if you rewrite those 6 templates, then you can put your logo in there. So this is pretty straightforward. And you can also do different things, like if you want to change colors, then you can use Jinx to pick a different set of colors. Skinning is what happens if you want to achieve a more substantial change in the appearance of an application. And so what that means is, getting back to this diagram, you have the same XML, which was computed in the same way by the same engine here. So the car still has the same transmission, and it's not going to go from a 4-speed to a 5-speed. But you can strip off all the panels and paint purple if you want. And that's what skinning is. You basically rewrite as many of these Jinx files as you need to achieve the desired effect. And again, you're not going to turn a VW into a Ferrari by doing this, but you can turn a VW into something that looks pretty different. And more specifically, and backing away from the overextended car metaphor, the kinds of things you can skinning are, you can change the appearance of a page pretty substantially. You can add new links. So if you wanted to add a new link page, that's just extra HTML. You put href equals the place I want to go, and you just add that onto the page. You can add new scheduled content using cats. So you can just drop in another region on the screen where you want an ad to appear. So if I wanted to skin this but put an ad here, I could just from Jinx it says, go ask cats for the ad to go in the space, or the promotion to go in this space. The things that you can't do is change the fundamental client-server interaction or change the page flow. When I click on this button, I'm going to go to the same place. It may look different, but I'm going to the same place. Or change the data model. You can't make new data appear in this tree, which is then going to get drawn on the screen somehow. So you can take the same data, the same page flow, dress it up differently, add different links, add new scheduled content, and that'll get you pretty far. But there are limits on what you can do with Jinx by skinning. And the last thing is application APIs. So all applications work this way. All applications support customization by fiddling with the Jinx files and ABC. And then each particular application has, or many applications have, extra APIs for customization built into them. So centers let you add new centers or add a new partner pull, best sellers at Amazon, that kind of thing, without changing the code. This is all driven by the config file, so it has an API to let you do this without having to sort of get at our proprietary code. Search lets you change the defaults and samples that people get when they get a new favorites folder. This is valuable real estate. People like having their websites put by default into people's favorites, so we let the NetApp customize this. Search, you can change the XML backend, which means our search application will work with any backend, provided we can give it a URL. It gives us XML that represents the search results. We're building it with MSN, but don't want to use MSN. You can plug in somebody else that all speaks XML. I should point out these are also XOXML partner pulls. For registration and settings an account, we have a pretty rich API for changing the flow of registration. So if you want to add new screens or ask different questions during registration, do you want to sign up for premium services? Would you like NTT long distance L? Do you want this on one cable bill? Sort of custom questions that you might want to ask during registration that are specific to NetOp. There's some extra APIs over and above all this stuff that let you do that in these applications. Okay, questions on this? Yes? Yeah, we just had an interesting meeting on that yesterday. Basically, it boils down to an exercise in change control. So what we don't want is people modifying our files in our tree. What we'd rather have is they modify files in their own tree. The system, probably ABC, is smart enough to pick theirs over ours when they've overridden some of our behavior. And then when we roll out a new version, NetOps have a choice. They can either integrate our changes into their files or their changes into our files. But there has to be a merge operation that happens. It's like any branching of source code where they've taken drop, adapted it, and then they have to roll those changes forward.
We're going to end up having this suggested way of going about doing something.
Yeah, and we were working on that yesterday. Jim, I don't remember particulars of what came out of that, but did I capture the essence of that accurately?
Yeah, I mean, the other thing to say about 1.0 is that all the stuff that can be done via pinning can be done by anyone. I mean, all the things involved in the report code for 1.0 are being done by the engineering group, which is part of the project group.
Right.
Yeah.
Also, I think we are going to have to start dialogue on that. A lot of that's going to come from the work that we've done. We're learning smart things.
I think Mike Coffey also was saying that the customization applies to the TV server apps. Customers can build their own website using
Yes.
ASP.
Yes. And because we have passport for those external apps, even if they are written using, even if they're running on Unix machines or written whatever, we'll have some notion of who the user is. Now, they won't have access to things like the user store necessarily, or other proprietary technology. But there's nothing to stop people from, there's nothing that says you can't link to Amazon or write something like Amazon and have it tie into our system. That's just the way the web works. Just URLs pointing to somebody else's site. On the subject, I want to talk a little bit about the roadmap for beyond 1.0. So what does Jinx stand for anyway? Jinx stands for Jinx is not XSL, and that name was born out of frustration. Me and Steve Sankey sitting in the Seattle airport after flying up to Redmond, discovering that the XSL team couldn't support the changes we needed to have them to be able to use their technology in our product. We had also met with these guys who were working on something called Project 42 at the time, who described something that sounded great. And so we were sitting up there feeling bad because we had three options. One was to use XSL, which wasn't going to work. One was to wait for Project 42, go on vacation for a year, and then use that when they were done, which sounded great, but it was probably a tough sell to management. Or three was rolling our own thing. So that's what we did. We rolled our own Jinx, which was not XSL. Project 42 now has, I guess, a number of different names, ASP Plus or COM Plus Runtime or Universal Runtime or whatever. It still looks, we met with them a couple of weeks ago, it addresses virtually all of the concerns that we had that prevented us from using ASP and XSL in the first place. It is descendant ASP and XSL just like Jinx. And although it's too early to say that for sure in 2.0 we're going to rewrite all of our applications, build on top of it, definitely the plan right now is to converge with standard Microsoft technology again, use that for our applications going forwards. So Jinx may not have a very long lifespan, which would be okay. But the goal is to try and find a way to not be in the application framework business very much longer, or at least not to the degree that we have been, and to start taking advantage of the next generation of web building tools that Microsoft is putting together right now. So I used too much time. I apologize. Any other questions? Okay, thanks.
Data warehouse components that we're shipping with 1.0 consist of a back-end infrastructure, front-end reporting application, and a set of predefined subject areas and reports. And let me talk a little bit more about those. The subject areas consist of database schemas in both SQL 7 RDBMS and OLAP, 7.5 cubes. a predefined data stream parsing, so the logic and scripts to move the data from the log stream into the database, processing and loading that data. Key predefined reports, 3, 4, 2, 5, some small number of predefined reports per subject area to get the NetOp going. Documentation and metadata, open architecture throughout. So unlike really any other piece of TV server, the data warehouse doesn't really write any code. We hardly ever compile anything. We're really just using SQL 7 and the tools that are included with that, and a lot of scripting to tie it together. And anything that talks OLADB and OLADB for OLAP can talk to the data warehouse. The primary subject areas that we're working on subscriber, user, and device, and I go on to talk a bit more about those in a few minutes. Web browsing. Web browsing has information potentially at the click level, at the page view level for each subscriber, or actually each user who's browsing the web, both internally in the walled garden, if that concept is set up at the NetOp, and also externally. TV viewing. TV viewing is interesting because we potentially have effectively every click on the remote control. We know exactly what the subscriber is doing in their interaction with the television. We know what shows they're watching and how long they're watching them. We're planning to bring in some cable connection data, basically keeping track of how long the box is connected into the service and how much data is flowing up and down. Service performance, client errors are technical subject areas that would probably be used by the backroom NetOp type people. And if the NetOp chooses to use Commerce as their advertising engine, then we'll be folding in the Commerce for subject areas for the local e-commerce and advertising. Also, it's possible that we'll have the bandwidth to bring in email, chat, news, games, and other auxiliary and somewhat less interesting subject areas. All the subject areas linked together almost all contain information by subscriber, user, and/or device. And analysts can conduct cross-schema studies. For example, finding the subscribers who regularly visit these sites and watch the Super Bowl and maybe clicked through on some interactive TV site. The benefits, the most obvious ones are very simply reporting on the activity of the service. You can also, since we are keeping track of exactly what subscribers are doing and how they're doing it, the potential for doing targeted advertising both in the on the web and on television, potentially in the future, are tremendously valuable and obvious to figure out how you might do that. With both static and video ads that are unique, I think, to a TV server kind of service. Customer care is also a place where the data warehouse is going to be valuable. Subscribers call up with questions to customer care. It's pretty short to modify and extend the customer care application to triage the subscribers, sending those who are more valuable to the service to a higher level of customer care call. Customer acquisition and retention. Acquisition is an issue, of course, for cable companies, and probably retention too than it would be for the telco-based service. But I still think it's useful in general, particularly for upselling to a more expensive and presumably more profitable service. Content and channel decisions, both on the web and the TV side. The U.S. service at Web TV has used the data warehouse there significantly for this, figuring out what it is, exactly what it is subscribers are doing, what it is they're interested in, and making decisions about particular web content based on that. Also decisions about how to structure the company, what kinds of activities to support, and what kinds they can scale back on. And then obviously service operations and economics. I don't mean to give it short shrift, but I think all of us can understand that really pretty easily. What I'm setting up the data warehouse to do is support the big wins. The reporting is a base requirement, and it comes out of building a data warehouse that can support killer apps. But there are easier ways to generate a predefined set of reports than to do what I'm doing, which is building a conformed dimensional data warehouse. So my real goal is to enable the killer apps. I'm not building any killer apps that I see as killer 1.0. I'm enabling the infrastructure for future releases of TV server or also for the NetOps to build themselves. And the killer apps are unique or nearly so to business conditions. They're probably something really, the really valuable ones are ones that a NetOps is going to do themselves. They're often closed loop systems that will feed back into the operation of the service. And the reason that they're hard and that building to support that is difficult is that you need flexible data storage to support problem exploration before you develop the application. And I think this is a great role for a system integrator to work on with NetOps. So the implication of building for supporting these killer apps is that the data warehouse is big. You have to store data at a very granular level to support an unknown variety of analyses downstream. We still do throw out a lot of junk data, but nonetheless, we're talking about a terabyte of data for each million subs if you store data for 3 months, which is we have found to be, that's going to be our recommended configuration. That will be configurable, but that's what we'll ship with. The design focuses on enabling great OLAP cubes, and we're doing a lot of database work to make those cubes work efficiently as possible and be as easy for the NetOps to build themselves. And it'll support and enable very straightforward business user development of analyses and reports. The relational database in our architecture really exists as a maintenance area more than anything else. It's where data are loaded, managed, and aligned, and it serves as a middle area between the data coming in and the OLAP cubes, which is where most business users are going to be accessing the data. But it's important to keep the relational store there because it will support new OLAP cubes should the NetOps choose to define them. This is far more complicated, really, than it needs to be. But the basic idea is that we have data coming from clients which flow through the service logs. We also have the services, like proxy, will generate its own logs. Those all get grouped together into one big event stream, which is the primary source of data into the data warehouse. We also have operational databases, the most important of which is the TV server subscriber database, which has data that flows into the data warehouse. This guy over here is a relational database that, as I said, serves primarily as a staging service, and it feeds the OLAP query service. The green arrows here are pullable places for interface with external data. Other corporate databases bringing data in, for example, other information about subscribers that's not relevant to this TV server subscriber database. Or truly external data, for example, demographic data, could also be added into the data warehouse. And finally, instead of just sending data through the query service, the business users, you could potentially populate another data warehouse, perhaps a corporate data warehouse in another relational database if that's what the NetOps wants to do. I mentioned most of these already. The SUD database, or I think it was earlier this week renamed to be called the service database, is the central schema for, it mentioned that just in almost all subject areas and almost all reporting. It's a complex extract. It's by far the most complicated piece of logic that we're working on, but luckily the data volumes are trivial. We're talking, for 1.0, we're talking 1 million subs in the data warehouse world. 1 million of something is just not a big deal. The event stream is where the huge volume of our data comes from. The biggest piece of that, or one of the biggest, are the content reformatting logs or the proxy logs. Also, applications. For example, TV viewing is actually logged on the client because service, of course, doesn't monitor the remote control clicks. It's something that's captured on the client, and then periodically that log information is uploaded into the service. Any of the applications that Mike was talking about here, all of these can and do log information, and some of that information is considered useful enough to store in a permanent, user accessible way in the data warehouse. Other sources, good opportunity for somebody else. Okay, so subscribers and device. The data warehouse retains a history of the end-day picture of the subscriber and device attributes. So the things that might change during a day are whether a new subscription, of course, or whether the subscriber has changed their zip code, their service plan, which is very important, their account status, or possibly, you know, the end of changing your account status is canceling your account. We keep every day those attributes of the first subscriber, we keep the history. By contrast, we're keeping only the current billing address in the data warehouse. We don't feel that it's important enough to keep a history of that, especially since a lot of those changes are typos, and anything significant gets picked up in the change of zip. Similarly, for devices, we're keeping a history of when device moves from subscriber A to subscriber B, and when the client version has been updated. That's really important for a lot of queries, especially if the NetOp is doing some customization to the client and they want to look at the performance of the service or the behavior of subscribers before and after a client upgrade. The history of that attribute is tremendously important to retain. About users, you know, the logins, for email, only current user attributes are stored. Typically, most queries occur around subscriber and device, fewer around users, and those attributes just aren't interesting. And we use security in the database to shield personal data from most data warehouse users. I don't know how interesting this is to you, but I'll just run through it quickly. I talked earlier about the complexity of the SUD extract and load, and this is a little bit of an outline of what we're doing. The first thing we do is pull over all the static information, all of basically the decode information, the labels associated with duties and plans, the fact that a new plan in general has been registered in the database. We're actually subscribing to it in a replication, getting the information over into the data warehouse database, and updating those attributes, which is just a tiny, tiny amount of data. It's possibly only, you know, one row every week is what I would expect to see in the volume on that. But we still need to put the infrastructure in place to manage the changes to those attributes. The main source of SUD data comes from a table in the service database called entity events, which is related by a trigger from the service database. So anytime something happens to one of the major tables, subscriber, user, device, and some of their major subtables, that event is logged into this table called entity events. And that becomes the source of data for the data warehouse, this history that I talked about. And this is done in DTS and logging the fact that we've successfully extracted a set of data. The processing occurs nightly, again, because I'm keeping only end-of-day status on subscriber, user, and device. And on the service database itself, it's the customer's responsibility to back up and prune this table entity events if they decide it's getting too big. I don't think they're really interested. Basically, we need to take information that's coming in a normalized structure from the service database, denormalize it into a far more simple structure that we use in the data warehouse. The reason that it's important to do this is that the goal of the data warehouse design is to support very simple, straightforward querying by business people. So if we left the data in the form that it was in the service database, that's really too complicated for people to look at and get. So I make it as simple as possible. It also improves, there's a hit during the processing time. Processing time increases than simply copying data over into the data warehouse, but we make up for that during query performance because we've already put the data together in a structure that makes sense to business users and that they typically query together. Oh, one of the things that I need to do is map the GUIDs that are part of the service database into integers. This is important, again, to support rapid querying in the OLAP and query side of the house. And we stream inserts into Commerce 4 components for stored key assignment and loading. So I mentioned Commerce 4 here because I'm using Commerce components as the loading infrastructure for the data warehouse. For the SUD data, there's a lot of processing that occurs in the database using DTS tasks, and the final step of that calls the Commerce DLLs. For the rest of the loads into the data warehouse, the very large volume loads, pretty much all of it is going straight through Commerce and using those components heavily. Okay, so I think probably Jim, maybe next, is going to be talking about the event stream and logging. So I'm not really going to talk about that there, but the first bullet here refers to the log infrastructure that Jim's group has put together. The second bullet is to separate it out and parse specific event types, outputting a clean formatted database load file. We're currently calling this harvesting. And it's really a straightforward executable that reads the event stream, looks for the kind of data that is specific to the kind of processing, for example, proxy events, and formats them in a specific way. This is the place where we hopefully are going to be doing any pruning that's going to occur. This is the first point at which I could prune data. So any of the configuration options that might reduce the amount of data that's going into the data warehouse typically occur here as configuration, and they're configurable by the configuration system. The most processing intensive piece of the log data loading is to perform key lookup and substitution and load into the RDBMS. This is an extremely expensive operation. Basically, I need to take GUIDs, which are what are logged in the logging system, because that's what is used to identify entities throughout the TV server system. I need to take those GUIDs and turn them into integers. The reason I need to do that is because I'm with a terabyte of data, and I need to make all of the changes that I can to improve performance. And moving from GUIDs to integers is a huge performance gain. The key lookup and substitution. So any single incoming data file might have 5 identifiers that need to be substituted, need to have this key lookup for. And these data files can of course, be quite large. So this processing is very expensive, and that's the reason that I'm using the Commerce technology here. They've put a lot of time and money into solving this problem, and I'm riding on their coattails. It's great, though, because it is standard Microsoft technology. If necessary, we'll aggregate within the relational database. Again, this is really a step to reduce data volume where sensible in order to improve performance. We'll perform incremental loads of the OLAP cubes and run scheduled reports. My hardware, the harvesting and loading that I just talked about, we expect probably by default will be co-hosted with the log aggregator that I'm going to talk about in a minute. It makes sense probably in most cases to keep these pieces of the service code together with the machine that's running the log action and harvesting. The Commerce loaders can either be on that machine or they can be spread across multiple smaller servers. The weak link in my infrastructure is the single large relational database server. I, as yet, have no way around this problem. But this is primarily, as I said before, used as a staging database that populates OLAP cubes, and the OLAP infrastructure nicely partitions across multiple servers. I do need to solve this problem before we scale far beyond 1 million subscribers. So I pretty much already have said this. The role of the commerce infrastructure primarily is to load tables, performing very fast loads, very fast key lookups. The core pieces are high performance, multi-threaded, distributed. I have some issues with the technology, primarily that the UI is non-existent. What this means is that for the NetOp to change the schema or add new schema is not trivial. You know, I would love to make it drag and drop, and someday it will be, but right now it's a bit of work. And it's complicated, and right now Commerce is not supporting OLAP, which, as I've said, is my primary query database. However, the OLAP tools themselves really are pretty usable, pretty easy, so I don't see that as a major problem. The TV server is extending the Commerce infrastructure to support table partitioning in the relational database based on union views. We have a tool that will automatically create and drop partitions, generate load scripts, load into the appropriate partition, and maintain a view that combines partitions into a single logical view for the business user. We're also managing slowly changing dimensions for subscriber and device. This is the point that I was talking earlier about keeping a history of changes to the attributes of subscriber and device. That's a fairly complicated thing to model, and unfortunately Commerce isn't supporting it directly, but we're managing it and integrating that in with the Commerce infrastructure. And as I said, we're using 7.5. They are not, and we have a different front end than Commerce has for our data warehouse querying. I already spoke about the first tool we have to support partitioning and loading. We also have a tool to help support the front-end administrative tasks, creating users and giving them security, managing their security, managing the metadata, managing reports, also to categorize sites, which is a little thing. To add a new schema, if the NetOp wants to add a whole new schema to the data warehouse, the process would look something like this. Well, first, implicit there, and I should have made an explicit, was they need to do some analysis of the business and figure out what the business problems are and how the data is going to support it. Then they need to develop a target relational schema, use existing dimensions where they're relevant. And that's very important because by reusing existing dimensions, the NetOp is going to be able to define schemas and analyses that cross these different subject areas. They need to create a fact table, develop a data stream. So this fairly straightforward executable that I talked about that reads the log stream. They're going to need to either change that existing one or write a new one that will pick out the events they want and simply report them into a more, do any data processing, any data pruning that needs to be done there, and output data in a form that can easily be loaded into a database. For data that's not coming from TV server, from some arbitrary external source, simply write an OLADB compliant data stream. For example, tab delimited rows of data, but really anything that's OLADB compliant. Then they need to instantiate the schema via Commerce, develop Commerce load scripts. This is about a week of work. Perhaps supplement with DTS packages if necessary. Use our MMC to define partitions on this new data and schedule the loads. Design and instantiate a new OLAP cube or cubes. Schedule the incremental refresh. Manage the metadata about it. Develop standard reports. So this is a chunk of work, but it's not impossible. We're shipping a front end with TV server data warehouse primarily so that users, the NetOps, have a good out-of-the-box experience. We don't particularly expect them to use the front end as their primary corporate reporting tool. It actually is turning out very nicely and is more sophisticated in some ways than what a lot of NetOps will have because we're publishing over the web, and that's still relatively unusual in the data warehousing world. So it is possible, actually, that they'll like it a lot and use it a lot, but I don't particularly expect that to be the case. We are basically shipping a website that has integrated metadata where business users throughout the NetOp can access predefined reports. They can change those predefined reports. They can work with them interactively. And they can basically publish their own reports as well, new reports. It's all database and XML-driven ASP, fully customizable. The customer can add new sections, take away existing sections to the front end if they wish. It's really very straightforward. They can even replace the control that displays a report with any other OLADB for OLAP report or ActiveX control with probably just a couple days, maybe a week of work. I have a couple screenshots here that I'll just run quickly through. This is, I'm sorry, the only thing I could get up had only one report predefined, but you would probably see a full screen full of predefined reports here. We have wizards. We have links to metadata. We have some static reports over on the right. Again, all these components can be moved around as the customer wishes. This is an example of some wizard screens, an example of a report. And again, the report is nice because a business user, so like a marketing analyst at the NetOp, can bring this up in their browser in IE and move these elements around so that they can pivot the report, they can change the time period, they can interact with it within the browser. This is an old report that I brought up. The newest thing that we have has metadata showing up on the report page so that the users can see, oh, what is an URL? What does a site URL mean? What does the page hit count include? I do hope that the network operations people understand that in order to have a really valuable data warehouse, especially if they're going after these killer apps, they're going to need a data warehouse team. And this is a list of some of the skills and some of the roles that team might include. And I really think that if a NetOp can bring up a single killer app, they're going to make up the cost of their data warehouse really quickly. I see the data warehouse as having one-time hardware costs of between $1 to $2 a sub. It could be 50% more than that, but it's not going to be 10 times that. That's about right. Ongoing data warehouse team costs of $1 to $3 per subscriber per year, which decreases subscriber growth of economies of scale. And then the benefits when you're working with the NetOp to figure out how much resources they should have at the data warehouse. Have their business people price out a few key applications, such as improved ad targeting, reducing churn. A business person should be able to put this together really fairly quickly. And any one of these, if successful, will easily pay for the data warehouse, I guarantee. WebTV has one killer app that has saved more than $3 per sub per month. It unfortunately is based on telco pricing, so it isn't relevant for the cable operations.
Something here. I mean, we're getting some pushback from this chart. I think we'll start hearing from AT&T as we go forward. As we come up with these kinds of numbers, they're going to say that doesn't make any sense. It's not working to us. And it's you're going to tell me this. It looks like it's about $5 a sub a year, $5 a sub a month.
No, $5 a year.
That's not an easy sell. These guys don't have much margin. They're not used to spending money. That is not an easy sell. We need something that's going to convince them that they ought to do the benefit from it. And simply saying data warehouse are a good thing, not it.
Okay. So what about improving ad targeting by 10%?
Example. We'll show how and show. We need stuff that will show exactly how it was done, how it worked here, before and after.
And I think we can get some of that from the service as well.
Yeah. Right, but I mean, we need this.
You need the numbers.
To build out the
I
warehouse.
agree with building.
Also, there's a lot of TCO funds and resources that Microsoft has in terms of how to calculate TCO. And
right.
I think we need to get at all that.
Questions? I think that's.
I take it the privacy concerns with data warehouse is control how much click data you collect, how much is used?
Privacy is an issue. And you can certainly control how much is stored in the data warehouse. But controlling how much is actually collected is a harder problem.
Yeah, I think we're going to need to be careful, especially in some regional areas where overseas for sure.
Absolutely, Germany in particular, big one.
We'll just have to know how to say that, how to message that. How to
We're talking about that actually with our French favorite clients who are also going out in Germany. And they said that collecting it for their own use to do service improvements is not a problem as long as it is not allowed out of house. For example, in France, they can collect anything they want. Even the police don't have the right to ask them for that data. They don't have the right to tell them to give it to them. Okay, so I think we raised the same issue she was talking about.
Right. I think that's not true in Germany.
But they said it's not. They said still the stuff they can collect for their own use in terms of maintaining the service is significant. But things like ad targeting might start to infringe on that.
Right.
I'll have to start understanding.
Yeah. So it's really, as long as we can manipulate what's in there, it's up to the deployment and the NetOp to comply with the law.
Okay. Thanks, Joy.
Thank you.
This is a new topic we added to the agenda. I'm going to discuss the client configuration server. It's a component that makes the TV server manage clients better than any competition we know of. So the stuff I'm going to cover defines what we mean by client configuration. I'll walk through some ways of using it, discuss the components in our product, and then walk through end-to-end the process of the client and server communicating with each other for new configurations. When we talk about managing clients, we mean that we have to take care of establishing and maintaining connectivity between the clients and servers. Bart talked a lot about that, and Bart also talked a lot about authentication and authorization. We do call those management to some extent, because it's the process of defining who gets what level of service and how they connect and managing what they connect to. So that's what all that involves. Monitoring, Jim will talk about in the next presentation. That means really getting a read on a lot of instrumentation and figuring out how the server is performing. Logging is the stream of data that goes into the data warehouse Joy talked about. All of that really does give you a lot of tools for managing TV server, especially the logging. It's interesting to focus on that for a second, that all the load on servers generates logs, and the NetOp can define what those logs are. By going to the data warehouse, there's a single place to slice and dice the information about which servers were most heavily loaded, which zip codes are giving rise to traffic of a certain type. And they can manage network topologies and even do troubleshooting and that kind of information. So all of those are management tools. The last one on the list is what this presentation covers. Managing client configuration. Defining how each client box is set up and what software is on each box. So we have a number of components in TV server that allow clients to update themselves over the network. Set-top box comes up first time. From that point on, we can manage the version of the operating system, configuration settings, other applications that are on the set-top, and actually there's a list right here, including the first-time setup. We have an endearing concept called the brain-dead box. First time a box comes alive with volts on it. It doesn't know anything about its configuration, who it belongs to, what network it's supposed to connect to. So the client configuration server's job is to recognize that box for the first time and give it a set of instructions to set itself up for first-time operation. After it's in operation, we can dynamically update the operating system at any point in time. So when there are upgrades that allows the network operator to move with the state of the art, to bring out new features, new versions of the operating system, don't have to do truck rolls or change boxes to update Microsoft TV. Settings are what you think of in the registry. The registry is the configuration system of Windows, and the client box is based on Windows CE has a registry. So our server has a way of changing settings in the registry on all of our set-top boxes. That might include things like the default URL for the service. If the box comes up and it doesn't know who to contact, we can hardwire it to always go to a well-known place that we know is alive. So that's an example of one setting that can be managed and changed on the set-top for reliable operation. The electronic program guide data Suresh talked about is an example of data the client needs to be told about. Our server tells the client, here are the listings that apply to you for your zip code. Here are the listings that are applicable to the services you've signed up for. Does HBO show up in your listings or not? Things like that. So the server knows about all the settings that apply to the client. This is the system that gets the right listings to the client. New applications might include, in the future, things like games or any imaginable application on the client. Executable code that needs to be downloaded is included in that feature of the client configuration system. And then finally, the logs Joy talked about. Logs generated on the client are files containing a lot of information about clickstream, channel tune information, crash logs for troubleshooting. Those are all files on the client. The client configuration server tells the client where to upload those on the service, so it can make their way to the data warehouse. The components of this system are on both the client and the server. On the client, there's a piece called Client Configuration Agent, CCA, and the job of that component is to speak with a server component called the Client Configuration Server. And actually, they just speak HTTP to each other, and their responses are in the form of JavaScript, for what it's worth. So the point is there is a client component and a server component that have to work together for the system. I'm going to go through the details now of what that communication looks like between the server. On the client, the first thing that happens is that in bootrom, there is a step that causes a client configuration agent to load during the boot process on the set-top. The OS begins to load and calls this loadable agent. The point of it being a loadable agent is that it's possible for OEMs, the people who make set-top boxes, to replace that agent, if they want, with any other agent that's capable of going to get downloads from other sources. So, for example, if General Instruments has an operating system download agent that goes to some GI-specific place to get its OS, it's easy for them to replace our CCA with the GI download agent. And the set-top continues to boot and work the way that it's supposed to. It's also possible for GI to modify their OS download agent into a hybrid of the GI downloader and our CCA. So you get the benefits of the in-place existing GI download infrastructure and all the new features we provide, like the ability to upload logs and receive instructions about downloading executables of any kind.
Can you give them a source to do that, or how does that work?
Yeah, there's a full set of documentation about CCA and the interfaces between it and the outside world. So the agent's job is check for possible downloads or configuration changes, and if there are none, if there's no work for him to do, he returns to the boot ROM and the set-top box just loads them and works. If there is work for him to do, the agent uses some network-specific communications infrastructure to work over whatever the network is, speak to client configuration server. So the point about network-specific driver here and network-specific driver here is that CCA and CCS are designed to work together no matter what the network infrastructure is. By changing a driver in the set-top and having the corresponding driver on the server, this could be, you know, as per an earlier question, it could be a telco network or cable, DSL, satellite. It's a pluggable component of the system. Okay, so here we have the client requesting instructions from the server. The server receives the request, and then checks the client's state. In the post that it got from the client says, here are all the packages of data I currently have, is the version of the operating system, my CPU type, and any other interesting information. And the server then responds with configuration instructions. He looks in the database, finds out all the settings that are supposed to be applied to that client. Is he up to date? Are there some deltas that need to be applied? And responds with a script that will now flow back to the client. To the next slide. These are actually the words that wrap around what I just said, so I'll skip through that. Okay, so we had the client requesting instructions. This is the response. The server sends a configuration script to the client. Again, it goes over any network. The agent on the client receives the script and processes it. The effect of processing it is that the agent has to go and download an operating system from some OEM's website and game scores from a game vendor's website is the example. So the thing we can't see here is this is point 3. It's the processing of the script. The script said go and do these things. So the client configuration agent visits the internet. It goes to the OEM. This might be GI or Philips or Compaq, wherever. Gets the OS image, downloads it, installs the OS image, reboots, and the setup's now in business with a new operating system. Likewise, the client visits the network, gets scores from the game vendor, and now the game has been updated. So that's the process of requesting instruction. The server sends a script, and the client goes and visits the network to do what the script said. Well, again, these are the words that wrap around that slide. The server provides the commands. The client can do all sorts of interesting things like deleting files, creating partitions, changing the layout of the disk, and so on. And then the client is responsible for going to visit URLs. I'm going to discuss in 2 or 3 slides' time how this works in a broadcast network where the client is not actually connected to the server. We do handle that situation, and I will discuss that in a few slides. Before I do, I just wanted to go through how easy it is to set up this process for the operator. This is the process called administering CCS. An operator creates packages which are all the commands and URLs, the pointers to the data that has to make its way to clients. The package is embedded inside a channel. The channel is actually a word that derives from the Channel Definition Format, CDF. It's a World Wide Web Consortium standard. We follow that standard. They use the word channel to what is the package and where does it have to go. The target information includes the schedule. When was that package you sent out? They want the whole world to upgrade their OS on, say, at 12 o'clock. So people in one zip code will do it at 12, and another zip code can do it at 2 in the afternoon, etc. So there's a schedule. There are dependencies, like update this driver if you have this version of the operating system. A different version, then you do something else. That's what dependencies means. That's the standard. The third thing the operator has to define is groups. Groups just means bunches of clients. That's the subscriber management database, or our services database defines who the population of set-top boxes, who they are, who is the population. Who is the population is defined in that database. Creating groups means all the users in a particular zip code with Philips boxes might be an example of a group. All the people who have subscribed to this game application and get expensive, additional services. Define the groups of users. Then finally, the fourth step is to say, out of all these packages we know about that have to get to people, the channels that define when they have to get to people, we'll subscribe channels to groups. So that's making the connection between the available information and who really gets the information. Now CCS is set. Find the data, when it goes, and who gets it.
Subscribe channels to client.
Yeah, to find subscribe channels to client groups. Group is a word that's used throughout the CCS documentation and appears in the UI. So there is actually a drag-drop link between those two. It's pretty straightforward. Okay, and for the lucky people who have PowerPoint and are reading this online, all the words that I just said are pretty much on this slide. We're going to talk about data broadcasting. What happens when the client sitting out here at some far end of the network is not connected to CCS? It's not going to post its status and say, tell me what to do now. Hanging off a satellite dish, and it just wants to receive its instructions passively. So we call it data broadcasting support. The end-to-end example of what might use that is the EPG. So when Suresh talked about his EPG server in Microsoft TV Server, he mentioned that it has this export pipeline that allows the operator to create EPG listings. It might be short listings for present following information. There may be slightly larger program listings for 6 hours worth of programming and stuff that covers 7 days worth of programming. So those are each different files. Each of those types of listing is represented by a file. There might be versions of those files for different languages and different zip codes of people. So EPG listings is actually a whole bunch of files. They were derived from information supplied by a third party. This is third-party data sources. EPG listing provider is the example of a source. Send data to Suresh's database. We slice and dice that information, create these files called listings that have to be sent to clients. So Suresh's server, the EPG server, calls the client configuration server and creates a channel called EPG listing files. It says, what's the breakdown of groups of people who are supposed to get those listing files? So in a very standard way, it uses the interfaces that I described in the previous couple slides, and he sets up CCS to know about these files that have to get to different types of users. Then we have a component called the broadcast agent, who is going to pretend to be a client to CCS. He queries CCS and says, tell me about all the files clients are supposed to have. So it's exactly the same mechanism we had in the previous slides, where the clients were posting their status and saying, tell me the files I'm supposed to download. He says, tell me the files that all people are supposed to have. And CCS responds with script that says, so it's actually just an embedded conditional script that says, for this type of client, here's all the stuff he's supposed to have. For this type of client, given this version of the OS, tell him to go and get all these things. So it's one huge script. The broadcast agent then goes off and visits the internet, goes to URL, scrapes together all the files, just like the client would have had to do for himself in the previous few slides. Now he's got a bunch of files ready to be broadcast. He knows the schedule for when they have to be sent out, because CCS told him the schedule was part of the script. So he now calls an API on a third-party piece of equipment. Part of the head end is a data broadcaster box. It might be a GI OM1000 or a box by SkyStream or Divicom and others. They know how to do MPEG transport stream, IP encapsulation, BBI, or whatever type of data transmission it is to their network, up over the network, which is the client. A little bit more detail in the next slide. Actually, it looks like a lot more detail. It's actually a similar story. It shows CCS, and over here is the client. So it's the same end-to-end story where the broadcast agent queries the server for instructions. The server provides a comprehensive script for all clients. The agent then connects to the data provider. He does what he did in the first slide I showed you, the first diagram. And then he schedules this data for transmission. Examples are a carousel model, where the schedule says send it over and over, or send it every hour. A daily bulk transfer might be an operating system image. It's a large image, and you want to make sure the whole file gets there as quickly as possible. And use all the bandwidth you have, just get it to the client. But we're not going to use all the bandwidth we have all the time, so do it daily. So that's an example of a bulk transfer. A trick stream might be data that's sent out all the time using low bandwidth, and we'd even call that opportunistic transmission. It doesn't really matter if the sports score didn't make it round this time, because in 2 minutes' time it's going to be updated again anyway. So that's a characteristic of data transmission we know about because CCS sent that in his script. And so finally, the broadcast agent calls an API on the broadcaster with instructions to transport files for broadcast as scheduled. Examples are SkyStream, Comcast, GI, and others. So now we leave TV server land and we call this API. The API has to be implemented on a third-party piece of software that receives the instructions, fires up the Divicom gear or the SkyStream gear, starts streaming it to the files, and the gear knows how to do MPEG transport stream, DSMCC, DVI, DOCSIS, or however the network's configured to get the data to the other end. The data beams out over the network. It's received by a client-side component that knows how to tune to the appropriate data channel, receive the data, and store whatever data it received on the client. So this is a component on the client that corresponds to the broadcast gear the network operator is using. It's a mini-port driver that has to be developed within the Windows CE data broadcast services infrastructure. Finally, the agent uses the script to decide what data is relevant to him, executes the instructions, installs data, and does everything he would have done if he were real-time connected to the server. Okay, so the point of where we're at now is to say that the server has the ability to configure the client, all clients, in the way the NetApp wants, and we can even do it in a one-way network called broadcasting. Server works with any broadcast network because we have this API that abstracts whatever the network is, and that means there is system integration required to implement that API on the front end of whoever the broadcast gear provider is. CCS can be customized. We even have two versions of it. We ship a version called the standalone version of CCS on the Microsoft TV disk. So when you buy our client, there is a CCS on that CD, which means that network operators have a server from us on day one that knows how to upgrade their operating systems and send files to clients without them needing all the server infrastructure. Of course, CCS is also integrated with Microsoft TV servers, so when you buy the full server, you get all the additional services you heard about in the last 7 hours. The product has APIs for automating the processes we described, creating channels, telling it to stream data. Those interfaces are scriptable, so third parties can write VB scripts or command line tools, however they want to instruct the server to send files. You can do that remotely. And finally, it has an architecture that allows us to plug in support for different types of client in the future. It's a feature of the architecture, and we'll be exposing that feature beyond the 1.0 time frame. So all this infrastructure I've described will be capable of supporting implementations of CCA on things like cell phones, PCs, other types of handheld devices or whatever, because we can implement different protocols within this architecture. I'll go very quickly through this slide, and then there really is only one slide left. For integrating CCS and CCA into the real world, the network operator needs to decide who's going to operate this client management infrastructure. Is the NetApp going to be responsible for defining packages and when to upgrade the OS on set-top boxes? Or do they want a relationship with their OEM? Maybe GI is the manufacturer of the set-top box, and the NetApp wants GI to be responsible for distributing OS updates. So who's going to do that dictates where does the server go and who manages the server. Or outsource it to some third party, and on and on. So there's the operational management, I guess, infrastructure, the thing has to be defined. Whoever the answer was to that question is then responsible for creating packages, defining channels that contain those packages, and associating channels with groups of devices. It's possible to leverage the subscribe management database or our service database to get that group information. So there's integration between TV server and the outside world. Security is really important because you don't want bad people sending bad software to set-top boxes in an unprotected way. So our infrastructure supports digital signing of the data that gets sent to a set-top box, which means the set-top is going to trust the source of the data. If the data comes from GI and then a GI box, and there's going to be a GI signature on the operating system image, and the set-top will trust that operating system image and install it. If it comes from a non-recognized source, the client's just going to drop the bits and not install it. So implementing security, putting the right signatures in the box, making sure that the bits you want to download are signed is work. Finally, configuring the client, telling the client who's your CCS. You know, if I'm going to Compaq to get my operating system image, then the client has to be configured to know that. It's just a URL burned in ROM. It knows where to go. It needs public keys, which are the ways of unlocking these digital signatures. Who sent the signature? Well, I know it comes from a trusted source because burned in ROM or on my smart card is the key for unencrypting that signature so that I know I can trust data. Okay? So configuring clients, since this information has got nothing to do with TV server, it's work that has to be done as part of creating an end-to-end infrastructure. Then the last bullet for the system integrator is that to make it easy for operation, write scripts that make it easy to just kick off the right job at the right time of day, register new images, and know who to associate those operating system images with. When APG gets updated and you want to send, the example we heard earlier was the sport games running 5 minutes late. So you want to change the EPG to show the start time of the next show. You want to do that in real time. Well, there should be a script called update EPG now. You just run that script, which automatically goes to the right interface in the broadcast agent, and the right file gets sent to clients. So to wrap up on all of that is that our platform, and I'm using the word platform here to mean including the client and the server have to work end-to-end, makes it possible to support dynamic client requirements. The client can move and evolve and be upgraded over time. Continuously update client operating system, both downloading and uploading information. Uploading logs was the thing we talked about. Changing settings on the client, it may be specific to applications, what server does this application use as its default, or who are the members of my game community that always see their scores when I'm playing the game. That's a setting specific to a game. The game vendor has the opportunity to set things that are specific to his game in the client. It works over any kind of network, including one-way networks that are broadcast networks, and it can be customized to work with any-to-any, including any protocol, and it can be automated to do scripting. So that was a Swift version of the CCS architecture. Any questions? Thank you. Thank you. You're done.
Okay, let's start back up then, if everybody's set. Okay, so I'm going to talk a little bit about logging, administration, configuration of TVPAC server, MSTV server, whatever you want to call it. There are a lot of components to this, so I'm going to have to fly through them a little bit. I'm going to focus on mostly our software installation, how do we get the bits onto the machine, service configuration, how do we set it up so the machines each do what it is they're supposed to be doing, network management, which is how do we know that the machines are still working on a day-to-day basis, and logging, which we use to analyze historically what's been going on in the service. Some of the goals that underlie all of these areas of service administration, we're trying to build a large-scale commercial service, and so that has a number of implications. It's got to run lights out. We expect it to run in a data center with a bunch of machines in racks. They won't have monitors and keyboards attached. They won't have people sitting in front of them. So it's going to run on a large number of hosts. Historically, both the Web TV service and the Atlas service are designed to
to run on redundant but not necessarily high-end hardware. And that's to keep the capital cost down for operators. The dial-up service that we operate, we've traditionally run on desktop class machines, desktop workstations. And we expect that operators will probably run this on server class Intel hardware. So that means not the really high-end dual power supply, no single point of failure kind of servers. And we expect that it'll take hundreds of thousands of machines to handle a service of the scale that we're trying to enable. As a result of the number of hosts involved, they have to be centrally administered. You have to have people go around from machine to machine to do administrative tasks. It's a nightmare. You've got to hire a bunch of people to go and do things to 300 machines. And the people that you can hire to do that may make mistakes along the way. And so you really have to have centralized administration. And for that, most of our administrative tools are going to be written within the context of the Microsoft Management Console, which is a nice, fancy-sounding acronym, but it really doesn't mean a whole lot. It means they give us a frame in which to implement the tools. But they will fit into that. So in terms of how you navigate to the administrative tools, it'll be the Win2K standard way. And finally, the service needs to be centrally monitored so that you can have an operator sitting in front of a commercial network monitoring console, and they can have a lot of data available to them as to whether the service is having any problems, whether the users are seeing any of those problems, and what the general health of the service is, how busy are the machines, and so forth. Software installation I'm only going to touch on briefly. In this area, if you look at the DPR release right now, we provide an installer, which is sort of a Windows 2000, Microsoft standard installer. You double-click on it, it installs the software. And that's a useful installation model for demos and trial setups and installing a desktop to use it for development. But it's not a particularly useful installation model for a data center, where once again you'd have to go to 300 machines, hook up a monitor and keyboard in order to do that double-clicking. So the 1.0 installer will have both the graphic base for installation and it'll have an unattended mode of installation, so that you can install it on machines that don't even have a monitor keyboard attached. On the other hand, there are some problems that we're not solving in 1.0. We'll provide this installer that you can run unattended. It's command line, so there are various ways you can get it to run remotely. We are not implementing a bunch of tools for the installation of software on lots of machines simultaneously. We provide an installer that you can automate, you can script it, but we're not providing that automation or that scripting. There are some technologies designed for doing this. The Microsoft Installer that came out with Windows 2000 has some features for doing this, and Microsoft SMS has some features for doing this. So from a deployment standpoint, there are solutions to this problem. We're not, in the core development group, we're not doing any work with SMS. It's quite possible that you'll be able to use SMS to deploy this software, but we don't have the resources to try that out for 1.0. Hopefully post 1.0, we're going to try and at least provide sample integrations with more of these deployment tools as part of the core technology. Terminologically as well, I think that the configuration model is a little different from a lot of Windows products. We tend to talk about installation and configuration as two separate processes. And at install time, all you're really doing is putting the software on the machine. A lot of installers will ask you a lot of questions about what SQL server do you want to use, and what mode do you want to install it in, and in what server do you want to talk to. None of that is included in our installation process. When you run the installer, even in the graph mode, all it really does is place the software on the machine. You have to tell it where to put the bits, but you don't tell it, for example, which applications will this machine be running. The front-end machines that run things like Mail and Cookie Favorites and Search, they all have all the applications installed. You don't install different software on different machines. Operationally, that's an advantage because it means that if you need to repurpose a machine, the bits are already there. And it makes your operational configuration much simpler. And quite honestly, the amount of space occupied by this stuff is irrelevant compared to the size of modern disks. So the strategy is to install all the bits. And then once the bits are installed, there's a configuration process that's done centrally. And that's what I'm going to talk about next, is how you configure this as a service. So you have a bunch of machines. You've installed the product on each of them. None of the machines knows which applications it's supposed to be running. It's got the bits for all of them. So the next step is to configure your service. Now, once again, this has to be centrally done. You to each machine and configure it. So there's a configuration system where there's a central configuration file that describes for all of the machines in the service what it is they're supposed to be doing. And it's designed to be a relatively efficient format to edit. So you can describe, for example, a proxy machine should run the proxy server and the system monitoring server, and the proxy server should have the following TCP settings, and You can describe this all kind of in a higher level way, and then say, oh, the following 17 machines are all proxy servers, and they'll all get that of configuration information. And for editing that configuration file, there's an MMC snap-in that was not part of DPR, but will be part of the 1.0 release. So that's the configuration editor. And that's probably the most important. Maybe I'm biased because it happens to be within my group, but that's probably the configuration of the MMC snap-ins we provided. That's probably the one that the operators will spend the most time using, because that controls the configuration of pretty much all the applications you write. In addition to that, there are some other MMC snap-ins that you use to do some of the database configuration, some of the whitelist configuration, and so forth. And then when you edit the configuration on the centralized administrative workstation, it saves the changes locally, and then it pushes the changes out to each of the machines, which then pick up the changes and start running with the new configuration. So the next area that I want to talk about was network management. This is a very important area. If you're running a large commercial service, I guess we talked about this a little earlier, machines fail left and right. It would be unusual to have a machine fail every day. So in terms of the general architecture of the service, the first goal is that if a machine fails, the users don't notice. Most of the machines are redundant. In fact, I want to say that virtually everything in the service can be redundant. So when a machine fails, the users don't see a prolonged outage, but on the other hand, the operators need to know about it, because if you just let machines fail and you don't know about it, then eventually they'll all the redundant machines will have failed after enough time. So although the users don't notice the failures, the operators need to know about them right away so they can put them on their list of machines that need to be fixed within, a day or two. So for monitoring, there's a bunch of monitoring data that's available, much of which isn't specific to TV server. Windows 2000 gives you a lot of instrumentation. It'll let you hook up and find out things like how busy is the machine, how busy are its disks, how much memory does it have available. And that information is all extremely useful in terms of monitoring the health of the server. Similarly, Internet Information Server provides us with a bunch of information. How many pages is it serving a second? How much data is it serving up? Stuff like that. So between those two, you get a not bad picture of the health of the service. Then there's some other things that we're going to try and provide over and above that. Two in particular. One is that we have a monitoring application. And the monitoring application is a little bit different from all the sort of performance-oriented data that you get from Windows 2000 and Internet Information Server. The monitoring application actually goes out and pretends it's a set-top box and makes requests to the application. So it'll go to the home page, and it'll ask for a copy of the home page, and then it'll parse the home page, find out all the images that are on the home page, and it'll go and fetch all the images. And so it does the operations required to actually get a home page. And if any of those operations fail, then it's going to raise an alarm to the monitoring console. And the reason this is there is so that you catch that's really a good end-to-end test of the service. There are a variety of failures that could happen that maybe you're still serving pages and you're still serving lots of bytes and you're still using up the right amount of CPU, but the bytes you're serving are all wrong. And so this application is intended to catch the sorts of errors that other monitoring systems won't catch. So it's worth noting that the tests that it runs are application specific. So for each of the applications that we provide a corresponding test that knows how to talk to that application, what responses to expect back, and how to tell if it's actually gotten a bad response. I guess the other thing to note is that even from a protocol standpoint, it acts like a real client. It talks to services across the network, not from the local machine. So it'll catch, for example, network connectivity failures, and it speaks the same protocol it speaks. So it speaks WTP. Then this data is fed up to the monitoring console via like SNMP, a standard management protocol. It's worth noting that we don't sell a management console. We don't provide a user interface for monitoring the health of the service. There are third parties that sell these things. HP is the one that we work the most closely with, but CA and Tivoli are other vendors. From a 1.0 standpoint, it looks like the 4 showcase customers are likely to all end up using OpenView. They either have a preference for OpenView or they're asking us what we recommend. So if we can steer them all to OpenView, we're in a pretty good position, because then we can go out and we've been talking with OpenView over the last few weeks. We're talking with HP, and we're going to work with them to make sure that we integrate well with OpenView. And so I think it's a good direction to steer customers. That said, all the protocols that we use for gathering management and information are standard protocols. We use a simple network management protocol, and we use web-based enterprise management, which are both widely supported by consoles. basically SNMP is the traditional protocol that's been used for many years. WebM is a new protocol that's more functional and that Microsoft is kind of back. And so we're doing some combination of the two. The last area I really want to talk about is logging. I think Joy probably covered some of this. I noticed a lot of correspondence between her slides and mine in this area. All the servers in TV Server keep a very detailed record of what they do when they're running. So every time a user fetches an image or an HTML page, every time a client hooks up to CCS and downloads a release of the software or an ad, a log is recorded that indicates what happened. So it indicates what the client did, what the client requested from the service, and when appropriate, it indicates some other things like how did the user get there. Whenever the user goes to a web page, we log not only where they went, but where they came from. And if you string those together, you can actually understand a lot about user behavior because you can understand the path they take through the service. It's like, do users get to mail from the home page, or do they get to mail from mail to URLs? You can understand a lot about what features of the service people are using. We get the client log information about how long it spent on a given web page. So not only do you know where they went, you know how long they spent there, which can be important if you want to, once again, understanding usage patterns, understanding how long certain ads are on the screen. You also have things that are useful when you want to look back at reliability of the service, like did the operation succeed? You can go back and look historically and understand the number of failures.
In that context, can you define operation?
Yeah, typically an operation is an HTTP transaction. So it's an HTTP GET or POST. There are some other things that count as operations. For example, a session with the client configuration server is an operation. And there are some kind of artificial operations that we create just as ways to log data. So the philosophy is actually to get as much data into this log as we can. So we'll periodically log information about the health of the server to this log, and we'll write that in as a transaction to the log, even though it's not really an operation. Pretty much anything the server does, we try to find ways to log stuff its health when the data volume is appropriate. There are a lot of things that count as operations. So the other thing we log is some performance data, like how long did the operation take and how much data did it send down. So using these logs, historically, you can do a lot of different kinds of analysis. You can understand what traffic patterns look like, what the error rates look like what the response times look like, what the load looked like. So for capacity planning, this data turns out to be quite important. The client also does a lot of logging. We've been working with client to make sure that the client logging and the server logging work well together. So some of the client logs that are important is the configuration log, which is called the phone log for historical reasons, which records data like when did the client connect to the service, when did it power on, when did it power back off, and also a bunch of configuration information, like were there any peripherals connected. I actually, in this area, I don't know exactly what the set of things that set-top boxes will record, but if they have printer ports and they can tell whether a printer is attached, they'll log that. If they have Ethernet ports, they'll log whether those were in use. We log whether a remote has been used, whether a remote keyboard has been used, so you can understand a lot about what peripherals customers have in their homes. There's also the TV log, which I think Joy talked about, which is a very important log. It tells you everything that happens with the tuner. So when does the box change channels? And then we also can know what were they doing on the remote. So reconstructing the Nielsen ratings is an interesting challenge because we have the same problem Nielsen does. You don't actually know whether the TV is powered on or whether the person's sitting in front of it. All you know what channel it's tuned to. But you do know if there's someone clicking the remote, either they're sitting there watching TV or their cat's walking on the remote. And so ignoring the cat problem, knowing the last time they touched the remote is an important thing in terms of guessing what their viewing habits are. So the client keeps track of all that. What was the tuner doing and what was the remote doing? Based on that, you load that stuff into the warehouse, you apply some heuristics, and you can do a decent job of figuring out people's habits. In particular, there are some really interesting problems that we could solve. You could ask the question, during the Super Bowl, when some particular obnoxious ad comes up, how many people turn away? Right? We have all the data for it. That was one that a cable company brought up. That, it's a sort of interesting thing to study. What do users do when ads come on? Do they turn away? Which is something that not even Nielsen can really tell, because they track your usage on a more like program-by-program basis, not like what do you do during the ads? Do you flip away or do you stay? The client logs, it's crashes. Anytime the client crashes, it tries to save some stack information on the way down. Yeah?
Yeah, and where is the data logged specifically?
Well, so far, it's logged to the client disk. I'm going to talk in a minute about how we get the data. Well, the client non-volatile storage. So either the flash or the disk, or if I guess all the clients in question have either flash or disk. So.
So it's stored in the client storage area, and then we get it and we put it somewhere.
Yep, that's right. Yeah, we'll get it on the next slide. And then there are also application logs. Various applications can log data about their own failures. And this is mostly for use for applications that are developed to go on the client. Anything that an OEM of MSTV client wants to write can log data. In terms of getting the data up to the service, it's sent up client configuration server that Dave was talking about. And it's worth noting that's a general mechanism. So if a customer does write a custom application on the client, the same mechanism can be used to gather logs. They don't have to write new log collection code. So it's up to the service via the CCS. And then we've been negotiating with the client team. What's going to happen is the log comes up to the service, and there will be a converter that takes the log that's in the client format and converts it to match the server format and logs it to the server log. And so in that way, we can support logs in a bunch of different formats, and we don't have to write a bunch of server code that knows about the formats. So it's just a pluggable architecture where you install a DLL for each kind of log. So if a MSTV licensee develops a new log format, then they just need to supply the service with a converter DLL, and the service will be happy to convert their logs and log them to the MSTV log. So, oh, go ahead.
It doesn't stay in TV server log. It stays in some database storage.
That's right. Yeah, and that's even next slide. So the data starts out, some of the data starts out on the client disk, some of the data starts out on the server disk, the logs that are generated by servers. So all those logs get put into a big log that's on the disk of the individual server machine. So in a server arm where you've got 150 front-end machines, all 150 have a big log of all the stuff they've been doing recently. Those logs aren't very useful scattered around 150 machines. You need them to be centralized. So there's a log aggregator that goes out and talks to all of the front-end machines and gathers their logs in pretty close to real time. Talking to them all the time. You know, during a load spike, it might get a little bit lagged, but it generally tries to keep them up to date. The reason that they're logged disk on the client first actually is just from a fault standpoint. Connection fails if the aggregator has a problem for a few minutes. The clients, the front-end machines will keep logging to disk, and then when the aggregator comes back up, it'll connect to them and it'll say, hey, give me your logs as of the following time. It'll pick up where it left off and get the logs. But in practice, we try to get them up to the aggregator pretty quickly. So there actually are some things you can do with the aggregator that you can't do with the data warehouse that we do in the telcos, and I suspect that some of it will be interesting in the cable world. We can see in pretty real time what the service is doing. You can, if you're trying to diagnose a problem, you can watch the activities of a particular box, so you can see it try to connect and the errors it's getting back. If you want to understand the health of your cable network, you can look for errors that clients are having. For example, the client team is trying to figure out the right set of network diagnostics to send up. So lost packets or problems with the DOCSIS cable network. And so if they can send that data back up, then in real time you can, out of this stream of logs, you can find out what sorts of failures the client's seeing, and you can understand if there's a systemic problem in your cable network. So we're providing the mechanism for doing that. We don't actually want to have tools for diagnosing cable network failures and for correlating things. There's a general mechanism for telling the service that you want to see all the logs in a particular area, like you want to see all the client error logs. And then on top of that, you can build tools that will correlate them, which actually the folks who run the telco service have done in a couple instances. Like they study the health of the dial-in ports, for example, in this way. They grab the logs in real time, they stuff them into a little SQL database, and they can run reports in real time and see which dial-in areas people have been dialing, which ones they've been succeeding, which is actually pretty similar to the problem of understanding a cable network failure. So now we've gotten the logs from the client, from the servers, they've gotten onto the aggregator. The next step is to get into the warehouse. That's not a real-time process at present. The warehouse gets loaded in a batch mode. The US service and I suspect the ONE cable service both do that nightly. So every night we run a batch that goes through the day's logs, it converts them into a format that the warehouse understands, and then they get loaded into the warehouse. So finally in the warehouse we have much more sophisticated analysis capabilities. Not every bit of data goes in there, so there are still some things that you need to go back to the logs for, but Joyce worked hard to make sure that all the stuff that we expect for business analysis makes it into the data warehouse. And that is all that I had on my list. Have you got any questions about any of those other broad areas? It's been a long day.
Thanks.
No problem.
That's it.